So good evening everyone, and we will start with the session of reinforced cement concrete. Today I'll take up very beautiful questions which are not covered in either in previous years. So this will be a very set of very unique questions. I'm sure you will enjoy these questions. I hope the audio and video is clear. Please comment me. Good evening everyone. Good evening. अंकुर प्रकाश, गुड इवनिंग. तेज प्रकाश. अभी सिर्फ और सिर्फ आरसीसी वी विल टेक द कॉन्सेप्ट्स ऑफ आरसीसी गाइस. ओके, the concepts of RCC. Very good evening everyone. So we will start with the session. We have started the session for reinforced cement concrete RCC. Okay, reinforced cement concrete. These are the revision session. Okay, reinforced cement. All the concepts will be covered. All the questions will be covered in this session. Okay, complete RCC will be covered. Okay, so all the concepts, all the codal provision, I have designed question in such a way that all the questions are being covered. So all concepts will be covered. All concepts will be covered. Okay, so these are the revision session. These questions will help you to crack examination like these. Questions will help you to crack the examinations like RRB JE. I have designed these questions in such a way that you will be able to crack RRB JE as well as different state AE and JE exam, state AE and JE examination. Okay, one thing is to be remembered is while solving these questions, you don't need the use of calculator. Okay, please don't use calculator while solving these questions. Understood? Thank you bhai, thank you so much yaar. Thank you so much. Start करें session. Shall we start? Shall we start the session? No worries. No worries. These are such beautiful questions. I have framed these questions. Okay, in order to see that the expected question of RRB JE as well as different state AE and JE examination. So shall we start? These are some beautiful questions that I have framed in last 1 month. Okay, so we'll start with the question. Let us see the first question. This is the first question. Everyone who are watching the live session, please answer the question. Answer the question. Then only you will be able to understand which mistakes you have been committing. Okay, attempt जरूर करना है, by which you will be able to understand what mistakes are you been committing. So these are all the questions which I'll take are some beautiful questions, and all the concepts will be covered. Complete RCC will be covered in next few days. Okay, this is a very good question. Okay, please put a star mark on this. Please put a star mark on this. Now I'll wait for answers. Then I'll dictate you what is the most appropriate answer. This is a very good question because generally in books what is written is the stripping time, in how many days you will remove the shuttering. Okay, but this is a very good question because in concrete you have mixed fly ash and admixture. Whenever the ingredient other than OPC is mixed in the cement, okay, whenever you have made the cement other than OPC, then the stripping values are changed. Understood? These stripping values are changed. Very good, Maya. Only one student have given the correct answer till now. Maya, very good, very good. The correct answer is, now please write down a note for this. I'll tell you, मैंने आपको बोला था all the questions will be very new questions. I personally have designed few of the questions, okay, by keeping in mind that most probably you will not get these questions in your notes also. Okay, this is a very good question. The stripping time for reinforced concrete slab, please underline slab, spanning less than 4.5 meter and using fly ash you have used fly ash as an admixture. When you have used fly ash as an admixture, the stripping times have changed. These stripping times have changed. Please write down, okay, vertical formwork. Please write down a note for this. Please write down a note. Now look very carefully. Whenever you are using the OPC, ordinary Portland cement, the stripping time will be for vertical formwork. For vertical formwork, the time for stripping is 16 to 24 hours. 16 to 24 hours. But when you have casted the cement other ingredient other than OPC, the stripping time will be for this vertical formwork, it is same 16 to 24 hours. 16 to 24 hours. Okay. Now for soffit. Okay. Soffit is for beam and for slab. Okay. Soffit is for beam and for slab. Okay. Soffit, it means for beam. Okay. Props are used. Okay. Props are used even after the removal of the formwork. Here for OPC it is 3 days. If you have used the cement other than OPC, it is 7 days. Please mind it, it is 7 days. It is 7 days. Okay, this is a very good question. Next is for beam. Okay, soffit for, okay, it is for slab, it is for beam. It is for slab, for beam. Okay, and the condition is after removing the formwork, props are used. Props are refixed or used. When you have used the OPC, it is 7 days. And when you have used other than OPC, it is 10 days. When you have used fly ash as admixture, it is 10 days. It is 10 days. This was asked in the question. This was asked. Understood everyone? This is a very good question. 99% student will fail to answer this question. The correct answer is 10 days. Again read the question. The stripping time for the reinforced concrete slab spanning less than 4.5 meter using fly ash as an admixture should be 10 days. Understood everyone? Now next is, this is soffit. Props are to be used. Now next is, now look very carefully. Props to slab. Now you have used, when you have removed the props also. Now for props for slab, span less than 4.5 meter, and here for slab span more than 5 meter, span more than 4.5 meter. These datas are bit different. Look very carefully. 7 days and 10 days, 14 days and 14 days. 7 days and 10 days, 14 days and 14 days. Now look, for slab, now this is for beam, it was not asked, it was slab, it was asked. Okay, for slab, now look very carefully. Earlier it was 7 days. Now when you have removed the props also, the vertical members you have removed below the formwork, the average days are 10 days. If you need to remove the props also for span less than 4.5 meter, okay, the stripping time, it means formwork and props are to be removed after 10 days. After 10 days, this was asked. Understood everyone? Understood? This was asked 10 days. Clear? Understood everyone? Okay, we'll move towards the next question. Please read out this question. Please read out. What is the correct answer? Similar concept we have seen just now. As per IS 456-2000, minimum period before striking formwork for vertical surface of the column. If nothing is given about the cement, we will consider the ordinary Portland cement. If nothing is given for the question for cement, we will consider this as ordinary Portland cement. 1 day, 7 days, 16, 14 days or 28 days. What will be the correct answer? What is the correct answer? Very, very good. Ankur Prakash, very good. Shilpa, very good everyone. The correct answer is even though for any type of cement, even though for ordinary Portland cement, also for any other type of cement, for vertical formwork, okay, for vertical formwork, like for column, like for wall, like for column, like for wall, okay, the stripping time is to remove the formwork is 16 to 24 hours. So 16 for 24 hours is almost 1 day. Okay, answer is option A. Option A is the correct answer. Understood everyone? Now we'll move ahead. Please read the question very carefully. Question number 3. Please read the question very carefully. What will be the correct answer? Also guys, if it is possible for you to please share these concepts or these session among your friend, because these questions will be beneficial for your upcoming examination. Please share it please share it. Okay, what will be the correct answer? What is the correct answer for this? Very good, Shilpa. देखिए, now look, consider the following strength of concrete. Okay, what is the correct answer? Cube strength. We know that cylindrical strength is 80% of cube strength. 80% of cube strength. Yes or no? Because of the Platen effect. Okay, so cube strength is less and cylindrical strength is more. Now in increasing order, so in increasing order, okay, cube strength will be cylindrical strength will be less, and cube strength will be more. Understood? So 2 will be before and 1 will be after. So 2 will be before and 1 will be after. Okay, so 2 1 will be the ratio. 1 2 is wrong. Okay, 1 2 is also wrong. So either C or D, yes or no? Next is 3 and 4. Now we have taken care of 1 and 2. Now look very carefully. Split tensile strength and modulus of rupture. Now look very carefully. Split tensile strength is less than modulus of rupture. So 3 will come before and 4 will come afterwards. 3 4 2 1 is option C is the correct answer. Option C is the correct answer. Understood everyone? 2p upon pi dl. Very good Vishnu, very good. The correct answer is option C. Understood everyone? Shall we move ahead? Okay, we'll move towards the next question. What is the correct answer? The effect of air entrainment in concrete is to, now you are using which type of admixture? Air entraining admixture. Air entraining admixture. Okay, you are using air entraining admixture. Now the purpose of air entraining admixture is to impart millions of air bubble in the concrete, millions of air bubble which act as a ball bearing. Okay, which act as a ball bearing. Now these ball bearing, they will help to overcome the friction. Okay, increase resistance to freezing and thawing. Yes, this is the correct. Which of these statement is or are correct? This is correct. Why? Because in the voids, in place of water there is air, so less chances of freezing and thawing. Option 1 is correct. Improve workability. Yes, these ball bearing will help to improve the workability. Option 2 is also correct. 1 and 2 both are correct. Now look very good. Decrease the strength. Yes, the only drawback of air entraining admixture is because in the void there are air, so hence the compressed strength will be reduced. So all the 3 are correct. It means what will be the correct answer? Option D is the correct answer. Understood? Option D is the correct answer. I hope it is clear. So all the questions that I have taken in today's session are very beautifully designed question, by keeping in mind that all the concept will be covered, as well as these questions are very helpful for your upcoming examination like RRB JE, like state PSC, AE and JE examination. Understood? Now moving ahead towards the next question. Look, next question. the minimum and maximum percentage of longitudinal reinforcement in column according to IS 456 2000 respectively. Now this is as per the new code IS 456 2000. The previous code was IS 456 1978. Now these longitudinal bars, okay, how much is the Neeraj? No. Look, this is for column, not for slab, not for beam. It is for column, not for beam. Understood everyone? Now look, the minimum, what is the minimum percentage in column? Minimum percentage in column is minimum percentage of reinforcement, okay, longitudinal reinforcement. Minimum percentage is 0.8%, okay, 0.8% of the cross section area. And what is the maximum? What is the maximum percentage of longitudinal reinforcement? We are asking about column. Look very carefully. Most of the student will give answer C because 4% is for beam. We are asking for column. Understood everyone? Most of the student have given the wrong answer. The correct answer is minimum percentage is 0.8%. And what is the maximum percentage? Maximum longitudinal percentage is 6% of the gross cross section area. Okay, 6% is the correct answer. Hence option D is the correct answer. Understood everyone? I want answer from each and everyone who are participating in this live session. Please answer everyone. And if it is possible for you, please share this session to your juniors also, as well as who all students are preparing for RRB, JEE and different state service examination. The correct answer is option D. Understood? Muhammad Anwar, you have given the wrong answer. Understood? It is not for, we are asking for column, not for beam. Hence option D is the correct answer. We'll move ahead with the next question. Now look very carefully. Option E. Now answer me. Now answer me. Very good everyone. The correct answer is, now we are asking about beam. Understood everyone? Now look very carefully. Maximum area of compression reinforcement. Now in the beam, if let us suppose this is the cross section of the beam, okay, this is the cross section area of the beam. These are tension reinforcement and these are compression reinforcement. These are compression reinforcement. Okay, so what is the maximum area of these compression reinforcement? These compression reinforcement should be maximum of 4% of gross cross section area. Okay, understood everyone? 4% means 0.04 times of gross cross section area, means this is the width B and the total depth is D. Total depth is D. Understood everyone? So this is the maximum area. We'll take the gross cross section area. Hence option A is the correct answer. Understood everyone? Good evening everyone. So likewise, thank you so much everyone. Thank you so much. Okay, we'll move ahead. We'll move ahead guys. We'll take the next question. Again, this is a very good question. Very good question. As per IS 456 2000, okay. We will definitely take the marathon session on this platform. Understood? Please answer it very carefully. Okay, as per IS 456 2000, minimum grade of concrete for plain concrete exposed to sea coast is. Now this is a very good question. for plain concrete. Now you are asked for plain concrete. It is not for reinforced concrete. Please mind it. It is for plain concrete. You need to be very careful while answering the question. My dear student, please be cautious, because I have designed the question in such a way that you will definitely commit the error in few of the questions. Please be careful. Please be careful. Neeraj, it is for plain concrete. The question is for plain concrete, not for reinforced concrete. Why don't you understand, guys? The correct answer will, very good, Shilpa. The correct answer is very good. The correct answer is, as per IS 456-2000, minimum grade of concrete for plain concrete exposed to sea coast. Plain concrete, okay, plain cement concrete. So for PCC, and this PCC is exposed to sea coast. Understood, everyone? It is exposed to sea coast. Okay, what is the minimum grade of concrete? The correct answer is, very good. The correct answer is M20. M20 is the correct answer. If in the question it is for reinforced concrete, if it is for reinforced concrete, then what will be the correct answer? For reinforced concrete, minimum grade of concrete, if it is exposed to sea, will be, if it is exposed to sea coast will be exposed to sea coast. Exposed to sea coast is, very good question. If it would have been the reinforced concrete, it will be M30. It will be M30. Understood, everyone? Here the correct answer is M20. Understood? Yes or no? Understood? We'll move towards the next question. Now, very good question. Now, this is a very simple question. Please be attentive while answering this question. According to IS 456-2000, the characteristic strength of concrete is defined as the strength of material below which not more than X% of okay, of the test result are expected to fall. The value of this is characteristic strength. Understood? Characteristic strength is the strength below which not, okay, so below which how much? Very good. 5% of the test results are expected to fall. Okay, so only 5 test results. If there are 100 test results, only 5 test samples are below this value and 95 test result will be above this value. Understood? So 5 will be the correct answer. Hence option C is the correct answer. Since here percent is written, if it percent is written, so the X value will be 5, not 0.05. Understood? Please don't be confused on option B and C. Here the correct answer is option C. Understood? Now we'll move ahead with the next question. The target mean strength of concrete mix for characteristic compressive strength of, what is the target mean strength? Target mean strength is for FCK. For FCK is M40. The characteristic strength is 40 megapascal, 40 Newton per mm square. We need target mean strength. So target mean strength is FT is equals to FCK plus 1.65 sigma. 1.65 sigma. Understood? For M40, what is the value of sigma? What is? Please don't use calculator. Apply your logic to get the answer. What will be the correct answer? Please don't use calculator. Understood, everyone? For 30 and above, for M30 and above, the value of sigma for M40 will be 5. It is 5. Understood, everyone? 3.5, 4 and 5. So it is 5. So target mean strength will be 40 plus 1.65 into 5. Understood, everyone? Yes or no? Clear? So what will be the correct answer? Now look, we will not get option C, guys. The correct answer will be now. If you don't have calculator, okay. Now look, if I now in order to simplify the calculation, please mind it. In order to simplify the calculation, if I consider this as 1.5, 1.5 times of 5 will be equal to 7.5. It is 7.5. So your answer will be more than 47.5. Which option have which option has 47.5 more? So 46.6 will not be correct answer, 45 is also will not be the correct answer, 49 will be greater, the correct answer is option B, 48.3. In order to simplify the calculation, I have considered this 1.65 as 1.5. Okay, so your answer will be more than 40, just more than 47.5. One of the option is just more than 47.5, hence option B will be the correct answer. Clear? So you need to apply the logic in your examinations. If calculator is not allowed, so you need to apply your aptitude in order to get the answer, rather than solving this as 1.65 into 5. Okay, understood? Clear? So hence option B is the correct answer, not C. Rajesh, option B is the correct answer. We'll move ahead with the next question. Okay. Now, according to IS 1343, the flexural strength of the concrete member having measured compressive strength of 50 megapascal, okay, will approximately equal to, now look very carefully, measured compressive strength. Now, we have taken the cube and we have seen the compressive strength as 50. So this will be treated as characteristic strength. This will be treated as characteristic strength as 50 Newton per mm square. 50 Newton per mm square according to IS 1343. Okay. Very good, Siddhanta. Very, very good. Good evening everyone. What will be the correct answer? The correct answer will be now, according the flexural strength, for flexural strength of concrete FCR, okay, flexural strength of concrete is equals to 0.7 under root of FCK. Okay, the FCK is given as 0.7 times of the under root of 50. Now look very carefully, look very carefully. We know under root 50 is little difficult. So what we'll do is, we will consider this as 0.7 under root of 49. So 49 under root is 7. So 7 means 7 of 70. Okay. Yes, very good. 7 into 0.7 is 4.9. So your answer will be little more than 4.7. So option A is correct answer. Understood? So you need to apply the logic. Logic lagana hai. Okay. Under root 50. Most of the student who thinks ordinary will leave this question. Why? Because sir, calculator is not allowed. How we will able to solve under root 50? You need to apply the logic as root 50 can be written as root 49, and it is square root of 7. Okay, so 7 into 0.7 is 4.9. So your answer will be just more than 4.9. That is option A. Understood? Jaldi aayenge bhai Prayagraj. Chaliye, we'll move ahead with the next question. Okay. The nominal. This is a very good question. This is very good question. Please answer it very carefully. The nominal cover requirement for meeting the durability requirement of mild. First is durability requirement. So you are concerned about durability requirement. Durability requirement. First is mild, then very severe, then mild, very severe, severe, moderate, then extreme. Please be cautious. First is mild, then very severe, then very severe, then severe, then moderate, then extreme. So the options here are juggled. Okay, extreme. So mild, moderate, severe. Please answer very carefully, guys. What will be the correct answer? No, most of the students have given the wrong answer. Most of the students given the wrong answer. I am shouting in front of you that all the questions are very good designed question. So you need to be very careful. Vaisak, you have given the correct answer. Very good, brother. You have given the correct answer. Now 20, 50, 45, 20, 50, 45, 30, 75. Hence option C is the correct answer. You getting my point, everyone? Understood? Option C is the correct answer. 20, 50, 45, 30, 75. So be cautious. Okay. Option A is not the correct answer. Most of the student in hurry will take option A. Understood? So you need to be very cautious while reading the question. Understood? Clear? We'll move ahead with the next question. Okay, please put a star mark on this because most of the students have given the wrong answer. Now look, this is also a very good question. Put a star mark on this. I am sure this will not be in your notes book. What will be the correct answer? करा देंगे भाई, बिल्कुल करा देंगे अनिल. What will be the correct answer? Yes, option B is the correct answer. Here you have given, most of the students have given the correct answer. Very good everyone. Okay, as per IS 456, the weighing or batching accuracy plus minus of the cement, aggregate, water and admixture. Look very carefully. For weighing the cement, okay, the accuracy will be plus minus 2%, okay, of the weight of the cement. For weighing the cement, the accuracy should be plus minus 2%, okay, plus minus 2%. Understood? Okay, plus minus. So this is the tolerance limit, plus minus 2%, okay. And for admixture, water and aggregate, okay, and for water and for admixture, okay, the percentage will be plus minus 3%, plus minus 3. So tolerance limit of plus minus 3% is accepted. Understood? So what will be the correct answer? Cement 2333. 2333 is option B. This is a very good question. Understood? Clear? Shall we move ahead? Option B is the correct answer. Now we'll move ahead with the next question. Look, Poisson ratio for concrete remains unchanged for concrete, not for steel. Okay, for concrete increases with richer mix, decreases with richer mix, none of these. This is a very good question in terms of concrete. What is the correct answer? Now look, I'll give you the details. Now look, Siddhanta, very good Siddhanta. Only one student has given the correct answer. Very good. Now look, for higher grade of concrete. Now look very carefully. For higher grade of concrete, the value of Poisson ratio is 0.1. Okay, and for lower grade of concrete, it is observed that the lateral strain are more, okay, as compared to the lateral strain for higher grade of concrete. For lower grade of concrete, it is 0.2. So look, as the rich is increasing, as for richer mix, the value is decreasing. So decreases with richer mix. Option C is the correct answer. Option C is the correct answer, guys. Please mark it as a star mark. So for richer mix, the value of Poisson ratio decreases. Hence, lateral displacement for higher grade of concrete, the lateral displacements are less, and for lower grade of concrete, the lateral displacements are more. Understood? Option C is the correct answer. Okay, please put a star mark on this because most of the students have given the wrong answer. We'll move ahead with the next question. I told you in the starting of the session only that all the questions that I'll take up here will be very good questions. Okay. Next question. This is a simple question. I am sure most of the students will give the correct answer. And just a moment. Now answer me. In the next class, I'll give you the scanner for my Telegram group. Okay. What is the correct answer? Yes, very good. Most of the students have given the correct answer. In the designation of concrete mix, the letter M. Now, if let us suppose I have written M20, so this M represent mix. Okay, and this 20 represent, okay, this 20 will represent the characteristic strength. The characteristic strength of concrete. Okay. Clear? Mix and characteristic compressive strength of 100 mm. No, it is not 100 mm cube, it is 150 mm cube. Mix and characteristic compressive strength of 75 mm cube. This is a wrong answer. Mix and characteristic compressive strength of 150 mm cube at 28 days. Okay. Now look, if for bolt, let us suppose I'll tell you that I have a bolt of M16 grade. So here this M represent. Can you answer me? If for bolts, for example, I have tell you that I have used 4 bolts of M16 grade, okay, of FE 410 grade. So what is this M represent for bolt? Can you answer me? If it is written M16 for bolt, what is this M represent for bolt? I'll give you the option. M is mix, option B metric. Okay, yes, very good. This is metric. Okay, no, this 16 is dia of bolt. This M represent metric. Understood? This M represent metric. No, understood? This 16 will represent diameter of the bolt, but this M represent metric. Understood? Okay. Now we'll move ahead with the next question. This is a simple question. Answer it. The relation between modulus of rupture FCR and characteristic compressive strength FCK is given by. Just now we have solved one of the question on this. What is the correct answer, guys? What is the correct answer for this? Very good question. Now here none of the options are correct. If it would have been FCR, okay, it is also known as modulus of rupture or flexural strength, okay, it is equals to 0.7 times of under root of characteristic strength. 0.7 times of, yes, this is a typing mistake, okay, this is a typing mistake, but yes, this is the answer. Understood? We'll move ahead with the next question. Concrete exposed to severe freezing and thawing condition shall be classified as exposed to. This is a good question. Answer it, guys. Very, very good. Now look, the correct answer is very severe. Now we have mild condition, mild, moderate, severe and very severe. Now mild is prevent from weather, okay, prevent from all type of weather, prevent from weather, okay, exposed to severe rain, okay. Next is here exposed to very severe freezing and thawing. Very severe. Yes, the correct answer is very severe. The correct answer is very severe. Now, whenever concrete is exposed to, good evening Sachin, concrete is exposed to freezing and thawing condition because of the temperature variation. If the temperature falls below 0 degrees Celsius, it will be freezing of the water in the voids, and then if the temperature exceeds, then there is a thawing. So it is very severe condition. Understood? Because the stresses will be cyclic in nature. Hence, the correct answer is very severe. Clear? Understood everyone? Very severe is the correct answer. Next question. This is very good question. I told you this is a very good question. Underline this question. In reinforced concrete construction, the structure in which marked changes in plane dimension take place abruptly shall be provided. If let us suppose there is one member and there is another member with different cross section. Understood? With different cross section. Now, which type of joint will you provide? Here, when two structure with different dimensions are joined, we always provided with expansion joints, guys. We always provide with expansion joint. Also write down, if the RCC structure is more than 45 meter long, one or two expansion joints are provided. One or two expansion joints. Okay, one or more than one expansion joints are provided. Understood everyone? Understood? So this you need to be very careful. Whenever two members which have different cross section, which have two different dimensions in one plane, okay, then we will provide expansion joint. Also, if the member is more than 45 meter long, one or more than one expansion joints are provided. Namaste bhai, namaste. We'll move ahead with the next question. Understood? If it is more than, now look, if it is more than 45 meter, okay, if length is more, what is the stress? L alpha delta T. Now, if the length is more, the stresses developed will be more. Hence, we will divide them into expansion joints. Clear everyone? Also, whenever two members which are meeting, which have different cross section, then also we provide the expansion joint. Understood? Moving ahead with the next question. This is also a very good question. Please answer it very carefully. Answer it, guys. Very good question. Now look, in a reinforced concrete section, as the percentage of steel increases, okay, the depth of neutral axis decreases, the lever arm increases, both depth of neutral axis and lever arm decreases. Now look, I'll give you one of the example. Look here, this is a balance section. Okay, this is the balance section in this balance section, look, in this balance section, this is the neutral axis. This is the neutral axis. Understood? Now, when you have increased the reinforcement, the tension reinforcement, let us suppose we have increased the tension reinforcement, what will happen is the neutral axis will shift down because more area will be there to resist the tension. Understood? Understood everyone? So clear? So as the area of the tension reinforcement increases, the neutral axis will shift down. Comment about the lever arm. Lever arm is fixed. Lever arm will not change. Clear? So here you can see very carefully. Understood? You can see very carefully the depth of the neutral, as the depth is measured from the top. Depth is measured from the top. In this case, this was XU balance. So here this is the actual depth of neutral axis. Okay, understood? As the percentage of the steel increases, the depth of the neutral axis increases. Option B is the correct answer. Clear? We'll move with the next question. Next. This is also a very good question. Please don't use calculator while solving this question. Please don't use calculator. Very good question. Answer it. Please don't use calculator. If the permissible compressive and tensile stresses in a simply reinforced beam are permissible compressive stress, okay, sigma CBC, okay, is 20 megapascal and sigma ST is 250 megapascal. If the neutral axis depth is limited to 0.3 times of the effective depth, XU is, no, Siddhanta, 0.76 is not the correct answer. Answer it very carefully, guys. Now in the question it is given as, this is a very good question, FCK. The characteristic strength of the concrete is 20, okay, and Fy is 250 megapascal. And in the question it is given that the depth of the neutral axis is 0.3 times of the effective depth of the neutral axis. So in the question XU by D is given as 0.3. It is given as 0.3. Now you are asked that then the percentage area of the steel required. Now we know that the compression area is equals to tension area, or the compression force is equals to the tension force. We can write it down as 0.36 FCK XU into B is equal to XU is equals to 0.87 Fy into AST. Fy into AST. So this equation holds good. 0.36 FCK B into XU, 0.87 Fy into AST. So compression force is equals to tension force. Now look very carefully. Now we need to find the percentage of the steel reinforcement. So this is equals to AST upon BD. AST upon B into D. Now B is taken here, as well as you need to multiply and divide by D. Multiply and divide by D. Okay, divide D by both sides. Now look very carefully, in this equation divide D by both sides. So D we have divided here, D we have divided here. Now this equation will be written as AST upon this B will be taken here, B into D. B into D is equal to what will be 0.36 FCK into XU. Now here in the denominator XU by D. So here it is 0.87 Fy. 0.87 Fy. So now 0.36, what is FCK? FCK is 20. Now XU upon D is 0.3. It is 0.3 upon 0.87. 0.87 into Fy is 250. So this is your answer. If in the percent, if you need to find out this in percentage, multiply it with by 100. Multiply it with 100. You will get the answer. Now look very carefully. This is 0. Okay, and this is 4. This is 4. This is 4. This is 4. 4 2s are 8. Okay, 4 2s are 8. Now look very carefully. Your answer will be, without calculator you need to solve the question. Look, 4 and this 2 is 8. 8 means this 8 means it is, if it is 0.8, if it is 0.8, this is 0.1. This is 0.1. Okay, 0.1. So your answer will be 0.99. It is roughly around 0.99. Okay, 0.9. So 0.9. Your roughly option will be 0.9. 0.9 percentage. So 0.9 percentage is option D. 0.9 percentage is option D. Understood? Clear? So this was asked. So this is a very beautiful question. Okay, the only logic was XU upon D was given as 0.3, and you are asked about percentage of steel reinforcement AST upon BD, and in the percentage multiplied by 100. Clear? This is a very good question. Please note down this question. Okay, we'll move ahead. We'll move ahead with the question. Next question. Answer this. Which of the following statement is correct? So which of the following statement is correct? Answer this question. Which of the following statement is correct? The factor of safety for steel is lower than that of concrete. What is the factor of safety for steel? What is the factor of safety for steel? And what is the factor of safety for concrete? Since concrete is manufactured at the site, hence more factor of safety is given, 1.5. And what is the factor of safety for steel? Because steel is manufactured in industry, more quality control is there. So factor of safety is less, 1.15 and 1.5. So what will be the factor of safety for steel is lower than that of concrete. For steel is higher. So the factor of safety is same. One of the option is correct. Option A is the correct answer. Option A is the, understood? Option A is the correct answer. Clear everyone? We'll move with the next question. Look. As per IS 456-2000, side face reinforcement shall be provided along the two faces of the reinforced concrete beam when the depth of the web exceed. Now look very carefully. Side face reinforcement. If this is the depth, if the depth of the beam is more than how much? Side face reinforcement. These are the compression reinforcement. These are tension reinforcement. So here side face reinforcements are provided. Side face reinforcements are provided. Understood everyone? If the depth of the beam is more than 750 mm. 750 mm. Understood? These are the side face reinforcement. Clear everyone? Yes. These both are side face reinforcement. And what is the area of the side face reinforcement? What is the area of the side face reinforcement? These are 0.1% of web area. 0.1% of web area and a maximum spacing of, and the maximum spacing of the side face reinforcement are center to center spacing of 300 mm. 300 mm. Maximum spacing is center to center is 300 mm. So please note down these 2 points also. Option B is the correct answer. Understood? Clear everyone? We'll move with the next question. Now, next question. मजा आ रहा है सेशन में? I hope you guys are enjoying the session. Yes or no? I hope something new is being learned from this session. Yes or no? This is a very simple question. In a cantilever beam, tensile or main reinforcement is provided. In a cantilever beam, look, we are asking about cantilever beam. Okay, so in cantilever beam, okay, whenever the load is taking place, you can see these two fibers comes closer. So below the neutral axis compression takes place. Okay, and above the neutral axis tension takes place. So tension above the neutral axis, compression below the neutral axis. In a cantilever beam, tensile or main reinforcement is provided. So concrete is weak in tension, and in cantilever beam made up of concrete, the tension reinforcement are provided above the neutral axis. Understood? On the top or the upper face of the beam, option B is the correct answer. Clear? On the bottom or lower face, no, this is a cantilever beam, option A is not the wrong. On both top and bottom of the beam, in the middle of the beam, the correct answer is option A. Clear, everyone? Now, moving ahead with the next question. This is also a very good question. As per IS 456-2000, when HYSD bars are used, the minimum reinforcement in either direction of slab is minimum reinforcement of slab. Okay, when HYSD bars are used, this is also a very good question. On both side means longitudinal bars as well as lateral bar. For example, longitudinal bars, this is a slab and reinforcements are provided also on this side also. Lateral bars on both the side. What will be the correct answer? Minimum reinforcement in either direction of slab is very good. When HYSD bars or now look, when you are using HYSD bar or wire welded bars, please note down also in IS 456 clause number 26.5.2.1. 26.5.2.1. This is the clause along with HYSD bar, and it is also written as along with welded wire fabric. If you have welded fabric wire is used, also the minimum reinforcement is 0.12% of the total cross section area. If mild steel is used, what is the minimum percentage on any direction is 0.15% of the gross cross section area. Hence, in question, option B is the correct answer. Okay, we'll move with the next question. Please answer the next question. The maximum compressive strain in concrete. This is a very good question. Okay, here I'll tell you three data will be taken care here. Very good. Very good, guys. Very good. The maximum compressive strain in concrete in axial compression. Now look, this is the structure. Concrete is subjected to axial compression. The maximum compressive strain here, axial compression. Here, bending compression. Above the neutral axis, bending compression. Okay, bending compression. But here, no reinforcement have given. Understood? No reinforcements are given. If no reinforcement is, it is a plain cement concrete, it will be shrinkage. Here, shrinkage strain will be there. Understood? Shrinkage strain will be there. shrinkage strain will be there. So maximum compressive strain in axial compression, maximum axial strain, maximum compressive strain in axial compression. Then bending compression, then shrinkage, strain due to shrinkage. So your answer will be 0.0003, okay, 0.002 and 0.035. Understood everyone? Zero 0.0035, 0.0003, 0.002. Clear? Clear everyone? So these three you need to remember. Axial compression, maximum compressive strain is 0.002. Bending compression 0.003. So concrete will fail when the strain in the compression is 0.0035. This will make use in the limit state method. And when no reinforcement is given, it is plain cement concrete. What is the maximum? What is the strain we need to take while designing? 0.0003. Understood everyone? So here the correct answer is option B. I hope you have understood these three data. Understood all the three data? Yes or no everyone? Clear? We'll move ahead with the next question. Answer it. For an under reinforced beam section, the neutral axis lies. For an under reinforced beam section. Now again, very simple question. It is a balance section. So in the balance section, the neutral axis is in such a way that the stress in the steel and stress in the compression steel occur simultaneously. If this is a balance section, okay, AST balance. Whenever so this is for balance section. Understood? So here sigma CBC permissible stress in concrete, or here sigma ST upon M. So both the stress in the concrete and steel occur simultaneously. But when you have given the reinforcement less than, so what will happen? This neutral axis will shift upwards. Neutral axis will shift upward. Whenever neutral axis will shift upward, what will happen? What will happen? The stress in the concrete is less than sigma C is less than sigma CBC. But here the stress in the steel will reach to its permissible value earlier than the concrete. Okay, clear? So it is same level below the critical neutral axis of the balance section. No, at mid depth above the critical neutral axis. Option D is the correct answer. Clear everyone? We'll move with the next question now. The additional cover. This is a very good question. Most of the student will give the wrong answer. Most of the student. If you have not solved the SSCD previous year question, this is a very good question. This is a very good question. Please consider option E also. Please consider option E also. Yes, very good. Only few students have given the correct answer. Mohammad Armar, Vaisak, very good. Option A is the correct answer. Look very carefully, dear. Look, the additional cover, you are asked for additional cover. Okay, additional cover thickness to be provided in reinforced concrete member that are totally immersed in seawater. Now for mild condition, look very carefully, for mild condition, the nominal cover is 20 mm. But when concrete is immersed in seawater, okay, when it is immersed in seawater, it is which condition? It is severe condition. And in severe condition, what is the nominal cover? Nominal cover is 45 mm. So 45 mm, how much is 45 is greater than 20 mm. So if you add 25 mm, to 20 mm, you will get 45. So how much additional cover you have given? 25 mm additional you have given. Yes or no? Understood? This is a very beautiful question. This is taken from SSC JEE. Clear? This is a very good question. I have taken this question from SSC JEE. Clear everyone? We'll move with the next question. Answer it. What is the correct answer? Answer everyone. What is the correct answer? Alan, very good. Almost everyone have given the correct answer. Very good everyone. The question states that the minimum grade of concrete to be used in RCC, minimum grade of concrete, okay? Minimum grade of concrete used for RCC, okay? So minimum grade, whenever you are casting reinforced cement concrete, minimum grade of concrete is M20 as per the new code IS 456-2000, okay? And for pre-stressed concrete, it is, if you are making pre-stressed concrete, and for post-stressed concrete it is M30, and for pre-stressed concrete it is M40. Now look very carefully, this is as per IS 456-2000, okay? But in one of the state surveys it was asked that as per IS 456-1978, so minimum grade of concrete was for RCC, minimum grade of concrete for RCC, it was M15. Please mind it, this was asked in one of the examination. Understood? Clear? So here your correct answer is option C. Here the correct answer is option C. This was also asked in one of the examination in PSUs. I think it was asked in one of the PSUs. Most probably it was asked in Coal India Limited, CIL. Clear everyone? Minimum grade of concrete for RCC as per the old code, it was M15. Clear? We'll move ahead. Now, the factor used to account for the difference in strength indicated by cube test and the strength of concrete in structure. This is also very good question. Since we test the compressive strength in the cubes of dimension 150 mm, but actually we cast the structure on slab, on beam, yes or no? So if understood? Now if the characteristic strength is FCK on cube, this strength of the concrete, if we cast this on the other than cube, this will be considered as Very, very good. The correct answer is, we consider this as 67% of characteristic strength. 67% of characteristic strength. Understood everyone? Now look very carefully. The factor used to account for the difference in the strength indicated by cube test and the strength of the concrete in structure. Since we test the cube and we get the value as FCK, so for structure we consider this as FCK. On this 0.67 FCK, we apply the factor of safety of 1.5. That is why we get. Understood? So what is the difference of this 0.67 under root divided by 1.5? .45 FCK, yes or no? That is why we get this value as 0.45 FCK. This we use as a design value. This we use as a design value 0.45 FCK. So here the correct answer is 0.67. Clear? But in case of steel, we don't take this as for steel also. For Fy only we apply the factor of safety as 1.15 as 0.87 Fy. This is the design value. This is the design value for steel. And this is for concrete. This is for concrete. Understood everyone? Clear. We'll move ahead with the next question. This is also a very good question. I'm pretty sure that you won't get the data of this question in your notes. हाँ, yes, आपने सही किया विष्णु. All the questions are designed for your upcoming examination. Most probably you'll get the same question in your RRB JEE examination. Most probably you'll get the same question. What will be the correct answer? Please make a star mark on this. Now look, according to IS 456, I'll give you the clause number, table number 6. So this is in IS code, IS 456, table number 6. Table number 6. If the maximum aggregate size is increased from 20 mm to 40 mm, the minimum cement content requirement changes. Yes, it changes. Yes. Now look very carefully. If the nominal size of aggregate are 10 mm, if it is 20 mm size of the aggregate, adjustment in the cement content, adjustment in the cement content, adjustment in cement content, adjustment in cement content, kg per meter cube, kg per meter cube. And if the nominal size of aggregate are 40 mm, now look, this is 0. If the nominal size of aggregate are 20 mm, no change, no adjustment in the cement content there. Clear everyone? Now if the nominal size of aggregates are 10 mm, what you will do is, you will add the weight of the cement plus 40 kg per meter cube. If the average size of aggregates are 40 mm, you will readjust the cement content, that minus 30 kg per meter cube. For example, 3 meter cube of concrete is to be casted, then 90 kgs is to be deducted from the design value. Clear? So for 10 it is plus 40, for 40 mm it is minus 30. So your answer will be option C. This is table number 6. Please note down, this is table number 6, adjustment of the concrete. Understood? I told you that you will gain the knowledge from my lectures, from my past 13 years of experience. Okay, I know that which data is missing in your note copy. So that is why deliberately I have taken these datas. Clear everyone? And mind it, these are the sessions for AEJE. Okay, for PSC examination. If it would have been for GATE examination, I have taken the different concepts. I would have taken the different questions. These sessions are for purely for AE and JE. Clear? And I'm using English language. Why? Because most of the students are from Kerala and most of the students are from Tamil Nadu and Karnataka. Okay. I hope the language is not the barrier for any student because the questions are written in English. Okay. We are moving ahead. Next question. Next question. Answer the question. Now, last 10 question according to IS 456 under normal circumstances. Normal circumstances means you have not added fly ash. You have not added the fly ash. Okay, the maximum cement content in kg per meter cube, not including fly ash and slag allowed is. Under normal circumstances, the maximum cement content. Okay, what is the maximum? Not including fly ash and slag. So the maximum cement content is 450 kg per meter cube. This is the maximum that you can add. 450, option C is the correct answer. Under normal condition. Clear, everyone? And it is given in the IS code. Please don't say this is not recommended in the IS. I'll give you the clause number. So this is clause number. This is clause number. The maximum value is given in the clause number 8.2.4.2. This is the clause number. Clear, everyone? Option C is the correct answer. Okay. One concept we have seen in the first question also. Please answer it. A flat slab of span 6.45 meter. So here the span is more than 4.5 meter. Span here is 6.45 meter. It is more than 4.5 meter for slab. Okay. Was casted today afternoon. As per the recommendation of IS 456, the minimum time after which the props should be removed. So the props are also removed. Okay. If the props are also removed, what is the time after which the props are also removed? 7:10. Slab of greater than 4.5. Slab of greater than 4.5. Very, very good. If the slab you are using, okay, and props are to be removed. Props are to be removed. Props are to be removed. Okay, props are to be removed. Okay, this should be done after 14 days. And if OPC is used, if other than OPC is used, again it is also 14 days. Again it is also 14 days. Understood? If it would have been a beam, if it would have been a beam, comment the answer. If instead of slab, beam is given, then what will be the correct answer? If it would have been beams, props are to be removed. 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 Span less than 6 meter, span less than 6 meter, and span more than 6 meter. So in the question, span is greater than 4 meter. What will be the correct answer? Span less than 6 meter is 14 days. Span less than 6 meter is 14 days, 14 days. If the span is more than 6 meter, then what will be the correct answer? It is 21 days. Very good, Sachin. Very good. Very good, everyone. It is 21 days. It is 21 days. Please note down it is 21 days if it would have been a beam. Clear? Option D is the correct answer. Oh, sorry. If it would have been beam, it is 21 days. But here the correct answer is option C, 14 days. Understood, everyone? Understood? Okay, we'll move ahead with the next question. Please write. This is a very simple question. The flexural tensile strength of M25 grade of concrete as per IS 456-2000. The flexural tensile strength is modulus of rupture. What will be the correct answer? This is a very simple question. Please answer it. This is a very simple question. Please answer it. We will solve 40 questions in today's class. Okay. This is a very simple question. So 0.7 under root of 25, it will be 5, 3.5. 3.5 Newton per mm square. Option B is the correct answer. We'll move with the next question. Modulus of elasticity of concrete. Okay. So the ratio of stress by strain. Modulus of elasticity of concrete can be assumed as short term modulus of elasticity. Correct answer is 5000 under root FCK. 5000 under root of FCK. Okay, 5000 under root of FCK. Option D is the correct answer. Clear everyone? Yes, D is the correct answer. Now answer me guys, do you want PDF of this? Do you want annotated PDF? Do you want annotated PDF? Answer me guys. Whosoever is watching this session live, do you want annotated PDF? Or is it okay? Yes, this is short term static modulus of elasticity. If you want long term, okay, long term static modulus of elasticity, it is equals to short term static modulus of elasticity 1 plus creep ratio. Understood? This value of creep will be equal to 2.2, 1.6, 1.1. Yes or no? This theta value is for 7 days. If the loading is done after 7 days of the casting, this value is 2.2, and for 28 days and for 1 year. 28 days for 1 year, the value of creep coefficient is equals to 1.6, 1.1. Understood everyone? This is long term static modulus of elasticity. This is short term. Clear? Now we'll move ahead with the next question. Concrete in seawater shall be at least grade in case of this we have done. This we have done. If the concrete is in seawater, okay, if the concrete is in seawater, what is the minimum grade of concrete for reinforced concrete? Concrete in seawater. So minimum grade of concrete. Minimum grade of concrete. What will be the correct answer? Yes. This is, yes, this is for RCC, no? Option C. If it is for PCC, it is M20. For PCC it is M20. Clear everyone? Okay, option C is the correct answer. Now go ahead. Target strength for the mixed proportion FM is given by, so target mean strength is given by FCK plus FCK or FCK. Comment me about the answer. Comment me about this answer. FCK plus 1.65 sigma. 1.65 sigma. Now please remember value of sigma. Value of sigma for M10 and M15. For M10 and M15 the value of sigma is 3.5. Okay. For M20 and M25 the value of this is 4. Okay. For M30 and above. For M30 and above the value of sigma is 5. Clear? The correct answer is FCK plus 1.65 sigma. Clear? Now moving ahead with the next question. Nominal mix M20 concrete represents the nearest ingredient ratio. So the ingredient ratio is cement, sand or fine aggregate. Fine aggregate to coarse aggregate. to coarse aggregate. Okay, so please remember for M20, yeah, M15 for M20 it is 1:, what will be the correct answer? What is the correct answer for this? For M20 and for M25, please remember for these two value also. M15, M10. Very, very good everyone. The correct answer is option C. 1:1 ratio cement, 1.5 ratio fine aggregate and 3 ratio coarse aggregate. And for M15 it is 1:2:4. 1:2:4. And for M20 it is 1:1:2. 1:2:4. 1:3:6. Clear? Please remember these value 10, 15, 20. This is 25. This is 25. Clear everyone? We'll move ahead. Understood everyone? We will move ahead with the next question. We will complete 40 question in the session. Okay, last 3 question. Okay. Individual variation between tensile strength of sample should not be more than. So when you are testing for concrete, the tensile strength of concrete, individual variation, if there are more variation, we will reject the sample. So what is the variation? Maximum variation among the sample, if you are testing for tensile strength, is what is the correct answer? Very good Abhinand, very, very good everyone. The correct answer is plus minus 15%. So maximum variation is 15% of the average value. Please note down of the average value. Okay, if you have taken let us suppose 6 sample, take the average of this. If any of the sample is if have a variation of more than 15%, you will discard that value. Understood? So correct answer is 15% of the average. Next question. This is a very good question. Okay, mild, moderate, severe, very severe and extreme. Minimum, what is the minimum cement content? Minimum cement content. Okay, so the value for mild is 300 kg per meter cube. For moderate also 300 kg per meter cube. For severe it is 320 kg per meter cube. This is 340 kg per meter cube. And for severe it is 360 kg per meter cube. This is minimum. Please mind it, this is minimum. This is minimum cement content in moderately exposed reinforced concrete with nominal weight of aggregate 20 mm. Nominal size. Okay. The correct answer will be yes. Understood everyone? The correct answer is option D. D is the correct answer. 300 kg per meter cube. Clear? We'll take up the last question for today's session. Last question for today's session. This I have, in today's session, I have given the explanation for this. If you were attentive in the class, I have given the explanation for this question. What will be the correct answer? In today's session only I have given the explanation for this question. Muhammad Anwar, yes, you have given the correct option. Very good, Alan, very good. Vaisag, yes, this is the correct answer. Very, very good everyone. Now look, is as per IS 456-2000, normally structures are designed with one or more expansion joint exceeding. If the, now look, in the normal structure, if the structure length is more than 45 meter, one or more than one expansion joints are provided. Understood? Option A is the correct answer. So in today's session we will be solving questions of RCC which are important for your upcoming RRB JEE examination as well as for your state PSC examination. Okay. Okay. Now we will start the session, guys. Now in today's session we will be covering a few more questions of RCC. This lecture series will contain all the questions, all the concepts of RCC. Okay, and within a week we will be able to cover all the questions related to this subject. Okay, so our target is to finish all the concepts of, we will cover all the concepts of RCC within a week. Okay, in this week. Clear, everyone? So today I have taken the session at this time, but from tomorrow for rest of the days your class timing will be from 11 AM. Understood, everyone? Just for today I have taken the class at 1:30, but from tomorrow onwards for the rest of the 5 days, okay, we will cover the session and we will start the session at 11 AM. Will it be okay? Please comment, everyone. Will it be okay if I take the session at 11 AM? And trust me, guys, very good questions are being taken in these sessions. Okay, you will definitely, most probably you will get the question directly from these sessions. Okay, so these sessions are designed in such a way that most probably you will get the questions from these sessions only. Understood, everyone? So we will start the session. Okay, today's session, just for today, the session will be of will take around 20 questions, but from tomorrow onwards, okay, we will take the session such that we will cover more roughly around 50 to 60 questions in one session. Okay, so from tomorrow onward we will try to cover the questions such that we will be able to solve around 50 to 60 questions, and 2 hours dedicatedly we will cover the questions in 2 hours. Understood? So from tomorrow, that is, the date is 8th, from 8th of March, sorry, from 8th of April, your class timing will be from 11 AM. Understood, everyone? 11 AM. Most probably we'll cover the class from 11 AM to 12:30 PM. Okay, so 1.5 hour class will take from tomorrow onward. Okay, understood, everyone? So we will start the session. Okay, I'm waiting for answer for some questions. Look, first question for today's session. Answer it very carefully. Answer it very carefully. What will be the correct answer? Long-term elastic modulus in terms of creep coefficient theta and 28-day characteristics and FCK is given by. So in the question you are given with, this data. So what will be the correct answer? What will be the correct answer for this? Please answer it very carefully. Now short-term Young's modulus of elasticity is, for concrete is 5000 under root FCK. Okay, this is short term. Now when the effect of creep is taken, what will be the Young's modulus of elasticity for long term? Okay, for long term, okay, the Young's modulus of elasticity is short term upon 1 plus theta. Theta is creep coefficient. So when you are taking the long term, you need to consider the effect of creep. Understood, everyone? Now look very carefully. So this will be equal to 5000 under root of FCK, 5000 under root FCK upon 1 plus theta. So what is the value of theta? Yes, what is the value of theta? The value of theta depends upon age of the loading. Okay, age of the loading, 7 days, 28 days and 1 year. Okay, understood? Okay, so the value is 2.2, 1.6 and 1.1. For 1 year it is 1.1. Clear, everyone? So what is the correct answer? Option A is the correct answer. 5000 under root FCK 1 plus theta. Understood? Clear? Yes. So we'll move ahead with the next question. Answer the next question, guys. If sigma CBC is permissible compressive stress in flexure compression in service, the modular ratio is. What will be the correct answer? Now answer it very carefully, everyone. Is audio video clear? Now answer it, everyone. What will be the correct answer? Yes, very, very good. Yes, very good. Okay. Please make sure that from tomorrow your classes will be from 11 a.m. okay, from tomorrow your classes will be from 11 a.m. and please mind it, okay, these questions are specifically taken for your state PSC examination. Okay, if I would have taken these questions for gate examination, the question level are different. Understood, everyone? Okay. Okay, the correct answer is, what is modular ratio? Now, if sigma CBC is permissible compressive stress in flexure compression, the modular ratio. So modular ratio is defined as 280 by 3 sigma CBC. 280 by 3 sigma CBC. Understood, everyone? Okay. So option A is the correct answer. Now we'll move ahead with the next question. The permissible shear stress in concrete depends upon. This is a very good question. So there are two concepts, the permissible shear stress and maximum shear stress in concrete. So both the concepts are different. हाँ, लेवल बढ़ाएंगे भाई, नेक्स्ट क्लास से लेवल बढ़ा देंगे, ये बेसिक क्वेश्चंस हैं, ठीक है. सो जो स्टेट सर्विसेज, द मैक्सिमम स्टेट सर्विसेज हैव दीस टाइप ऑफ क्वेश्चन ओनली. Okay, so your speed matters in state services, your speed matters. Okay, so from next time I'll little increase the toughness level of the questions. Now what is the correct answer? The permissible shear stress. Now look very carefully, what is the permissible shear stress? Permissible tau permissible. Okay, so the permissible shear stress in the concrete depends upon two factors, that is grade of concrete, and percentage steel, but the maximum shear stress of concrete depends only on grade of concrete. Please make sure that permissible shear stress depends upon two values, the grade of the concrete and percentage steel, but your maximum shear stress on concrete depends only on grade of steel, grade of concrete. Understood, everyone? So here you are asked with the permissible shear stress, hence option D is the correct answer. Option D is the correct answer. Understood, everyone? We'll move with the next question. Answer it very carefully. This is a very good question. Now this is a very good question. Most probably you'll able to, please put a star mark, because most of the student will give the wrong answer for this question. Please read it very carefully. Now yield strength is 400 megapascal. Now if you have a steel of grade 400 megapascal, okay, now look very carefully. None of the, yes, what is the value of maximum allowable tensile strength? Maximum allowable, so what is the allowable strength? What is the maximum allowable strength? Maximum allowable strength is now tensile strength have two values, maximum allowable strength in axial tension. So what is the permissible value? 60% of yield stress. And for bending tension, maximum allowable strength in bending tension. So maximum allowable strength in maximum allowable strength in bending tension. Okay, in bending tension. So this value is 66% of yield stress. 66% of yield stress. So it multiplied 60% of yield stress means 0.60 into 400. So you will get the value as 240. You will get the value as 240 Newton per mm square. So only this option is correct. Hence you will get the value as 240. Option A is the correct answer. Understood everyone? Clear? Now we'll move with the next question. Answer it very carefully, guys. Now the question is the minimum clear cover to the main steel bar in slab, beam, column, footing. So clear cover. Now the minimum clear cover to the main steel bar. To the main steel bar. Okay. What is the clear cover? To main steel bar to slab, beam, then we have column, then we have footing, then we have column, then we have footing. What will be the correct answer? What will be the correct answer? These are standard value. These are standard value. So how much stress will you permit in the steel? That is 60% of yield stress. And how much, if let us suppose in steel bars, if there is bending tension, how much stress will you permit? Okay, that is 66% of yield stress. So what is the correct answer? What is the clear cover for slab, beam, column and footing? So for slab it is 15 mm. So what is the correct answer for this? Yes, very good. So for slab it is 15 mm. For beam it is 25 mm. For column it is 40 mm. And for footing it is 75 mm. So this much is the clear cover. This should be given to the slab, beam, column and footing. So 15, 25, 40 and 75 is option B. Option B is the correct answer. Understood everyone? Please make sure for flat slab, expert gaming, for flat slab it is 20 mm and for normal slab it is 15 mm. Now please make sure it is for flat slab. For flat slab it is of 20 mm. Understood everyone? Please don't confuse it. Clear everyone? Beam 25, column 40 and footing 50 mm. Understood? So please don't confuse about normal slab and flat slab. Only flat slab have the clear cover of 20 mm. Understood everyone? So that is why we have ticked option B. Now moving with the next question. Answer it very carefully. The desired characteristic strength of a mix is, the characteristic strength of the mix is FCK is 20 Newton per mm square. Okay, this is given in the question. The standard deviation given is 4 Newton per mm square. Okay, 4 Newton per mm square for 150 mm size of the concrete cube, and K value is constant 1.645. Okay, the average strength of the cube will be nearly. So this average strength is nothing but the target mean strength. So this is nothing but Fm is equal to FCK plus 1.65, or here we'll take the 1.65 and in place of 1.65 it is 1.645 into sigma. So this is 20 plus 1.645 into 4. Okay. So you can see very carefully, if I consider this value as 1.5 into 4 is nothing but 6. 20 plus 6 is 26. So you will get the value slightly greater than 26. Only one option is there which have the value slightly greater than 26. Hence option C is the correct answer. Understood everyone? So you, in the examination, you don't need to calculate each and every aspect. It is just an objective question. Okay. So consider this 1.645 as 1.5. So you will get the value as 6. So your answer is slightly more than 6. Hence you will get the option C is the correct answer. This is what is called aptitude. Okay. So in the examination where there is no calculator, you just need to apply your aptitude and reach to the answer. Clear everyone? We'll move ahead. We will move ahead with the next question. Answer it very carefully. This is a very simple question. Answer it. You'll get the answer. Very simple question. Okay, the value of creep coefficient of concrete at an age of 28 days loading is, now value of creep coefficient. We know that age of loading, it depends upon age of loading and the value of creep coefficient. So if 7 days, if you have applied the load in 7 days, the creep coefficient is more, 2.2. In 28 days, it is 1.6, and for 1 year, it is nothing but 1.1. So in the question you are asked about 28 days, the value is 1.6. Option B is the correct answer. Understood everyone? Clear? Option B is the correct answer. We'll move ahead with the next question. This is a good question. Please answer it very carefully. If no reinforcement is given in the RCC structure, if no reinforcement is given in the RCC structure after concreting, the concrete shrinks. Okay, so to consider the shrink, so what is the shrinkage strain in the concrete which is taken? So sometimes minimum reinforcement is provided, okay, to prevent the stresses due to shrinkage. So approximate value of shrinkage strain in concrete is, please answer. Yes, very good. 0.003. So correct option is option B. Okay, so shrinkage strain is taken as 0.003. So this is the correct answer. Option B is the correct answer. Understood everyone? We'll move ahead with the next question. Please answer this. The maximum compressive stress in concrete for design purpose is based on the partial safety factor of, so now in limit state method we apply the factor of safety to material strength also and to the load also. So what is the partial safety factor for concrete? Partial safety factor for concrete. So now partial safety factor for concrete strength is taken as, we divide the strength by 1.5, and for steel, since steel is manufactured in industries, the partial safety factor is less. How much is the value? 1.15. Here you are asked with concrete, hence option B is the correct answer. Option B is the correct answer. We'll move ahead with the next question. Please answer it. This is a very good question. Please answer it. This is a good question. In the 4th amendment May 2013 of IS 456-2000, M60 grade has been shifted to. Now look, there are 3 type of concrete as per IS 456-2000. There are 3 type of concrete: ordinary concrete, standard concrete, ordinary concrete. Ordinary concrete is of M10, M15 and M20. Okay, ordinary concrete. Okay, then we have standard concrete. Standard concrete, so M25. Now look, earlier, what is the correct option? Now look very carefully. Now this is M60. Now, M60, M25 to M60. Then we have high strength concrete. Then we have high strength concrete. Look very carefully. Yes, very good. M65 to M100. Now look earlier, so this is the amendment in 2013. Earlier, look very carefully, the standard, this M60 was in high strength concrete, but now this M60 has been shifted to standard concrete. Okay, now look, now in the 4th amendment May 2013 IS 456-2000, M60 grade has been shifted to, earlier it was high strength concrete, but now it is shifted to ordinary concrete, standard concrete from high strength concrete. This option A is correct. High strength concrete from high strength standard concrete from ordinary concrete. No, this is wrong. Ordinary concrete from standard concrete. Option A is the correct answer. Clear? So this is the amendment on May 2013. Understood everyone? Option A is the correct answer. Clear? Understood. Now we'll move ahead. Now next question. Next question is this. Answer it. The partial factor of safety for steel as per IS 4562. This is a very simple question. Just now we have said that partial safety for steel is as per IS 456 1.15. Okay. Why the partial safety factor is less as compared to concrete? Because it is manufactured in industries. Hence more quality control is taken care while manufacturing the steel. Hence partial safety factor is less. So what will be the correct answer? 1.15. Option A is the correct answer. Clear everyone? We'll move towards the next question. Answer it very carefully. The development length of each bar of 3 bars bundled together is increased by, okay, whenever what you have done is, you have 3 bars, okay, you have 3 bars, okay, these all are bundled, okay, or I'll show you the longitudinal axis. This is 1 bar, okay, this is 2 bar and 3 bars. These all are bundled, okay, these all are bundled. So when the 3 bars are overlapped and bundled together, okay, so development length are increased. How much it is increased? How much is increased? Answer it very carefully, guys. What is the correct answer? Very good. Now look very carefully. When 2 bars are bundled, now please note down, as per IS 456, when 2 bars are bundled, okay, the development length is increased by 10%. The development length is increased by 10%. Okay, when 3 bars are bundled, okay, when 3 bars are bundled, their development length increased by 20%. And when 4 bars are bundled, okay, when 4 bars are bundled, are clubbed together, okay, development length is increased by 33%. So since here 3 bars are bundled, your option B is correct. Option B is correct. Understood everyone? Yes. This is the correct answer. Okay. Now moving ahead with the next question. Answer it very carefully. Loss of stress with time at constant strain in steel is called relaxation, ductility, creep or shrinkage. Look, these 2 bars are bundled. Understood everyone? Overlapped. Now if we have 3rd bar also above it, so this is the bundle of 3 bars. So the development length increased. What is the correct answer? Yes, this is very good. Creep is the correct answer. Okay. So continuous deformation over a period of time, okay, because of the sustained loading, because of this there is a loss of stress, okay, with a constant strain, okay, in steel, it is called creep. Understood everyone? Option B is the correct answer. This is called creep. So creep initially increases with time, then it decreases. So initially we have elastic strain and then we have plastic strain. When you remove the load, Okay, all the elastic strain is been recovered, but some of the plastic strain is left. Okay, that is permanent deformation. Clear? Option B is the correct answer, that is creep. Now answer the next question. What is the correct answer? No, no, no. Answered. Now please look very carefully. I'm really sorry. In the previous question, I'm really sorry here. I have taken the wrong answer. I'm really sorry. The here you are asked with the loss of stress. You are asked with the loss of stress. Creep is the continuous deformation over the period of time. I'm really sorry. Please, I'm really sorry. The correct answer is not creep. Now look very carefully. I'll explain you how. Now let us suppose we have a bar. We have a bar. Okay. And on this bar there is a continuous load if there is a continuous load P. So whenever you apply the load P, what will happen? There is a elastic deformation. Thus the moment you will apply this P load, there is a elastic deformation of dx. This dx is nothing but elastic deformation. But over the period of time, because of this continuous load, what will happen? In this section you will have this, over the period of time, this plastic deformation, and it increases okay, it increases as the time passes. This dy is known as plastic deformation. So if we plot the graph of stress, so what will happen? Initially when you apply the P load, there is this much is the strain, but after a period of time, this much is the strain. So this is nothing but, this strain is elastic deformation, elastic strain. And you can see very carefully, this is nothing but a plastic strain. These strain are known as creep. Understood everyone? When you apply the load, when you have released the load, after removing the load, what will happen? This much of the strain is being recovered. Okay, and then afterward, few of the strain is also recovered. So this yellow curve indicates of unloading. So this much is nothing but elastic recovery. This much is known as elastic recovery, and you can see this much is known as plastic recovery. And this much strain is not recovered. This is known as permanent deformation. Understood everyone? So it is a time dependent process. As the time increases, the strain also increases. Which type of strain? This is permanent strain, plastic deformation strain. Understood? So this is nothing but the creep. This deformation is nothing but the creep. But whenever what will happen? Because of this creep, their stress is also generated. But whenever the strain recovered, when you remove the load, this elastic strain is recovered. So whenever the elastic strain is recovered, there is a loss of stress also. That is known as relaxation. The loss of stress is known as relaxation. So I misunderstood it. The loss of stress is known as relaxation. Please mind it. The loss of stress is known as relaxation. Understood? Option A is the correct answer. Whenever you find loss of stress, you'll get the answer as relaxation. Understood everyone? So continuous deformation over the period of time is known as creep. Okay, but during the creep, if there is some loss of the stress, so that is known as relaxation. And what is ductility? Ductility is nothing but ability of material to deform into wires. Okay, or technically we say that if material have more than if material have more than 5% post elastic strain. Post elastic strain means plastic strain. Then only you will be able to deform them into wire. Okay, that is ductility. Understood everyone? So relaxation is the correct answer. Now moving ahead with the next question, please answer it very carefully. Why is minimum tension steel is provided in a reinforced concrete? This is a very good question. Every time you will see in beam also we will provide the minimum reinforcement. In slab also will provide the minimum reinforcement. In column also will provide the minimum reinforcement. So why this minimum reinforcement, tension reinforcement is provided in reinforced concrete beam? To arrest attack width, okay, to control excessive deflection, to prevent hairline crack formation, to prevent sudden failure. Now look very carefully. Let us suppose I have this beam, and I have this beam. Whenever I casted this beam, okay, when I casted this beam, there is no reinforcement because the load is very less. The load is within the permissible limit. But what happens is this beam is within this fixed support. This beam is within the fixed support. So what happens is after the casting of the beam, evaporation of the water, which is pore water, that is gel water, takes place. After the evaporation of that gel water, what will happen? Shrinkage of the beam will take place. Shrinkage of the concrete will take place. Because you have arrested this shrinkage, what will happen? Movement, resistance of the movement is known as strain. Whenever you resist the strain, stresses are developed. So that is why these stresses are developed. Because of these stresses, what will happen? The hairline cracks are developed. Small cracks are developed on the surface. These are known as hairline cracks. Okay, to prevent these hairline cracks, minimum reinforcement is always provided. Minimum reinforcement is always provided. Understood everyone? Clear everyone? So what will be the correct answer? Why in RCC always minimum reinforcements are provided? To prevent hairline crack formation. Option C is the correct. Please put a star mark on this. And it is not a sudden failure, it is a gradual failure, because evaporation of the gel water from the surface takes place. It takes time. It is not a sudden process. Understood everyone? It is a gradual process. And because of this, there is a hairline crack that are developed on the surface. To prevent this, we always provide minimum reinforcement. Understood everyone? Understood? Shall we move ahead? Okay, we'll move ahead with the next question. Please answer it very carefully. What is the maximum permissible acid soluble chloride content for reinforced concrete? This is a very good question. What is the correct answer? Now this is a very good question. You will get the answer of this question. You will get the answer of this question on table number 7 of IS 456. What is the maximum permissible acid soluble chloride content? Because more will be the chloride content, it will lead to the corrosion of the reinforcement. So whenever you are using the water to make the concrete, for which reinforced concrete, so what is the maximum permissible acid soluble chloride? Maximum permissible chloride content is 0.6 kg per meter cube. 0.6 kg per meter cube. So option B is the correct. Please put a star mark on this. This was asked in one of the examination. Okay. Now note down one more thing. If the concrete does not have any embedded metal, if you are concreting for plain cement concrete, there is no metal inside the concrete does not contain any embedded metal, does not contain any embedded metal. So what is the maximum value of chloride content? That is nothing but 3 kg per meter cube. 3 kg per meter cube. This is the maximum value. Understood? So these three values you need to know. I hope it is clear. Shall I move ahead? No. Next question. Now, in the previous question, we have seen minimum tension reinforcement. Do you know the minimum area, minimum tension reinforcement area? So this is nothing but AST upon AST. Minimum tension reinforcement upon B into D is equals to 0.87 upon 0.87 upon. Is this correct? Is this correct or wrong? Is this correct or no? This is 0.85 upon Fi. Very, very good. Very, very good. AST upon BD, minimum tension reinforcement. Minimum tension reinforcement is, this is the, yes, very, very good. Yes, 0.85 upon F5. Very, very good, everyone. Now moving ahead, please answer this question. In an under reinforced section, okay, in an under reinforced section, what is the case? If let us suppose this is for balance section, this AST is for balance section, okay. This AST is for balanced section. Now answer it very carefully. If at balance section, what will happen? Okay, this will reach to the permissible value sigma CBC. This will reach to its permissible value sigma ST upon M. Okay, but if it is a under reinforced section, so this means that the reinforcement given is less than the balance section. So what will happen? Now look very carefully. You can see the yellow one. The stress in the concrete will be less than, stress in the concrete is less than sigma CBC, but stress in the steel reaches to its permissible value sigma ST. So failure of the steel takes place before the concrete. So concrete is not fully stressed up to permissible stress. Yes, reinforcement is not fully stressed up to permissible limit. Option B is wrong. Option B is wrong. Either or B is also wrong. So what will be the correct answer? Option A will be the correct answer. Okay. Now both is also not the correct answer. Option A is the correct answer. So this is a very simple question. Understood, everyone? We'll move ahead with the next question. Please answer it very carefully. The anchorage value of hook is assumed 4 times the diameter of the bar. If the angle of bend is, now this is a good question. Anchorage value, please answer it very carefully. The anchorage value of hook is assumed 4 times the diameter of the bar. Okay, 4 times of diameter of the bar. Okay, the anchorage value. So the angle of the bend is, what will be the correct answer? Very, very good. So if you bend the reinforcement 45 degree, so you need to give the extra anchorage length, that is 4.5. So for 90 degree it is 8.5. For 135 degree it is 12 5, and for 180 degree U type hook, okay, or bend, this U type, what will be the correct answer? 4 8 5 12 5, and what is the value for 180 degree? What is the value for 180 degree? Can you answer it? 16 5. Very good everyone. 16 5. So here you have asked with 45 degree bend. Option C is the correct answer. Option C is the correct answer. Very good everyone. We'll move ahead with the next question. Please answer it. For RCC braced frames, maximum redistribution of moment allowed is, this is a very good question. For RC braced frame, so last 4-5 question. What is the correct answer? For RC braced frame, the maximum redistribution of moment allowed is, very good. So you can only redistribute the moment of 30% of the maximum value. You will not allowed to redistribute the moment more than 30% of the maximum value. Hence, you will get the maximum value as 30%. Option A is the correct answer. Option A is the correct answer. Understood everyone? Now we'll move ahead with the next question. Please answer it. Ratio of modulus of elasticity of two different material. Now, ratio of modulus of elasticity of concrete or modulus of elasticity of steel to modulus of elasticity of concrete. Let us suppose these are the two. Factor of safety, Poisson ratio. Poisson ratio is lateral strain to longitudinal strain. Okay. Yield stress upon permissible stress is factor of safety. Stress ratio, stress of the steel to the stress of the concrete. Here you are taken the ratio of modulus of elasticity. Hence option D is the correct answer. Understood everyone? Option D. Young's modulus of steel to the Young's modulus of concrete. This is nothing but modular ratio. Clear everyone? This is modular ratio M. I hope you have understood this point. Option. Factor of safety is not the correct answer. Factor of safety is defined as yield stress to permissible stress. Yes or no? Yield stress to permissible stress. Yield stress to permissible stress. This is factor of safety. Understood everyone? And we are talking about the ratio of modulus of elasticity. Hence option D. Please answer it. If you have a curved beam, curved RCC beam, you have this curved RCC beam, okay. A beam curved in plan is designed for bending moment and shear, bending moment and torsion, okay, and it is a beam. Understood? It is a beam, transverse. So transverse load is acting upon it. Whenever transverse load is acting upon the beam, bending moment and shear force automatically developed. Understood? So apart from it, for the curved beam, torsion also developed in the curved beam. So what will be the correct answer? Apart from bending moment, shear force, torsion is also developed in the. Answer it. What will be the correct answer? So for curved beam, always we designed for bending moment, shear force, and we always designed for bending moment, shear force, and torsion. Bending moment, shear force, and torsion. So what will be the correct answer? Option D is the correct answer. Understood? Option D is the correct answer. So curved beams are designed for bending moment, shear force, and torsion. Understood everyone? Clear? Now next question. The pH value. This is a very good. Please put a star mark on this. Very good and very important question. The pH value of water for quality concrete shall not be less than. So three factors are you need to remember. pH, organic content, inorganic content. These three you need to remember. Organic content, inorganic content, and chloride content. Very, very good. The correct answer is, please answer it very carefully. The pH value of water for quality concrete shall not be less than. So for concrete manufacturing, you need to see that the pH of water shall be in the range of pH of water for which you are making the concrete is in the range of 6 to 8.5. 6 to 8.5. So shall not be less than 6. Shall not be less than 6. So here you need to remember some values also. Organic matter, organic solids. Okay? Organic solids. Then you have inorganic solids, sulfates, and then we have chlorides. Chlorides we have two value for RCC and for PCC. Okay, sulfate, organic content, and so these value you need to remember. So please remember these values. Organic content is 200 milligram per liter, inorganic content is 3000 milligram per liter, sulfates is 400 milligram per liter, and for chlorides for chloride it is 500 milligram per liter. Shall not be more than, these are the maximum values. Okay, 2000 milligram per liter. Okay, for PCC. Sulfate is 400 milligram per liter. Organic content is 200 milligram, should not be more than 200 milligram per liter. So this you need to remember. Understood? And inorganic is nothing but 3000 milligram per liter. 3000 milligram per liter. Understood everyone? Okay. So here you have asked with pH. pH is 6 to 8.5. So these you need to remember. Please note down, if you have note down in your copy. Please note down this value. Written everyone? Shall I move ahead? pH is 6 to 8.5. Yes, very good. We'll move with the next question and the last question for today's session. Okay. Now please remember, now from tomorrow your class will start from 11 a.m. Now from tomorrow your class will start from 11 a.m. and roughly around 200 question I'll cover more. Okay, in RCC 200 more question I'll cover in RCC so that your all concepts will be covered. Understood everyone? Okay, we'll move with the next question. And the last question for today's session, please answer it very carefully. Please answer it. Consider the following statement as regard to rheology of concrete. Rheology you must have studied in fluid mechanics also. Rheology of concrete. It deals with strength of concrete. It deals with deformation in concrete. Yes, rheology deals with the how the material deform under the action of load. So this is good. This is right. It also deals with the strength of the concrete. Rheology also considered with the strength of the material. Okay, it is the study of deformation and flow of concrete. Yes, very good. Deformation and flow of concrete. Yes, it deals with the rate of shear and shear. Yes, shear strain and the shear stress. Rate of shear strain and shear stress in the concrete. Yes, this is also correct. Hence all the options are correct. Option A is the correct answer. Option A is the correct answer. So rheology deals with, हाँ ये महाट्रांसको के लिए भी रिवीजन है दोस्त. दिस इज द रिवीजन फॉर महाट्रांसको ऑल्सो. क्लियर एवरीवन है ना? सो आई हैव कवर्ड, आई विल टेक all the concepts of RCC so that you will get benefited in all the examination. So this is the correct answer. Rheology deals with the deformation. Okay, deformation. I'll try to cover the physics and chemistry part also. Look very carefully. Rheology deals with the how on applying the load, the deformation of the material take place, as well as how on applying the shear stress, the shear deformation takes place. So these two are also correct. 3 and 4 is also correct, as well as it deals with the deformation in the concrete, it deals with the strength of the concrete. Hence all the options are correct. Option is this is the question from engineering services examination. I hope it is clear. So this is lecture number 3 and this is the Telegram channel. You can download the PDF You can scan this Telegram channel. You can scan this Telegram channel and you can join the Telegram channel. You will get the PDF of, you can get the PDF of, okay. You can get the PDF of the lecture. Okay. This is lecture number 3. Understood? Just a moment. So today is lecture number 3, guys. Now from now onwards, your class timing will be from now onward, your class timing will be from 11 a.m. 11 a.m. Understood everyone? But just for today, your class is of 1 hour, okay? But from now onwards, we will take the session for roughly around 1.5 hour or 2 hours, okay? 11 a.m. to 1 p.m. Understood everyone? So this will be your timing for next 3-4 days. In 5 days, I'll finish the RCC. I'll take the most probable question, roughly around 300 question I will take. In these 300 question, your most probable question for RCC will be finished. Understood everyone? So today we will discuss the topic. So now in today's session, I will be discussing about the fundamentals of working stress principle. So today's chapter is today's chapter is fundamental of working principle. Fundamental of working principle. Understood? So this is the chapter name. Shall we start? Now we'll start the session. You can scan this QR code. Understood everyone? Directly you will reach to my Telegram channel. Here the annotated PDF I'll share you, okay, on this Telegram channel. Or you can search as ASM Live. ASM and live lecture, that is live, okay. ASM Live. You can search this also. So we'll start the session, guys. This is the first question. Please read very carefully. Please read very carefully. What will be the correct answer? What will be the correct answer? The vertical deflection limit may generally be assumed to be satisfied provided that the span to depth ratios is not greater than, okay, if you need you can WhatsApp me your doubt on this number 9911636463. Okay. What will be the correct answer for this? Answer me, guys. What will be the correct answer? Very, very good, Vishnu. Those who are live, please answer it. Those students who are live, okay, who are attending the live session, please answer it. Very, very good, everyone. This is a very basic question. You will get the answer as. Now, if you want the deflection of the beam under control, okay, the span by, we will take the span by depth ratio. Understood, everyone? So span by depth ratio should be such that span by depth ratio, okay, up to 10 meter. So these limits are up to 10 meter, okay. The span is of 10 meter for cantilever beam, and for simply supported beam, and for simply supported beam and for continuous beam. For cantilever beam, the span by depth ratio is limited to 7. If you have made the cross section such that, if you have made the section such that span by depth ratio is less than 7, so there will be no vertical deflection. Okay, the vertical deflection will be under permissible limit. Understood? Simply supported beam it is 20, and for continuous beam it is 26. Now, if span is for simply supported beam, if span is more than 10 meter, okay, the span by depth ratio is nothing but 20 upon span in meter. You need to divide the value by span in meter. Understood, everyone? You need to multiply this into 10 upon span in meter. Understood, everyone? This you need to remember. Understood, everyone? If the span is more than 10 meter, only for simply supported beam, okay, except cantilever beam, for simply supported and continuous beam, you need to multiply the value by 10 upon span, and this span should be in meter. Clear, everyone? For simply supported beam this value, and for continuous beam it will be 26 into span upon 10 meter. 10 upon span meter. Understood, everyone? Span in meter. So we'll move ahead. Next question. Please analyze this. What will be the correct answer? For second question, what will be the correct answer? What is the correct answer for second question? Please answer very carefully. Now this is a very good question. In a simply supported 9 meter long beam, so span is less than 10 meter and it is a simply supported beam. It is a simply supported beam. Understood, everyone? So length is nothing but 9 meter. The effective depth should be minimum of, okay, what will be the effective depth? D in mm is required for assuming the vertical deflection to satisfactory. So we know that span by depth is nothing but span by depth. Okay, this is effective depth is equal to, for simply supported beam it is 20. Understood, everyone? So span is 9 meter. 9 means 9000 mm. 9000 mm upon depth is equal to 20. So what will be the effective depth? Effective depth will be equal to 9000 divided by 20. So your answer will be 450 mm. 450 mm, and this is in mm. Understood, everyone? Option C is the correct answer. This is a very good question. Understood? Clear, everyone? Now we will move towards the next question. Okay, your answer will be 450 mm. Okay, so now the next question is, answer this question. Again, this is based on the fundamentals of working stress method. The application of elastic theory to the beam is based on the assumption at any cross section, plane section before bending remains plane after bending. Is this correct? Yes, this is correct. Okay, this is the assumption that we used to take. The plane section before bending remains plane after the bending. Okay, all tensile stresses are taken up by reinforcement alone and none by the concrete. Yes, this is also one of the assumption that, okay, all the tensile reinforcements are taken by the steel only, none by the concrete, because concrete is weak in tension, okay, and strong in compression. Steel reinforcement is free from initial stresses when it is embedded in the concrete. Yes, whenever you are casting the RCC structures, we assume that there is no initial stresses in the concrete. This is the assumption that we used to take. Understood? So these three are assumption A, B, C. So it means all the assumptions are correct. All the assumptions are correct. Understood everyone? Yes or no? And in working stress method, now these are the three assumptions. In working stress method, there are two more assumptions. One is modular ratio. You take the modular ratio value as 280 upon 3 sigma CBC. Okay. And the fourth assumption is These are three. This is fourth, and the fifth assumption is, okay, for example, you are talking about concrete. Okay, this is concrete, and we are working in this range. We are working in this range. Okay, we are working in this range. C point. Whenever you are using the steel, okay, that steel does not have initial stresses. What happens is in steel there is a cold working method. Cold working method means since in steel you stress the steel beyond yield point, so there is a strain hardening. So what happens is we twist the bars such that the stress diagram look like this. We twist the bar and then we release the load. So initially there is some stress which is there in the steel bar whenever they are used as a RCC. Understood everyone? So at practically there are some stresses because the manufacturing of the steel is such that in order to avoid this yield plateau, we twist the steel bars. Hence, there are some initial stresses which are left in the steels. So our assumption is we assume that there is no initial stresses in the steel bar. Understood everyone? Now, the last assumption is since we are working on before the elastic range, so the stress diagram is linear. So stress strain diagram is linear. We need to assume the stress strain diagram is linear. So these are the 5 assumptions for working stress method. Understood everyone? Now moving ahead. Here also you can see we are working at this range. So here the stress strain diagram is linear. So this is nothing but 60% of yield stress or 66% of yield stress. This value is yield stress. Understood everyone? So here the stress diagram is linear only. Now we are moving towards the next question. Answer this question. Answer this question. This is also a very good question. Now this question is a beam of 400 mm effective depth with a neutral axis constant of 0.39. So neutral axis depth constant is 0.39. The value of lever arm is now I'll show you here. This is a beam and this is the steel reinforcement. This is effective depth D. Okay, the stress diagram is small d. Understood? This is the clear everyone? Now you can see very carefully. This is, let us suppose, depth of the neutral axis. So this compression force will lie at x upon 3. Understood? And these are the tension force. So what is the lever arm? D minus x by 3. This is the lever arm. Yes or no? So you can see that the lever arm value is nothing but a beam of 400 effective depth. So small d is given as 400 mm. With a neutral axis constant of k is nothing but 0.39. 0.39. Okay, the value of lever arm. So lever arm value is d minus x by 3. So d is given as 400. What is the value of x? K into d. K value is, d is nothing but 400. Okay, minus k into d. 0.39 into 400 divided by 3. Understood everyone? So this is the value. You will get the answer. Now this you need to solve. You can see very carefully how we will get the answer. You can see, if you do not have calculator with you, so what is this? This is nothing but 0.1. 400 minus, so this value is nothing but 0.3. Okay, 0.39 into 400 divided by 3. So this is nothing but 0.1, roughly around 0.1. Okay, 0.1 into 400 is nothing but 40. 40 minus 400, 400 minus 40 is roughly around 360. So your value is close to 360. So your value is close to 360 means option D is the correct answer. Understood everyone? Now, no, just a moment. This is 0.39. 0.39, if your value will be, no, you need to calculate this. Otherwise, you will get the wrong answer. You need to calculate this value. Here, our assumption does not suits well. 0.39 into 400 divided by 3. So this is roughly around 0.13. Yes, 0.13. 0.13 means 13% of 400, because these two options are little close. The 300 will not be correct answer. 250 will not be the correct answer. 0.13 into 400 is nothing but 156. 156 means 348. 348 mm will be the answer. 348, yes. 348 will be the correct answer. Yes, this is the correct answer. This will be 156. The correct answer is 0.39 into 400 is 156. 156 divided by 3. So your answer is 348. Understood everyone? We will move ahead with the next question. Answer this question. In working stress method, okay, the moment of resistance offered by balance section in WSM is given by IS 456-2000. This is a very good question. Standard question. Okay, if you have now answer the question. What will be the correct answer? Moment of resistance. Now I'll give you the hint. Hint is, now this is the tension force and this is the compression force. Okay, so the lever arm is D minus X by 3 in balance section. Understood everyone? So from tension side, your answer from tension side, the moment of resistance is equals to, from tension side, force into lever arm. Force is nothing but sigma st into AST into D minus X by 3. D minus X by 3. So you can see very carefully, you need to find moment of resistance. Understood? And from compression side, okay, this will be nothing but sigma CBC, okay, stress, and this width is B and this depth is X. Understood everyone? Half base into height. So what is the area of the stress diagram? Half base into height, half sigma CBC into height. Okay, this is the area. On how much width it is acting? It is acting on B width. Okay, and what is the lever arm? D minus X by 3. D minus X by 3. Understood everyone? Yes or no? Now you can see very carefully what is the value of X. The value of X is K into D. K into D. Okay, half sigma CBC into K into D into B. Here also D minus K into D by 3. You can see this K can be taken outside. Yes or no? Understood? So you can see. So match the option. If you take D as common, okay, sigma CBC, okay, into X. So here sigma CBC D minus X by 3. You can see half sigma CBC into X into B, okay, D minus X by 3. So what is the correct option? What is the correct option? So D is the correct option. You can see very carefully. D is the correct option. Understood, everyone? You can see this expression. D is the correct option. Yes or no? Yes, D is the correct option. Clear, everyone? Okay, we'll move towards the next question. Answer this question. Which of the following is primary cause of flexural collapse in over reinforced beam? So whenever there is a over reinforced beam, so what is the primary cause that it is fail in flexure? Primary tension failure, failure of bond, primary compression failure, relative movement between steel and concrete. This is also a very good question. Please answer it. Yes, very good. It is a over reinforced beam. Very good, everyone. It is a over reinforced beam. Very good. Very good. It is a over reinforced beam, and in over reinforced beam, what happens is neutral axis shift at the bottom. Okay, neutral axis shift below the neutral axis of the balanced section. Yes or no? Neutral axis shift below the balanced section. Clear, everyone? So now the moment takes place about this value. This is for the balance section. This is for the balance section. In balance section, both steel and concrete fail simultaneously, but it is an over reinforced section. In over reinforced section, what happens is, look very carefully. So here the stress in tension is less than sigma st upon n, but here the stress reaches sigma CBC. The concrete fail earlier than steel. It is over reinforced section. So primary compression failure. So concrete fail earlier than the steel. It is known as primary. Please remember, it is primary compression failure. Primary compression failure means concrete fail earlier to the steel. So it is known as primary compression failure. And which side of concrete fail earlier? On the compression side fail earlier. Understood, everyone? That is why it is primary compression failure. We will move towards the next question. You can answer this question very carefully. According to the basic consideration of working stress method for reinforced concrete design, the stress strain relationship of steel and concrete under working load is taken as, this is a very good question. This is the assumption. What will be the correct answer? Yes, very good. You can see for steel also, for steel also. If this is the stress strain curve for steel, we will, and this value is Fy. How much stress you are permitting? You are permitting Fy upon what is the value? The value is the factor of safety is 1.15. It is nothing but 0.87 Fy. 0.87 Fy. So you can see very carefully. This much is the stress you are permitting. So here the stress strain diagram is linear. Okay. For concrete also, you can see this is FCK and we are permitting value lesser than FCK. So here also the stress strain diagram is linear. So your correct answer is option D. So this is one of the approximation that we have taken. Understood everyone? Option D is the correct answer. Clear? Okay. What is the shape for ultimate method? No, the shape for stress diagram is same. Ultimate method is a design philosophy. Ultimate method is a design philosophy that you will see in steel structure for the design of beam, plastic analysis. Okay, so there we assume that in plastic analysis, what we assume is that we will consider that this all the fiber, let us suppose this is fiber number 1, fiber number 2, fiber number 3, all the fiber reach to their every fiber will reach to their yield value. The shape will be same for stress strain diagram, but our assumption is bilinear. Here this linear and this linear, bilinear. Okay, as soon as the fiber reaches to yield value, we will consider this as a failure. Why? Because there is a strain hardening. And steel code suggests that if in the steel structure any of the member or any of the small part yielded, we consider this as failure. Okay, so all the fiber, when all the fiber yielded, then only the failure will take place. So we will consider that the strength of each and every fiber will reach to the yield value, then only failure will take place. This is known as ultimate load method. Understood? So here the answer is option D. Now we'll solve the next question. The end of side covers for a steel bar in RCC work may be taken as, this is a very good question, side covers. This is the side cover. Understood? This is the side. This is a very good question. Please make it a star mark. You know, I have almost given 1.5 months, 1 to 1.5 months to frame such kind of questions. And trust me guys, after solving these 300 questions, you will get the insight of whole subject. Understood everyone? So that is why each and every question I have framed in such a way that after solving these 100 question, 300 question, you will be able to solve any kind of question of RCC. And this is a very good question. This is a side face cover. So till now we have seen the nominal cover from the bottom. These are side face. How much is the side face cover that you need to provide to the reinforcement? There is a very good question. No, A is not the correct answer guys. A is not the correct answer. Now the side cover are, the value of side covers are 40 to 50 mm. 40 mm to 50 mm. So this is the side covers. Always provide side covers as 40 to 50 mm. If this is the 40 to 50 mm, then what will be the correct answer? Okay, always provide side cover as 4 cm to 5 cm. Understood? Clear everyone? Always provide the side cover as 4 cm to 5 cm. I hope it is clear everyone. Now please put a star mark on this. This is a very good question. Okay, this is a very good question. Every time aspirant used to remember the cover from the bottom. But this question states that you need to remember the cover from the sides also. So that will be 40 to 50 mm. I hope it is clear now. Now the next question. Please solve this question. What will be the correct answer? Now, a section is one in which the area of tension steel is such that the ultimate limit state, the ultimate compressive strain in concrete is reached such that the ultimate limit state, the ultimate compressive strain in concrete is reached. Okay, the strain in the concrete is reached earlier. However, the tensile strain in the reinforcing steel is less than the yield strain. What is this value? Now the concrete reaches to its permissible value earlier than the steel. So what kind of section is this? You have given the steel more than the balance section, hence the permissible stress in the steels are less than, okay, the stress in the steel is less than permissible stress, but the stresses in the concrete reaches earlier, so it is over reinforced section. It is over reinforced section. I hope it is clear now. This is a very basic question. Over reinforced, not under reinforced. Understood everyone? That is for beam. That is for beam. Understood? Expert gaming. Now we'll move towards the next question. Please answer this question very carefully. For 45-degree cranked or bent up bars of dia D, the additional length of two bent up is approximately. This is a very good question. Most probably you will commit a mistake on this type of question. This is a very good question. No. I know that you will commit the mistake. That is why I have given you the time to solve this question. Most probably you will commit the mistake. I'm pretty sure that you will commit the mistake in this question. Now let us suppose this is the bent up bars and it is bent by 45 degree. Understood? It is bent by 45 degree. So you can see this is 45 degree. If this is 45 degree, if this length is D, so this length should also be D. Now you can see by giving the hypotenuse is more than, yes, expert gaming, you have given the correct answer. Very, very good. Yes, 2 bar. Yes, understood. So by giving this bent up, since hypotenuse length is more than other length, so it means that if there would have been this straight bar, the length was D, but by giving this, there should be additional length. What is the additional length? This additional length is how much it is more than by giving this hypotenuse, okay, by giving this hypotenuse, how much additional length you have given. Okay, you can see sine 45 degrees perpendicular upon hypotenuse. Perpendicular is this D and this hypotenuse value. So this hypotenuse value is D upon sine 45. Okay, so you have given the length D upon sine 45 degree. And what is the additional length? Minus D. This is the additional length. So by giving this bent of 45 degree, additional length given is exceeding the D is D upon sine 45 minus D. So if there are two bent up bars, this additional length will be D upon sine 45 minus D into 2. Clear? Now how to solve this question? Now you can see very carefully, the sine 45 value is nothing but sine 45 value. Sine 45 is 1 by root 2. Okay, 1 by root 2. Root 2 value is nothing but, or 1 by root 2 value is 0.707 minus 2. You need to answer this 0.707 1 by root 2. Okay, so you can see very carefully, root 2 value is 1.414, 1.414, root 2 value is nothing but 1.414 and 1 upon root 2 is 0.707. Please remember these two values. Always remember these two values. For your PSC examination, you need to remember these values, 1 upon root 2, 1 upon root 3, pi value, 1 upon pi value, this you need to remember. So 1 by root 2 value is 0.707 and root 2 value is 1.414. Understood everyone? So you can see very carefully, if sine 45 is in denominator, root 2d minus d into 2. Okay, so root 2d is nothing but 1.4. 1.4 minus 1 is 0.4 into 2, 0.8. 0.8 value, 0.8. Now you can see 1.41. 1.414 d minus d into 2. So you can see very carefully, this value will be more than 0.82. 0.82 d. 0.82 d. So which option will you tick? You will tick the value more than 0.8. That is option A will be the correct answer. Approximately we consider this value as 0.45 d. Okay, approximately it is 0.45 and twice of this is 0.9. It will be more than 0.8, no? That is why option D is not the correct answer. Clear everyone? I hope it is clear. Yes or no? Yes or no? We'll move ahead. Next question. What is the correct answer for this question? The equivalent area for reinforced cement concrete section, equivalent area is, you can see very carefully, if this is the top view, this is the top view, okay, or let us suppose this is the cross section. So area of concrete, okay, this ASC is area of steel, this ASC is area of steel, equivalent area of reinforced cement concrete section, okay, area of concrete and area of steel. Now to convert this into equivalent section, we will convert this steel into equivalent concrete. So this will be M into ASC, equivalent area of steel, equivalent area of steel. So what is the total area? AC plus M times of ASC, AC plus M times of ASC. What will be the correct answer? Option B is the correct answer. Understood? We are asking only for area, not for the force. That is why option D will not be the correct answer. Okay, this is the area. Clear everyone? Now moving ahead with the next question. I hope you are getting all the points. Effective cover of reinforcement is, this is a very good question. What is effective cover? What is effective cover, guys? What is effective cover? Please look at the option very carefully. Now you can see, this is clear cover. This is clear cover. What is the, yes, very good. Very good. Option D is the correct answer. Very good everyone. Okay, you can see this is clear cover. Clear cover. Okay, and this is effective cover. From bottom to the CG of the reinforcement, this is effective cover. Understood everyone? Okay, so what is the effective cover? Clear cover plus this is the half of the, this is nothing but half of the diameter of the bar plus half of the diameter of the bar. Option D is the correct answer. Okay. Option D is the correct answer. Moving ahead with the next question. A RCC beam 200 mm wide and 300 mm effective depth is reinforced with Fe415 grade steel. The grade of concrete used is M20. The limit moment carrying capacity of the beam is, very, very good question. And you need to solve the question without calculator. You need to solve the question without calculator and in a very given specific time. If this question came in GATE examination, you have calculator and you have time to solve such kind of question. But in your PSC examination, you need to focus without calculator. You need to answer the question. What will be the correct answer, guys? B is not the correct answer, Republic. B is not the correct answer. Please solve this question. Don't give a guesswork. Now this is a, you can see a beam width is 200 mm, a beam of 200 mm width. So width is 200 mm and depth is effective depth. Effective depth is 300 mm. Understood? So grade of steel is Fe415. Fe415. The grade of concrete used is M20. M20 concrete you have used. The limit moment carrying capacity of the beam is. Very, very good. This is the correct answer. Now the moment carrying capacity means moment of resistance. So these value are 0.138 FCK BD square. So there are three values. 46. Yes, correct answer is option C. Very, very good. Option C is the correct answer. Please remember this. For Fe250, moment carrying capacity is nothing but 0.138 FCK BD square. For Fe415 and for Fe500. Please remember these three values. Okay. Please remember these three values. This is the direct, you will get the answer. 0.148, 138, 0.134. 0.148, 0.148, 0.138 FCK BD square and 0.134 FCK BD square. Directly you will get the answer. Directly you will get the answer. Here you are asked with Fe415 grade. When Fe415 grade is used, the answer is 0.138, 0.138 FCK is 20, width is nothing but, width is 200, depth is nothing but 300 into 300, 300 into 300. So here you will get the answer in Newton mm. Newton mm. Understood everyone? Point. So you multiply them 10 power minus 6, 3, 2 to 4 to 6. This you need to solve the question. Understood? Clear everyone? So you will get the value here as 49.68 into 10 power minus 6 kilonewton meter, 49.6. So option C is the correct answer. We will move towards the next question. Please answer this. Economical percentage of steel in RC section is? This is a very good question. Now, in IS code, you need to study RCC. In order to understand the diagram, you need to first study RCC, then only solve the question. Now you can see very carefully economical percentage of steel in RCC section. In your IS code, minimum steel reinforcement is given, maximum steel reinforcement is given, but this is economical percentage. It depends upon the modular ratio. It is only valid for WSM structure. K is neutral axis depth factor, and M is nothing but modular ratio. What is economical percentage of steel? This is a very good question. Please put a star mark on this. How much percentage of steel will you give that it will be economical? So economical percentage of steel. Okay, this will nothing but 50 K square M into 1 minus K. This is a, so M is nothing but modular ratio, and K is neutral axis depth factor. Understood everyone? Neutral axis depth factor. Option A is the correct answer. Understood everyone? Option A is the, please put a star mark on this. Maximum student have given the wrong answer. Understood? We'll move ahead with the next question. Answer this question. Moment of resistance for a under reinforced beam section is. Now for under reinforced beam, you can see very carefully. Neutral axis will shift above the balance section. Yes or no? Neutral axis will shift above the balance section. So in this case, what happens is, steel reaches the permissible value earlier than concrete. This is sigma CBC. This is sigma ST upon M. So moment of resistance is taken care from the tension side. If you need to take the moment of resistance from the tension side, what will be the correct answer? Yes. So here the tension force is, the moment of resistance is nothing but tension force into lever arm. So what is the tension force? Sigma ST into AST. Understood everyone? So you can see very carefully. So the stress is sigma ST upon M. What is the area? M into AST. Equivalent area is M into AST. So if you multiply it with sigma ST into AST, this is the tension force. Lever arm is nothing but D minus x by 3. So here x is written as n. Understood everyone? X is written as n. So you can see what will be the correct option. Option A is the correct answer. Here the depth of the neutral axis is indicated by n. Clear everyone? We are moving towards the next question. Attempt this question. What will be the correct answer? The working stress method of design of RC member is known as. Now I'll give you the hint. Limit state method is known as probabilistic approach. Understood? This is probabilistic limit state method is known as probabilistic approach. Why? Because the probability is included, FCK. Okay. Clear everyone? Limit state method is probabilistic approach, but working stress method is, what is the correct answer? Working stress method is not probabilistic method, it is deterministic approach. Very, very good. It is a deterministic approach. Understood? Because here we are loading the member for the working load and we are reducing the strength. And how much we need to reduce the strength? Okay, this is already defined. For axial load, 60% of yield stress. For flexure, 66%. Okay, this is the deterministic approach. Understood, everyone? Factor of safety is predetermined. Understood? So this is the deterministic approach. Option B is the correct answer. Moving towards the next question. Please answer this question. Answer this question. In a critical section of a beam, whenever there is a critical section, in critical section, what happens is, in a critical section, neutral axis is at such position that the permissible value of stress in steel and concrete reaches its permissible value simultaneously. Okay, the stresses sigma st upon m, this is sigma cbc, reaches the permissible value simultaneously. This is the balance section or critical section. The full strength of steel in tension is not being utilized. This is wrong. The full strength of concrete in compression is not being utilized. Wrong. The stresses developed in steel and concrete will simultaneously be the same as assumed in design. Option C is the correct answer. The concrete will reach its maximum allowable stress earlier than the steel. So option C is the correct answer. Understood, everyone? Now moving towards the next question. Please share this session to your friends also or to your juniors also who are preparing for the examination. Okay, because these are very good questions. Okay, and whenever they see this session, how to solve such question without calculator, they will get benefited from such. Okay, this is on YouTube. Okay, you can share these session to your juniors also. What is the correct answer? This is a very good question. Please mind it. You need to solve the question without calculator. Without calculator, you need to solve such question. Attempt the question. No, Vignesh, 240 is not the correct answer, brother. Just a moment. 240 is not the correct answer, brother. Option D is not the correct answer. Please correct it. A rectangular beam section, 300 mm width. So width is 300 mm and effective depth is 500 mm. So this is given in the question. Okay. Tensile reinforcement of the effective and the tensile reinforcement, the area of the steel, AST, is given as 1346 mm square. 1346 mm square. The beam is constructed using M20 grade concrete. So FCK is 20. Fy is given as 415. Okay, Fy is given as 415 Newton per. Calculate the neutral axis. So how do you get the neutral axis? By equating the tension side to the compression side. So this is a question. although I have taken this in working stress method, but this is the question of limit state method. Since this is given, you can equate the compression side to the tension side also. You can solve such question by two method. By equating the compression force is equals to tension force. What is the compression force? 0.36 FCK B into XU is equals to 0.87 Fy into AST. This is by limit state method. You can solve this question by working stress method, by equating the compression area to the, by taking the moment of compression area to the tension area. By taking the moment of compression area to the tension area. But this is also one of the way. Equating the compression force is equals to tension force. So you can see very carefully, XU will be equal to 0.87. What is Fy? Fy is nothing but 415. What is AST? This is given. So this was the hint that it is given, 1346. 1346 divided by 0.36 into FCK is 20 into width is nothing but 300. So from here you will get the answer. From here you will get the answer XU in mm. So you can see here 415 is Newton per mm square, 20 is also Newton per mm square. Here this is 1346 is mm square, 300 is in mm. So your answer will be in mm. This you need to solve. Now this is a this you need to solve. Yes, here you will get the answer as 225 mm. Understood? Clear everyone? Now we will move ahead. We'll move ahead with the next question. Solve this question. This is also a good question. Please be careful without calculator. Try to solve this question without calculator. How will you get the answer? A reinforced cement concrete beam section has a size of 300 mm width. So here the width of the beam is given as 300 mm and effective depth is given in the question is 400 mm. The grade of the concrete used is M20 and for steel it is Fe415. This is given in the question. Okay. If the ultimate bending moment of 150 kN act on the section, the beam has to be designed as. Now, look, ultimate bending moment is given. Okay, ultimate bending moment capacity is 150 kilonewton meter. So, for this cross section and for this grade of steel and concrete, if you design the moment of resistance, then you can identify which type. So, moment of resistance is for Fe415 is 0.138 FCK BD square. 0.138 FCK BD square, you'll get the answer. Compare it, you'll get the answer. 0.138 FCK BD square. So 0.138 FCK is 20, width is nothing but 300, depth is nothing but 400 into 400 into 10 power minus 6. So you'll get the answer in kilonewton meter. So compare it. This moment of resistance is more than ultimate moment or less than ultimate moment. Compare this, if it is more or less. So this is the limiting value. Understood? This is the limiting value. What is the bending moment that is coming on the section? 150. And what is the strength? Maximum that this section can take is 132.48. So you can see its capacity is to resist 132, but how much moment is acting? 150. So when the limiting moment is less than the moment which is acting on the beam, so you need to design which type of section? If the moment coming on the section is more than its capacity, then which type of section will you design? Over reinforced or doubly reinforced? Which will you prefer? We do not provide over reinforced section, because in over reinforced section failure of concrete takes place, which is a brittle failure. Hence we go for doubly reinforced section. We go for doubly reinforced beam. We go for doubly reinforced beam. Understood everyone? We go for doubly reinforced beam. Are you getting my point? Now answer this. This question I have taken from ESE, Engineering Services Examination. Please read this question very carefully. According to IS 456, over reinforced sections are not permitted. Yes, over reinforced sections are not permitted. Now, reason is there is a ductile failure of over reinforced section. Okay. Now you can see how will you get the answer? If both assertion and reason are correct, reason is the correct explanation of A, then A. Both assertion and reason are true, but R is not the correct explanation, then B. Okay, C is A is true but R is false, and D is A is false and R is true. How will you get the answer? You can see very carefully. Yes, very good. Assertion is true. Why? Because IS 456 does not permit the over reinforced section. It says that you go for doubly reinforced section. Now the next is why it is so? Because there is a brittle failure of concrete. Just now I have told you there is a brittle failure of concrete, but the reason is there is a ductile failure. This is wrong. So assertion is correct, reason is false. Option C is the correct answer. Understood everyone? Because there is a brittle failure of over reinforced section, hence option C is the correct answer. Are you getting my point everyone? Yes or no? Yes or no? Shall I move ahead? Now next question. Please answer this question. The permissible bending compressive strength of M25 grade of concrete is 8.5. Its short term and long term modular ratios are? Very good question. Please answer this. This is a very good question. Please solve this. Please put a star mark on this. Answer this question. The permissible bending compressive strength of M25 grade of concrete is. Now look very carefully. Sigma CBC is given. Permissible bending compressive strength of M25 grade is 8.5 Newton per mm square. Okay, this is given. Okay, the grade of the concrete is M25. Two values are given. FCK. FCK value is 25 Newton per mm square. So these two values are given in the question. Okay, its short term and long term modular ratios is. Look, modular ratio for short term is short term modulus of elasticity of concrete to the short term modulus of elasticity for steel. Yes or no? For steel and for concrete. What is the value of Young's modulus of steel? 2 into 10 ki power 5. And what is the value of Young's modulus of concrete? 5000 under root of FCK. Yes or no? FCK value is 25. So this is short term, this is short term. And what is long term? Long term modulus of elasticity is 280 upon 3 sigma CBC, 3 sigma CBC. So your value is 280 divided by 3 into what is the value of sigma CBC, which is given in the question, is 8.5. 8.5. This is long term. So you can see very carefully here in denominator it is 25. This is to be solved. This is simple to solve the question. This is little simple. So you can see this value 280 upon 3 into 8.5, 24.5. So you can see this is nothing but 280 upon 24 or 25.5. 25.5. Yes or no? So you can see this value is roughly around 25. 11 times is 10 times is 250. 250, 275, roughly around 11. This will be roughly around 11. Most probably this will be, since the values are 11 and 8, and this value is 2 into 10 की power 5 divided by 5000 into 5. Yes or no? 30 are cancelled out. Now 25 4, this is 8. So 8 is the short term and long term is 11. 8 and 11. 8 and 11. Yes, this is based on WSM. Understood? Next question. Please answer this question. This is a very simple question. What is the ratio of flexural strength? Ratio of flexural strength of the flexural strength is FCR to the characteristic compressive strength of the concrete, FCK. तुम एक काम करो, अगर तुम्हें आरसीसी पढ़नी है ना, तुम एक काम कर लो टॉप तक, ठीक है, कॉन्सेप्ट सीखो, गूगल पे सर्च कर लेना, या मेरे टेलीग्राम चैनल पे ना, टेलीग्राम चैनल पे इसका ऐप का लिंक, गूगल प्ले स्टोर पे कॉन्सेप्ट सीखो देखोगे ना, तो इसका ऐप का लिंक होगा, वहां पे आरसीसी का कोर्स ले लो, पूरा पढ़ लो, लगभग 30-40 घंटे में पूरा आरसीसी कवर हो जाएगा. What is the ratio of flexural strength FCR? So FCR is nothing but 0.7 under root of FCK divide by to the characteristic compressive strength or divide by FCK. Understood everyone? So you can see very carefully the grade of the concrete is 25. So 0.7 root of 25 is 5 upon 25. So if you multiply it by root 25 into root 25. So this will be nothing but 0.7 into 25 upon 25 into 5. So your answer will be 0.12. 0.11 will be the correct. 0.1. Point 7 by 5. Okay, 0.7 by 5. 1.4. 0.14, sorry. 0.14. Option C is the correct answer. Understood? Next. Minimum spacing between horizontal parallel reinforcement bar of different diameters should not be less than. This is also a good question. Codal provision. अब उसका नाम चेंज हो गया है, MX लाइव से कॉन्सेप्ट सीखो हो गया है. ठीक है. Answer this question. What will be the correct answer? जाके चेक करो. Minimum spacing between horizontal parallel reinforcement above different diameter. Now, if the diameter are same, then the horizontal distance between horizontal distance is diameter of the bar. But if the diameter of unequal diameter, then we take the minimum distance should be longer diameter, thicker diameter. Yes or no? Thicker diameter. So these are the minimum dimension, minimum spacing. Understood everyone? Minimum this is the horizontal distance. Minimum distance. If diameter of the same bar, so smaller distance, minimum distance should be diameter of the bar. Or if these are of unequal diameter, so this distance should be diameter of longer bar, or 5 mm more than nominal size of aggregate. Nominal size of aggregate. Understood everyone? Okay. Minimum spacing between horizontal parallel reinforcement bar of different diameter should not be less than, not the thinner bar, 1 diameter of the thicker bar, sum of the diameter of the thinner and thicker bar, twice the diameter of the thinner bar. Option C is the correct answer. Option C is the correct answer. Minimum spacing should be 5 thicker diameter. Or if the diameter are same, then the 5, or this 5 mm plus nominal size of aggregate. Greatest value of among all the are taken, and this is the minimum spacing between two parallel reinforcement. Clear everyone? I hope you have understood these questions. Answer me one thing, guys. Is there is a need of annotated PPT? Do you need annotated PPT for revision? Okay, so this is it guys for today's session. Please revise the concepts. In the next class, I'll take few more concepts of RCC. Understood everyone? In today's session, we will be covering few topics of RCC. Good morning everyone. Okay, we will start the session, guys. So in this session, we'll be covering, this is the fourth lecture, understood? So from now onwards, your class timing will be from, for this RCC series, the class timing will be from 11 a.m. Understood everyone? 11 a.m. So most probably till this Sunday, I'll be finishing off this, okay, this session. Understood everyone? So you can scan this QR code, you can directly join to my Telegram channel, and the PDF of this lecture will be available on this Telegram channel. Understood everyone? Shall we begin? Shall we begin? Okay, we will start the session, guys. So today is the first question. Now answer it very carefully. Answer this question very carefully. Now, the permissible, so in the previous lecture we have covered 20 questions. Okay, so I think 22 question. So we'll be starting from 21st question. Okay, so today we will be covering three topics, that is basic of working stress method as well as design for shear, and if we get the time then we will cover the next topic, that is design for doubly reinforced beam. So three chapter we need to cover in today's session. Most probably two we will be covering. Okay, 50 question we will cover in this session. Yes, this is the right answer. Now the permissible bending compressive strength of M25 grade of concrete is, now you can see in the question it is given as sigma CBC is 8.5 Newton per mm square. So sigma CBC is given in the question. Its short term and long term modulus ratio is nearly. So what is the answer? Short term and long term modulus ratio for concrete. Understood everyone? If sigma CBC is given, so long term modular ratio is nothing but modular ratio is defined as Young's modulus of Young's modulus of steel upon Young's modulus of concrete. Yes or no? Okay, so short term, and for long term Young's modulus it is nothing but 280 by 3 sigma CBC. 280 by 3 sigma CBC. Young's modulus of steel is nothing but 2 into 10 ki power 5. Understood? And for EC is, for concrete, 5000 under root of FCK, it is 25. Clear? So this will comes out to be 8 and this will comes out to be 280 upon 3 sigma CBC, that is 8.5. You will get the answer. You will get the answer. ठीक है, वो आज आ जाएगा यार, वो मेरे से मिस्टेक हुई होगी कि PDF नहीं शेयर हो पाई होगी, आज आ जाएगा. Okay, what will be the correct answer for this? 11. 11 is the correct answer. 8 and 11. So option A is the correct answer. Understood everyone? Okay, we'll move ahead with the next question. Please answer this. What is the ratio of flexural strength FCR to the characteristic compressive strength of concrete FCK of M25 grade concrete? Good morning everyone. Okay, answer it. Please answer this question. Now, very good. Now, what is the ratio of flexural strength FCR to the characteristic compressive strength of concrete? Now, FCR is nothing but, FCR is 0.7 under root of FCK. Okay. Now, the ratio of characteristic compressive in the M25 grade of concrete. So, look very carefully. 0.7 under root of 25 upon the characteristic compressive strength is 25. So, this is nothing but 0.7 into 5 upon 25. So this is nothing but 0.7 by 5. So it will be less than 0.7. Okay, it will be less than 0.7. Okay, so 0.7 divided by 0.5 is 0.14. Option C is the correct answer. Understood everyone? Thank you so much, bhai. Option C is the correct answer. We'll move ahead with the next question. Now answer this question. Minimum spacing between horizontal parallel. This is a good question. This is a very good question. Now remember this, there are two datas, minimum spacing between horizontal bars as well as the minimum spacing in the vertical reinforcement. Okay, vertical bars. Answer this question. Answer this question. Yes. 24 till 24 we have covered. There are 36 questions in this chapter, so we have reached to 23rd. Okay. So what is the correct answer? Now you can see very carefully. Now look. What is the minimum spacing? Minimum spacing between horizontal parallel reinforcement bar of different diameter should not be less than, you can see very carefully, there are three criteria. Okay, three criteria is diameter of the bar, the minimum spacing is diameter of the bar or diameter of thicker bar. Most probably if the bars are of equal diameter, diameter of bar. If the bar of unequal diameter, diameter of thicker bar. As well as 5 mm more than the nominal size of aggregate. Nominal size of aggregate. 5 mm more than nominal size of aggregate. You can see why this codal provision is given, why there is a minimum spacing, because whenever you pour the concrete, so what will happen, the aggregate does not stuck in between the reinforcement. That is why there should be a clear spacing. Understood everyone? Otherwise if the spacing is very less, the aggregate in the concrete will get stuck in between this space. That is why this provision is there. So what will be the correct answer? 1 diameter of thinner bar? No, the correct answer is 1 diameter of thicker bar. Understood everyone? Now moving ahead with the next question. Now from here you will get the new question. Okay, from here you will get the new question. Now answer it very carefully. What will be the correct answer? If phi is the nominal of reinforcing bar, nominal dia of reinforcing bar, if phi is the nominal dia of reinforcing bar, fx is the compressive stress in the bar. Okay, compressive stress in the bar. ये कल बताया हुआ अनुराग वर्मा, 4 से 5 सेंटीमीटर साइड फेस, जो हम लोग साइड में जो स्पेसिंग देते हैं, क्लियर है? What will be the correct answer? Now this is a very good question. Here the notations are different. Here the notations are different. Okay, notations are different. Okay, so you can see the phi is the nominal diameter of the bar. If phi is the nominal diameter of the bar, reinforcing bar, fx is the compressive stress. Fx is the compressive stress. This is nothing but sigma c. Okay, sigma c compressive stress, and FBD is the design bond stress. FBD is similar to tau BD. Understood everyone? So here the notations are different. Okay, the anchorage length of the straight bar is, the anchorage length is nothing but phi into sigma c. Here phi into fx upon 4 times of tau BD. Tau BD here is FBD. So what will be the correct answer? So pi, option D is the correct answer. Understood everyone? Just the difference of the notation. Clear everyone? Clear? We'll move ahead with the next question. Answer this question. This is also a very good question. Please answer this. The effect of creep on modular ratio is? Yes, yes, Vignesh. Bond stress. Yes, bond stress increases by 25% in compression, and for high grade of steel, it is increases by 60%. Today, we will see these concepts also. The effect of creep on modular ratio. Now, you can see if I see the short term modulus, the answer is yes. Very good, yeah. Shubhendu, very good. Option B is the correct answer. You can see very carefully. For short-term static modulus of elasticity, it is nothing but Young's modulus of steel to the Young's modulus of concrete. Okay. For short-term, it is nothing but 2 into 10 ki power 5, and this is nothing but EC is 5000 under root FCK. Now, whenever you see the long-term static modulus, whenever you see the modulus ratio for long term, it is nothing but EC. So for EC value, it changed by 1 plus theta. Yes or no? 1 plus theta. So this 1 plus theta comes in the numerator. EC ES upon EC, this is nothing but 1 plus theta. So you can see by considering the long term effect, the modular ratio increases to increase it. Understood? So in the long term, the effect of the creep comes out. Okay. Whenever the effect of the creep comes out, it increases. It increases, guys. Option C, B is the correct answer. I hope it is clear. Yes or no? Now, moving towards the next question. Please answer this. Now, very good. Very good, Arun Kumar. The correct answer is, you can see in working stress design, if the modular ratio is M, okay, if modular ratio is M, okay, in the question it is given as modular ratio is M and steel ratio is R. Steel ratio is given as R. Okay, the critical neutral axis constant. This constant is given by very good. This constant is given by M upon M plus R. M upon M plus R. Understood, everyone? Clear? So the correct answer is option B. Option B is the correct answer. Very good. In the working stress method, you must have designed this formula K into D. Okay, K into D. So this K value is this modular ratio M upon modular ratio M plus R. Now moving ahead with the next question. Answer this question. This is a very good question. As per IS 456-2000, for a singly reinforced rectangular section, which of the following is correct? XU maximum is limiting value, limiting depth of the neutral axis by D for FE 415. So here three values are there for finding XU limiting or maximum, XU limiting or maximum, or rather XU maximum. Okay, this depends upon the grade of the steel. Okay, for FE for FE 250, FE 415, for FE 500 and FE 550. Okay, XU maximum is given as 415, XU maximum is given as. Now answer it very carefully. Very good. Now what is the value for FE 250? What is the value for FE 250? It is 0.53, guys, है ना? 0.53D, 0.53D, and for FE 415 it is 0.48D, 0.48D, 0.46D, and 0.44D, 0.44D. So this is how you will find the neutral axis depth for balance section. This is for balance section. Understood, everyone? Clear? अभी बताएंगे ये क्वेश्चन भी आएगा. Now answer it. Now XU for FE 415 it is not 0.84. For FE 415 it is 0.48D, option B. And the depth of the centroid of compression, always it is not 0.43. Depth of the rectangular position of the stress block is 0.38. It is wrong. Option B is the correct answer. Option B is the correct answer. Yes or no? We'll move ahead with the next question. Answer this question, guys. Answer this question. In a reinforced concrete beam design, the distance between the centroid of the area of tension reinforcement and maximum compressive fiber is known as. This is a very good question. Please answer it very carefully. Please answer this question very carefully. Please answer this. Look very carefully. Now listen. In reinforced concrete beam design, the distance between the centroid of the area of the tension reinforcement. These are tension reinforcement. Understood? These are tension reinforcement. The distance from the centroid of the tension reinforcement and the maximum compression fiber is this much. And this distance is known as effective depth. This is known as effective depth. Option C is the correct answer. Please don't be confused with lever arm. It is not lever arm. Understood? Shubhendu, it is not lever arm. It is effective depth. Please read the statement very carefully. The distance from, this is not lever arm. Lever arm is CG of the compression stress diagram to the CG of the reinforcement. That is lever arm. Understood, everyone? No, it is not lever arm. That is what I'm Shambhu Gupta, it is not lever arm, brother. It is effective depth. Now lever arm is, you can see, if I want to make the lever arm here, see, you can see this is the lever arm. So this is the stress diagram. So here the tension force, the CG of the reinforcement as well as CG of the compression area. This is lever arm. This is lever arm. But in the question you are asked with CG of the tension reinforcement to the topmost compression fiber. That is why it is effective depth. Understood? Okay, move ahead with the next question. This is a very good question. I'm pretty sure that you won't find this statement in your note copy. Now look very careful. For aggressive environment. Now aggressive environment means exposure condition as severe. You need to treat the exposure condition as severe. The assessed surface width of crack should not exceed. Now in the concrete, let us suppose this is the surface of the concrete. Okay, what happens is in the case of the aggressive environment, after the shrinkage, there are some cracks developed. So what is the maximum width of the cracks? What is the maximum width of the crack in case of severe environment? This is a very good question. No, the correct answer is no. You can see in case of aggressive environment, the maximum crack width should not exceed 0.1 mm. 0.1 mm. Please listen to me. The maximum width of the crack in case of severe environment or aggressive environment should not be more than 0.1 mm. And in no case, the width of the crack should exceed 0.3 mm. And in no case the width of this crack should exceed 0.3 mm. So for mild exposure condition, the width of the crack should not exceed 0.3 mm. Understood, everyone? But for severe environment condition, it should not exceed 0.1 mm. And whenever the concrete is in contact with aggressive soil, then aggressive soil or aggressive moisture, okay, then it should not exceed 0.2 mm. So you just need to remember these two values, that for severe condition it should not exceed 0.1 mm, and for any case it should not exceed 0.3 mm. Understood, everyone? Clear, everyone? So answer here is 0.1 mm. 0.1 mm. Okay, we'll move with the next question. Please note it down in your copy. I'm pretty sure that you won't get this data in your copy. Understood? Okay, Understood? In no case the width of the crack should exceed 0.3 mm, and for severe exposure condition it should exceed 0.1. Okay, in between them, in between mild or severe, in between mild and severe, okay, it should not exceed 0.2 mm. So this is the logic. This is the logic here. Clear? Hindi mein? Just a moment, I'll explain this in Hindi. Just for this question, I'll explain this in Hindi. That देखो, सीवियर कंडीशन में 0.1 से ज्यादा नहीं होना चाहिए, 0.1 से ज्यादा नहीं होना चाहिए, किसी भी केस में 0.3 से ज्यादा नहीं होना चाहिए, ये ध्यान रखिएगा. Again, this is a very good question. Now answer this question. No. Now you can see the factor of safety for steel in working stress method is, now you need to answer for steel and concrete both. Very good. In working stress method, this is not for limit state method. We are asking for in limit. Very good. Very good in limit state method. Now this question is for working stress method. The question is for working. Very good, Vignesh. Very good. In LSM limit state method, the factor of safety for concrete, the partial safety, or specifically partial safety factor for concrete is nothing but 1.5, and for steel it is 1.15. But here you are asked with the working stress method. Now see very carefully. In working stress method, you can see, I'll take one of the example. This is a very good question, guys. This is a very good question. Always student used to remember both the value of limit state method, but they forget to remember the value of working stress method. I'll derive you how the value of steel comes out to be 3, and for working stress method, factor of safety for concrete is factor of safety for concrete, it comes out to be 1.8. It comes out to be 1.7 to 1.8. So please do remember these two values, 1.7 to 1.8, and for steel it is 3. Understood, everyone? Now how it value comes out to be, you can see, if I take the M30 grade of concrete, M30 grade of concrete means FCK is equal to 30. Okay, and as per IS code, we test the concrete in cubes. We test the concrete in cubes, but we cast them in structure. So code says that you suggest the value of FCK as 0.67% of FCK. On this 0.67 FCK, you apply the factor of safety of 1.5. This comes out to be 0.44 FCK. This comes out to be 0.45 FCK. Understood, everyone? Now you can see very carefully, 0.67, it comes out to be 0.45 FCK. 0.45 FCK. So you can see very carefully, the value of 30 Newton per mm square is reduced to how much? 45% of 30. 45% of 30 will comes out to be roughly around 13.4. So it is nothing but, you can see, this value reaches up to 14. This value reaches up to 14. Yes or no? Yes or no? And for load factor, okay, Also you can see, now you can see in working stress method, if let us suppose I have taken M30 grade of concrete, FCK is 30 Newton per mm square. So what are the permissible values? What are the permissible value? If I see sigma CBC, what are the values of M15, M20, M25, M30? So you can see what are the values? 5, 7, 8.5 and 10. You can see 10 Newton per mm square. So you can see very carefully. Look at this value. FCK is 30 and you are permitting 10. You are permitting 10. Yes or no? So you can see that for concrete in working stress method, the value is 30 and you are permitting 10. So what is the factor of safety? Factor of safety is nothing but the value, the yield value is, characteristics value is 30, but you are permitting 10. So factor of safety is roughly around 3 for working stress method in concrete. And how about steel? And about steel, let us suppose we have Fe250. The yield value is 250 Newton per mm square. And how much you are permitting in permissible stress in steel? Sigma ST is nothing but 130 to 140. 130, I'll take 130 Newton per mm square. So what is the factor of safety? Factor of safety is nothing but the yield value is 250, but you are permitting 130 in it. What is the value? What is the value? Okay, if let us suppose you are permitting 140, if you are permitting 140, so you can see this value will comes out to be 1.78. So factor of safety in steel in working stress method is roughly around 1.8 and for concrete it is 3. In question you are asked with steel. So factor of safety for steel. Now for steel it is, no, I'm so sorry, for you are asked with the steel. So if it is steel is asked, you get the value as 1.7 to 1.8. Option A. Option A is the correct answer. Clear everyone? Clear? And for concrete it is B. Understood? We'll move with the next question. Please answer this question very carefully. Now answer this. Working stress method. Now this is a very good question. Working stress method is based on maximum shear stress, linear elastic theory, maximum distortion theory, material failure theory. What is the correct answer? Now in working stress method you can see we are always under elastic limit. We are always under. So yield value is 250. Yield value is 250 Newton per mm, but you are permitting how much? 130 Newton per mm square. So you can see this value is in elastic range as well as it is linear elastic. Understood everyone? So what will be the correct answer? What is the correct answer for this? Okay, linear elastic theory. So working stress method is nothing but linear elastic theory as well as it is a deterministic approach. And the limit state method is probabilistic approach. Understood? Now the next question. Answer this question. According to IS 456, simply supported beam of effective depth D. So effective depth is D for simply supported beam and the width is, effective depth is D and the width of the beam is B. Okay. Shall be so proportioned that the clear distance between the lateral restraint does not exceed. Now the clear distance between lateral restraint shall not exceed. Now answer it for simply supported beam. And answer it for cantilever beam. आइए बनाते हैं, फिगर बनाते हैं इसका. The correct answer here is, you can see, according to IS 456, simply supported beam of effective depth D and width B shall be so proportional that the clear distance between the lateral restraint does not exceed. You can see very carefully. Yes, very good, very good. For simply supported beam, it should not be more than 60B or 250B square by D. Which one is less? The lesser value, minimum value. And for cantilever beam, from the free end, the lateral restraint, okay, should not be more than 25B or 100B square by D. 100B square by D, the lesser value, minimum value is to be taken. Lesser value is to be taken. Understood? So option here, you are asked with simply supported beam, option A is the correct answer. Understood everyone? Option A is the correct answer. We will move ahead with the next question. Now answer this. This is a simple question. I will not mark the star on this question. It is a very simple question, although I have discussed this. The failure strain in axial and bending compression are respectively taken as the failure strain when the axial compression. What is the maximum strain in the axial compression? And what is the maximum strain in bending flexure? Bending compression. This value you always remember, 0.0035. Yes, very good. What is the correct answer for 33 question? Yes, this is the correct answer. In bending compression, what is the maximum strain? So when the concrete is treated to be fail, when the strain comes out to be 0.0035, and in the axial compression in the column, what is the maximum strain? 0.002. And for the third value is while casting the concrete, okay, what is the shrinkage strain? If no reinforcement is, minimum reinforcement is given to protect the shrinkage strain. What is the value of shrinkage strain? Please comment in the answer. Please comment. What is the shrinkage strain? जब कंक्रीट को कास्ट करते हैं तो कंक्रीट श्रिंक करता है, इसीलिए दैट इज व्हाई मिनिमम reinforcement is provided. Whenever we cast the concrete, the water from the pore gels evaporate out. Okay, so it gets shrinked, and minimum reinforcement is always provided to resist these stresses. So this value is 0.0003. Understood? Very good. Very good. So these three strain you need to remember. So here the answer is 0.002 and 0.0035. Option B is the correct answer. Moving with the next question. Answer this question. As compared to working stress method of design, limit state method takes concrete to, no, very good. As compared to WSM, in LSM, concrete to higher stress level, lower stress level, the stress level sometimes higher but generally lower stress level. Third option is please consider same stress level. Yes, very good. In working stress method, now 0.002 is plastic strain and 0.87 Fy upon ES is elastic strain. Whenever we pull a body beyond elastic limit and you remove the load, some of the strain left behind. Clear? Now here you can see in LSM the permissible values, the stresses are in the concrete are higher as compared to WSM. Understood everyone? So what is the correct answer? As compared to working stress method of design, limit state method takes concrete to higher stress level. In LSM, concrete are stress higher as compared to LSM. Understood everyone? So option A is the correct answer. Now answer this value. Answer this question. Answer this question. Now you can see which of the following characterizes the typical failure of over reinforced ratio higher than the balanced ratio. Okay, you need to compare this failure of over reinforced as compared to balanced section. So in over reinforced section, we provide the steel more than the balanced section. We provide the steel more than the balanced section. Hence neutral axis shift downward. Neutral axis shift downward. Yes or no? Neutral axis shifts downward. When neutral axis shift downward, what happens is the stresses in concrete, okay, the stresses in concrete reaches to their permissible value earlier than the steel, reaches the permissible value earlier than the steel. So here the stress in the steel sigma st upon m, the stress in the steel is less than sigma st upon n, but here the stress in the concrete reaches to the permissible value. Hence concrete failure is the brittle failure. Understood? So what is the correct answer? The steel yield, the steel does not yield. The concrete crushes and large deflection and tensile crack will be observed prior to failure. The steel yield, the concrete crushes and the beam fails suddenly without warning. Now please look option B and D. Very carefully please look option B and D. It is somewhat similar. Now we'll analyze this. The concrete crushes, okay, and large deflections and tension crack will be observed prior to failure. There will not be any tension crack. Understood? There will not be any tension crack because the stress in the steels are lesser than its permissible value. But yes, the concrete crushes, it is a brittle material, it fails suddenly. It fails suddenly. Understood everyone? Now moving toward the next question, the last question of the working stress method. Please answer it. The last question of working stress method. The limiting value of depth of neutral axis for concrete beam of overall depth. So the overall depth of the beam is given in the question as 300 mm and grade of the steel is Fe415. Now limiting value of depth of neutral axis for concrete beam of overall depth 300 mm. Okay, effective cover is 50 mm. Effective cover. So capital D is 300 mm. So in order to get effective depth, what we will do? 300 minus nominal effective cover is nothing but 50 mm. So the effective depth is 250 mm. So this is given in the question, and also you are given with grade of the steel Fe415. That's it. And from this data you need to find out. No, 144 is not the correct answer. No, Vignesh, this is not the correct answer. You need to apply the formula as XU limiting. So the XU limiting formula, if only the grade of the steel is given is 700 upon D upon, this was the formula that some of the students were asking in the comment section. 700 D upon 0.87 Fy plus 1100. Yes or no? 1100 plus 0.87 Fy. This was the formula you were talking about. So this gives you the maximum depth of the neutral axis. So look very carefully, 700, and what is the effective depth? Effective depth is nothing but 250 upon 1100 plus 0.87 into Fy. Fy value is nothing but 415. So you'll get the answer in mm. Understood? Here you need to use the, so this will comes out to be roughly around 120 mm. 120 mm, option D is the correct answer. Yes, also you can solve this very good. This was the formula. Also you can solve this because it is Fe415. So depth of the neutral axis is nothing but x limiting depth of neutral axis can also be taken as 0.48 d. So the effective value depth is 0.48 into d value is nothing but 250. Understood everyone? Also, yes, this was the mistake. Also you can get the answer from here also 120 mm. So if you remember the formula 0.48d, it is good. Also you can get the answer from here also. बिल्कुल कर देंगे भाई. आगे बढ़े. We'll move ahead. Now this is the next question, next chapter. Here now in this chapter we will be covering the 35 questions of next chapter, that is shear and anchorage. So now the next chapter, that is shear and anchorage. We will be covering 35 questions of this chapter. I hope you guys are enjoying these sessions. Trust me guys, it takes around 1.5 months to frame such questions such that all the concepts of chapters are covered. Clear? And these are most unique questions which are important for your PSC examinations. Now this is a very good question. In limit state design, permissible bond stress in the case of deformed bar is more than in the plain bar by what percentage? Now, in the limit state design, permissible bond stress, tau BD permissible value, okay, tau BD permissible values for plain bars are given as, for M20, M25, M30, this value you need to remember, M35, M40 and above. So these tau BD permissible values are 1.2, 1.4, okay, and then we have 1.5, 1.7, and then we have value as 1.9. So these are for plain bars, tau BD permissible value. But if the bars are of higher grade, okay, more bond strength will be there. Okay, so you need to increase the permissible values by how much percent? By 60%. By 60%. Understood everyone? Yes or no? For deformed bars, these permissible values are increased by 60%. As well as if the bars are in compression, these values are increased by 25%. But so here you are asked only by the deformed bar. Option D is the correct answer. Clear? 1.2, 1.4, 1.5, 1.7 and 1.9. This you need to remember. Understood everyone? Now moving ahead with the next question. Answer this question according to IS. Now please be careful. There are two IS code, that is IS 456. IS 456, I have given you the explanation that if the length of the member is more than 45 mm, you need to provide one or more than one expansion joint. Okay, more than one expansion joint, one or more than one expansion joints are provided. One or more than one expansion joints are provided. Yes or no? So it is for IS 456, but here you are asked with IS 3414. This is the code for expansion joint. So please put a star mark on this. This is also a very good question. (45 meter). No, please listen very carefully. In IS 456, it is given that if the length of the member is more than 45 meter, one or more than one expansion joint is provided. Okay, but in IS 3414, this value is reduced to 30 meters. So this code suggests that if the length of the member is more than 30 meter, provide one or more than one expansion joint. So this 45 meter reduced to 30 meter if the code is IS 3414. Please listen it very carefully. Please note down this value. This is IS code specifically for joints. Understood? Written everyone? Shall we move ahead? Shall we move ahead? So this is a very good question. We'll move ahead with the next question. Answer this question. A ready mix concrete supplier supplied 101 cubic meter of concrete. This is also a very good question. You'll most probably you'll get this question in your examination. If let us suppose I am the supplier of the concrete and I have supplied 101 cubic meter of concrete to your site. Okay, 101. Specifically I have taken 101. Specifically I have taken 101 cubic meter of concrete for a slab. As for the minimum sampling frequency, the number of cube sample required are. This is a very good question. A practical question. Now you can see if the concreting is in the range of 1 to 5 meter cube, 6 to 15 meter cube, 16 to 30 meter cube, 31 to 50 meter cube. Number of samples are 1, 2, 3, 4. Now above 50, now listen to me very carefully, above 50, that is above 51. What you will do, 4 plus 1 sample for additional 50 meter cube. For additional 50 meter cube. Now if it is in the range of 51 to 100, how much you need to add? 40 plus how much is this? 50. 50 is nothing but 51 to 100. 4 plus 1, that is 5. For 101 to 150, that is nothing but 4 plus how much is more than 50? 2 times, so it is 2, that is 6. So your answer will be 6. Option D is the correct answer. Option D is the correct answer. Vignesh, it is not 5, it is 6. Because 4 plus for additional 50. For additional 50 means 51 to 100. It is plus 1. For 101 to 150. In 4 you need to add 2. No. For now please, 4 plus 1 sample for additional 50 meter cube. 1 for additional 50 meter cube is yes, for 101 cubic meter. 101 cubic meter. Yes, option D is the correct answer. If it would have been 100 cubic meter, then the sample will be 5. Then the sample will be 5. Understood? So option D is the correct answer because it is 101 cubic meter. Understood? This is the logic. This is a very good question. Please note down this question, the data. Please note down these datas. Very good question, guys. Shall we move ahead? Okay, after the RCC, I'll take up the survey also. Okay, now please move ahead. Please move ahead. Answer this question. Just a moment, I'll be back in 1 minute. Okay. Just a moment, I'll be back in just 1 minute. I need to bring my water bottle. Just a minute. Now, what is the correct answer for this? What is the correct answer for this? We have seen this value, okay? As per IS 456, the minimum cement content for the respective durability class can be reduced by R kg per cubic meter while changing the maximum size of aggregate from. Now, if you have changed the maximum size of aggregate from 20 mm to 40 mm, you will decrease the, you can decrease the cement content by how much? By 30 kg per meter cube, by 30 kg per meter cube. Yes or no? But if you have reduced the aggregate size from 20 mm to 10 mm, what will you do? Okay, if you have increased the size from, decreased the size from 20 mm to 10 mm, this R value is plus 40 kg per meter cube. This is an important codal provision. Here the correct answer is option D. Here the correct answer is option D. Okay, we will move towards the next question. Now answer this question. Lap splices shall not be used without additional precaution beyond the bar of. This is a very good question. I am pretty sure that you will commit a mistake. I am 90% sure that you will commit the mistake. Very, very good. Very, very good. Because in most of the textbook, it is written as 36 mm. See, earlier it was 36 mm. The bars greater than 36 mm diameter are not lapped. Either they are welded. Understood everyone? But as per amendment, there is amendment in 2007. After that amendment, it is written that the bars, if more than 32 mm diameter, are not spliced, either they are welded. Okay, so now the correct answer is 32 mm. Earlier it was 36 mm, now it is 32 mm. Understood everyone? Yes, very, very good, Vignesh. Yes, this is the correct answer. Option C is the correct answer. Very good, very, very good. I was expecting that you'll give the answer as 36 mm because in most of the textbook you will find that the bars more than 36 mm shall not be, okay, they are welded. Very good, those. Now it is after amendment, it is 32 mm. Clear? Very, very good. Very good. Now we'll move towards the next question. Answer this question. Very good. The correct answer is option A. Option A is the correct answer. For vertical stirrups, the maximum spacing of shear reinforcement. Now look very carefully. For vertical stirrups, okay. So the distance between the vertical stirrups are, you can see this is the main reinforcement. These are shear stirrup. These are vertical stirrups. So near the support, the shear force is more, hence the spacing is less. But as you progress towards the center, the spacing is more. But here also near the support, the spacing is less. Okay. Now for vertical strip, the maximum spacing of shear reinforcement measured along the axis of the member shall not exceed. So the maximum spacing is, let us suppose spacing between the stirrups are SV. So the maximum spacing is okay, SV maximum. So the maximum spacing between them is, if the vertical stirrups are there, okay, we assume that the length of the crack is, so the length of the crack is D. At least there should be one stirrup in between the length of the crack. So what is the maximum spacing? If let us suppose these are the vertical stirrup, it is 0.7 D, 0.75 D, 0.75 D, and shall not be maximum of 300 mm. Understood everyone? 300 mm or 300 mm. So here the correct answer is option A is the correct answer. Option A. If it would have been the bent, if inclined stirrup bars, if it would have been the inclined, for inclined it is 300, it is D. Okay. For inclined it is D. Clear? Now moving towards the next question. Answer this question. In a rectangular beam of section B into D, subjected to ultimate torsional moment TU, equivalent ultimate shear can be given as, in a rectangular beam, okay, in a rectangular beam of section B into D. Now the section is B into D, it is a rectangular beam subjected to torsional moment. So there is a torsional moment of TU. So we don't give the reinforcement for torsional, except what we do is we take the additional reinforcement for shear and bending moment. So equivalent ultimate shear can be given as, so this is the factored shear force plus 1.6 time of the torsion divided by B. So what is the correct answer? This is the equivalent shear force, V equivalent. So we will give the reinforcement for this equivalent shear which is coming. So what will be the correct answer? The correct answer is VU plus 1.6 TU by B. VU plus 1.6 TU by B. So this is the correct answer. Option A is the correct answer. Understood everyone? Very good Vignesh, very good Vaisak, very good. Now we'll move towards the next question. Look. The percentage of steel as per IS recommendation in compression should not exceed. Now it is a question of beam, that the compression reinforcement should not be more than by how much percent of the total cross section area. Maximum compression and maximum tension reinforcement are how much percent of the total cross section area or gross area? Maximum compression reinforcement as well as maximum tension reinforcement shall not be more than 4% of gross cross section area, B into capital D. Hence the correct answer is option D is the correct answer. Okay, option D is the correct answer. Clear everyone? We'll move towards the next question. Answer this. The permissible value of local bond stress for M15. Okay, M15. The ratio is 1 ratio cement and 2 ratio sand and 4 ratio aggregate. है ना? 1:2:4. Cement concrete is permissible value of local bond stress. Yes, minimum value is AST upon BD 0.85 upon. Yes. Just now we have seen these value. Just now we have seen this value. What are the values for permissible bond stress? So now you can see for M20 tau BD permissible. Tau BD permissible was 1.5. Okay, for M25, for M30, M35 and M40 and above. M40 and above. Yes or no? For M40 and above. Clear? So the value is 1. No. 5 is not the correct answer. I'll give you the answer. Please don't worry. 1.2, 1.4, 1.5. This value is 1.2, 1.2, 1.4, 1.5 and then 1.7 and 1.9. So for M15, this value is, for M15, this value is 1 Newton per mm, 1 Newton per mm square. So you need to convert this in kg per centimeter square. Your task is to convert this into convert this for M15. You are asked with M15. Okay, you are asked with M15. So the permissible value is 1 Newton per mm square. Convert this into kg per centimeter square. And take the value of G as 10. You'll get the answer. Now look. 1 Newton per mm square. 1 mm has how many centimeter? 10 power minus 1. So there are 2. 10 power minus 2. So in order to convert Newton into kg, what will you do? 10 power minus 1. So you can see 10 power minus 1 is left. So this is 10 kg per centimeter square. So 10 kg per centimeter square is option B. Option B is the correct answer. Understood everyone? I hope it is clear. Because most of the students will remember these value 1.2, 1.4, 1.5, 1.71. So in the question it was asked for M15. M15 value is 10 kg and also we have converted them into kg per centimeter square. Understood everyone? Moving ahead with the next question. Answer this question. The shear strength can be ensured in a beam by providing. How will you ensure the shear strength in the beam? By providing binding wire on main wire, high strength deformed bar, rounded aggregate as well as stirrups. Now what is the correct answer? By which method you will strengthen the beam in shear? Now it is provided by, yes, very good. It is provided by stirrups. Okay, in beams stirrups are provided. In beams stirrups are provided. Understood everyone? So to strengthen the beam in shear. Clear everyone? So they take the shear. Understood? Now moving ahead with the next question. Now this is a good question. This is a good question. What is the distribution of shear in a rectangular beam? In a concrete rectangular beam. Now you can see. If you have remembered the value, this is nothing but. Now the shear distribution, if you need to plot the shear distribution, you can see. So above the neutral axis, there is a concrete section, so it is parabolic. Below the neutral axis, only steel will be taken. So steel will be taken. This is nothing but rectangular. This is rectangular. So you can see parabolic over and below the neutral axis is wrong in a reinforced concrete. If it is a reinforced concrete beam, so the answer will be parabolic over neutral axis and rectangular below neutral axis. Rectangular over neutral axis. Option B is the correct answer. Understood everyone? Option B is the correct answer. This is the shear distribution. Okay, this is the shear stress distribution along the cross section. Along the cross section. Understood everyone? This is along the cross section. Next question. Answer this question, guys. For bar in compression, the values of bond stress for M20 grade shall be increased by. Now, if it is in compression, we have just discussed it. For the bars in compression, the tau BD values, the tau BD permissible values are increased by 25% as compared to bars in tension. As compared to bars in tension. Yes or no? What will be the correct answer? What will be the correct answer? And for deformed bar, it is increased by 60%. Yes or no? Yes, option B is the correct answer. This is a simple question. Now moving ahead. Answer this question. Answer this question, guys. What will be the correct answer? The longitudinal shearing stress acting on the surface between the steel and the concrete are called the longitudinal shear stress. Now you can see, because of the unbalanced moment, okay, there is a unbalanced bending, unbalanced direct force remains in the beam. Because of that there is a, if this is a reinforcing bar and there is a concrete around it, so there is a unbalanced, so because of that unbalanced force, there is a shear which is developed on the surface of the concrete. So that is known as bond stress. Yes, very good. This is known as bond stress. The longitudinal shearing stress acting on the surface between the steel and the concrete are known as bond stress. Option A is the correct answer. Understood everyone? Okay. It's my humble request, if it is possible for you to please share the session, okay, amongst your friend. Okay, there are so many Telegram channels and also there are so many WhatsApp group of your college friends. Please share if possible, okay? Because I have given 1.5 months to frame these questions. So whenever someone put such an effort, and I'm taking this session on YouTube, so please share these session among your friends so that they get benefited from these session. Okay, and these are really good questions. You must have seen, this is the 4th class. Almost till now we have covered 100 questions, 100 to 120 questions we have covered till now. Okay, so you must have seen that I have not copied question from any book or any previous year. I have framed these questions in order to see that are very important for your upcoming examination. Understood everyone? So I am giving my 100%. I am on time. Okay, I am giving my 100%. A typed form of questions are there in front of you so that it looks good on the smart board. Okay, I am giving my time. So it's my humble request to please share the session amongst your friend. Okay, chale, moving ahead. Right, answer this question. If nominal shear stress tau V exceeds if there is a nominal shear stress is tau V, exceeds the design shear strength of concrete. So if this tau V exceeds the design shear strength of concrete, the nominal shear reinforcement IS 456 shall be provided for a shear stress equal to. Again, a very good question. Now you can see what is the correct answer. Very good. Now you can see the shear which is acting on the beam is, if nominal shear stress exceeds the shear strength of the concrete. So the shear reinforcement will be provided for tau V minus tau C. Tau V minus tau C. For this shear, the shear reinforcement will be provided. So there are 4 codal provision here. If the shear which is coming on the beam is less than tau c by 2, no shear reinforcement is provided. No shear reinforcement is provided. Understood everyone? Now if the shear which is coming on the beam is more than tau c by 2, but it is less than tau c, so you need to provide the minimum shear reinforcement. Understood everyone? So you need to provide the minimum shear reinforcement. Minimum shear reinforcement. But if this tau v is greater than tau c but less than tau c max, okay, so shear reinforcements are provided. Okay, shear reinforcements are provided for which value? Tau v minus tau c. And if the tau v value which is coming on the beam is more than tau c max, this section is redesigned. This section is redesigned. So these are the four codal provisions that you need to remember. Understood? So here the correct answer is option C. We'll move towards the next question. Again a very good question. Please put a star mark on this. What is the correct answer? Lap length including anchorage value of hook of bar in flexural tension shall be lap length including anchorage. You need to increase the anchorage value of hook of bar in flexural tension. So whenever the bar is in flexural tension, what is the very good. The correct answer is LD or yes, very good Vignesh. The correct answer is C. It is LD or 30, which is more, whichever is more. So development length LD or 30 times of the diameter of the bar, whichever is more. This is the answer. Option D is the C is the correct answer. C is the correct answer. Understood everyone? Moving towards the next question. Answer is a rectangular beam of width 200 mm and depth 300 mm is subjected to shear force of 200 kilonewton. The maximum shear stress produced in the beam is a very good question. Very good question. Direct tension is 2LD. Yes, very good Vignesh. 2LD or 30 mm. And what is the straight length of the lap? 15D or 200 mm. Yes or no? Straight length of the lap is 15D or 15 or 200 mm, whichever is more. Clear? So three values are there. Now a rectangular beam. So you can see the width of the beam is 200 mm. And how about the depth of the beam? Depth of the beam is given as 300 mm. Shear force is nothing but this factored. This is factored shear force of 200 kilonewton. 200 kilonewton. The maximum shear stress. Shear stress is the maximum shear stress. You need to find the answer. And it is a rectangular beam. It is a rectangular beam. This is a very good question. Please answer it very carefully. Yes. Now the average shear stress is, we know that the average shear stress is nothing but the V upon B into D. V upon B into D. So you can see very carefully 200. For kilonewton we convert this into Newton by multiplying by 1000 upon 200 into 300. So you can see this is nothing but 1000 by 100. 1000 upon 100. Clear? So this is 1000 upon 100 Newton per mm square, and we know that the maximum shear stress is nothing but in rectangular section the maximum shear stress is 3 by 2 of tau average. 3 by 2 of tau average. This will be completed as 3 by 2 of 1000 divided by 300. So this is 100. So this is 5 Newton per mm square. So without calculator you will get the answer as option C. Yes. Understood? So this is, now if this is a rectangular section, the value is 3 by 2. Can you answer me for Now we will move ahead with the next question. Answer this. Answer this question. The bond between steel and concrete is mainly due to the bond between steel and concrete. So there is a bond that the concrete will hold the steel reinforcement. Why? It is due to adhesive resistance, frictional resistance, mechanical resistance, and all of the above. This is a simple question. By logic, you can apply the answer. No. Here the correct answer is all of the above. By logic, you can apply the answer. Yes or no? Yes. The bond between steel and concrete is mainly due to adhesive resistance. Yes, it is due to adhesive resistance as well as for frictional resistance. There are some factors, mechanical resistance also. Understood? So all of the above is the correct answer. All of the above is the correct answer. So concrete holds the reinforcement. There is a bond between steel and concrete because of the adhesion, friction, mechanical purpose. All of the above is the correct answer. Now moving ahead with the next question. Answer this. The maximum shear stress for M20 grade of concrete is. Now here you can see the maximum shear stress for M20 grade of concrete. So you are asked with the tau C maximum value. Now for tau C maximum value for M20 grade of concrete. Now you can see this value 2.8, 3.5. This value is in LSM. So just remember the value of LSM, tau C maximum. So grade is M20. Okay, M20 or rather M15. M15, M20, M25, M30, M35, M40 and above. And above. M40 and above. Yes or no? So these values in LSM. LSM values are LSM value for tau C max. For tau C max and for WSM, the value for tau C max. Both have different values 2.5, 2.8, 3.1. Okay, so the yes, very good Vignesh. The value is 2.5, 2.8, 3.1, 2.5, 2.8, 3.1. So here the value is 3.4, 3.1, 3.5, 3.7, 3.5, 4. So these are the values for LSM. These values you need to remember: 1.6, 1.8, 1.9, 1.6, 1.8, 1.9. So you can see you are asked with M20. So 2.8 and 1. There is no option 1.8. Hence you will go for 2.8. 2.8 is the correct answer. 2.2, 2.3, 2.5, 2.2, 2.3. Option A is the correct answer. Clear, everyone? Clear? Moving ahead with the next question. This is a simple question. This is a very simple question. Answer it. Spacing of shear stirrup in RC rectangular beam. Now the shear stirrup spacing is, now you can see in the beam, okay, in a simply supported beam. I give you the example of simply supported beam. Okay, the shear force diagram is, if it is a point load or it is a UDL, if it is a simply supported beam subjected to UDL, the shear force diagram is nothing but the shear force diagram is shear force diagram is, yes, very good. This is a very simple question. Okay, you can see the maximum shear is at is at the support, hence the spacing is less, and at the center if the shear force is less, so spacing can be more. So as you move towards from the support towards the center, spacing decreases, spacing increases. So spacing of the shear strip in RC rectangular beam is kept constant. No, it is not kept constant. Decreased towards the center of the beam, increased. So decrease is not increased. Okay, increased toward the center of the span. So correct answer is option. No. Look, no. Increase at the end. I'm so sorry. Decrease towards the center. No, it increased. Increase at the ends. No, it is not increased. Decreased. So increase towards the center of the span. Option D is the correct answer. Yes, option D is the correct answer. Now moving ahead with the next question. Answer this. The shear strength of concrete depends upon the shear strength of concrete depends upon which values? Okay, the grade of concrete, percentage of longitudinal tensile reinforcement, shear reinforcement provided, all of the above. The shear strength of concrete. Now look, this is shear strength of concrete. Tau c maximum value depend not. The shear strength of concrete depends upon the grade of the concrete. Yes, it depends upon the grade of concrete, as well as it depends upon the percentage longitudinal reinforcement, as well as shear reinforcement provided. Hence the correct answer is option D. Hence the correct answer is option D. So shear strength of concrete depends upon all the factors which is given in the question. Now if it is if in the question it was asked as maximum shear strength of concrete, it depends on maximum shear strength of concrete, that is tau c maximum value. It depends upon grade of concrete only. So here maximum term is not there. That is why option D is the correct answer. Understood everyone? Vaisak, understood? Understood? Yes or no? Option D is the correct answer. Clear everyone? If it would have been the maximum shear strength of concrete. Now in the previous question only we have seen the value of maximum value of the shear strength of the concrete. It depends only on the grade of the concrete. But if it is the shear strength of concrete, that is only tau c value. It depends upon the grade of the concrete as well as longitudinal reinforcement as well as shear reinforcement. Hence option D is the correct answer. Clear? Moving ahead with the next question. This is a simple question. I will not mark star mark on this. It is a very simple question. The development length of the bar. So LD length is development length of the bar as per IS 453 given by, so you can see 4, no, this is nothing but 5 into times of the permissible stress upon sigma s upon 4 times of tau BD. 4 times of tau BD, permissible bond stress. Tau BD is permissible bond stress. So what is the correct answer? What is the correct answer? So stress in the bar is sigma s, 4 times of tau BD. Okay, permissible bond stress. So what is the correct answer? Option B is the correct answer. Option B is the correct answer. Understood everyone? Shall we move ahead? No. Next question. If diameter of reinforcement bar is D, anchorage value of the hook alone will be, for hook alone will be, what is the, very, now it is for hook have 180 degree bend, hook is 180 degree bend, so you can see 180 degree, for 180 degree it is, now we have seen for 90 degree, okay, for 45, 90, 135, and this, what will be the correct answer for hook? If diameter of the reinforcement bar is D, if D is the diameter, anchorage value of the hook alone will be, what will be the anchorage value? Yes, very good. For hook it will be 16D or 16.5, okay, or 16.5. Yes, option D is the correct answer. Moving towards the next question. Please answer it very carefully. Again a codal provision. What will be the correct answer? Here two options are correct. Please remove this value. Please do not consider this value. Now answer it, because option A and C was similar. Option A and C was similar. Now the minimum shear reinforcement formula, this is given in. Now you can see, to avoid sudden collapse just after a shear crack, minimum shear reinforcement is provided in pre-stressed concrete in the form of stirrup. So as per IS 1343, now remember this minimum shear stirrup formula was given in IS 1343, okay, 1980. So this is the IS code, IS 1343, IS 1343 1980. So this is clause number 24, 1343 1980. Okay, so minimum shear formula is nothing but ASV is the area of the shear stirrup into B times of the spacing of the shear stirrup is equals to 0.4 times of 0.87 Fy. 0.87 Fy. So you can remember this 0.87 Fy into ASV should be more than how much? 0.4 times of the B into SV. This line you need to remember. 0.87 Fy into SV is equals to 0.4 B into SV. Understood? Okay, so option C is the correct answer. Clear everyone? Option B is the correct answer. So this much is the minimum shear reinforcement you should provide. Okay? Yes. Even it is for pre-stressed concrete. Okay? Understood everyone? Moving towards the next question. Shear failure at section of beam without shear reinforcement normally occur on plane inclined at an angle to the horizontal. Now you can see that how the failure of the beam takes place. Okay, so how the failure of the beam takes place, shear failure takes place. So this crack will develop like this. This crack will develop like this. So it is at an angle of 45 degree. It is at an angle of 45 degree. Understood everyone? So the correct answer is option B, to the horizontal. Understood? 45 degree to the horizontal. Okay, you can derive this by taking the stress diagrams. Okay, from SOM you can derive, from the concepts of strength of material you can derive the concepts. Understood everyone? Clear everyone? No, the correct answer is 45 degree. It is diagonal shear failure. Okay, 45 degree diagonal shear failure. Next, this is a very good question. Please put a star mark on this. If a bar is cranked at both the ends at an angle of 30 degree, the extra length required when compared to the straight bar is D, center to center distance between the top and the bottom steel. What will be the correct answer? Okay, please put a star mark on this. I'll in the next lecture, please put a star mark on this. Okay, please put a star mark on this. Okay, in the next class, I'll derive this expression. Okay, answer this. If the bar is cranked at both the ends at an angle of 30 degree. So this you have cranked. Okay, for one side we will analyze. This is cranked at a length of 30 degree. This distance is D. This distance is D. Okay, so here the correct, this you need to remember, but if you do not remember, it's okay, don't worry. So you can see very carefully, this is 30 degree. So see, sine 30 degree is, so you'll get this value. Sine 30 degree is D upon hypotenuse. Okay, so this hypotenuse value is D upon sine 30 degree. Okay, and how about this base value? This base value will be tan 30 degree. Tan 30 degree equals to perpendicular by base, D by B. So this base will be equal to D by tan 30 degree. D by tan 30 degree. Just remember these two value. Okay, so H is nothing but this value is 2D. This value is 2D. So how about this value? This value is tan 30 degree is, okay, this value is nothing but 1.73D. This value is 1.73D. This you need to remember. So this value is 1.73D. If the bar is not cranked, the length was 1.73D, but now the length is 2D. How much extra you have given? 2D minus 1.73D. Yes or no? 0.27D. So this is nothing but 0.27D. Now the crank is given on both the side. If the crank is given on both the side, 0.27 into 2 times of D. So this will be equal to 0.27 into 2 times of D is option B. Understood? Clear everyone? Clear? Understood everyone? So how much extra you have given? You have given 0.27D extra length by giving the crank bars. Understood? Shall we move towards the next question? Okay, so last question for today's class. Answer this. Now in the question, a rectangular beam of size, the width is nothing but 230 mm and the depth is nothing but 350 mm. It is effective, it is given in the question. The factored shear force acting at a section is 80 kilonewton. So this is the factored shear force which is acting at a section. If the permissible shear stress in concrete is tau c value is 0.25. So how much is the concrete can can resist the shear, which is nothing but 0.25 into 230 into 350. So this cross section can resist the shear of this value. The design shear force is nearly. So the design shear force is nearly, you can see. So in 80, you subtract this value. So this value comes out to be Newton per mm square. So in order to convert this in kilonewton, multiplied by 10 power minus 3. Okay. 0.25 into 10 power minus 3 to 230 into 350. This value will comes out to be, you can see, and from 80 subtract this value, so 0.25 into 230 into 350 into 10 power minus 3. So you'll get the answer in kilonewton. This is your answer. So this is roughly around 230, 350. This will be roughly around 20 kilonewton. Option D is the correct answer. Option D is the correct answer. Understood, everyone? So guys, last seven question. Do you want to continue the last 7 question, or you want the 7 question tomorrow? Answer in the comment. There are 7 question which is left in this chapter. You want this 7 chapter now to finish off this chapter, or you want these 7 questions tomorrow? We are about to finish this chapter. There are last 7 question which is left. Answer this. Answer this question. As per IS 456-2000, for the design of reinforced concrete beam, the maximum allowable shear stress tau c max depends upon. Just now I have told you that the maximum shear stress depends only on grade of concrete and grade of steel. Grade of steel only, grade of concrete and percentage of reinforcement, grade of concrete. This is a very good question and simple question. Tau c max value depends upon, it depends only on grade of concrete. It depends, tau c maximum value depends only on grade of concrete. Yes or no? Grade of concrete. It depends only on grade of concrete. Option D is the correct answer. Yes. Moving ahead. Answer this question. A column of size 450 has unsupported length of 300 and is braced again sideways in both directions. The minimum eccentricity is with respect to major and minor principal. This is the question of column. Okay. This I'll again explain you. But this is a simple question. About what it is, eccentricity about major axis. Eccentricity about major axis. L upon 500 plus D upon 30. Answer this. Minimum eccentricity is L upon 500 plus D upon 30. Yes or no? Plus D upon 30. So what is the unsupported length? This is 3 meter. So here the D is the bigger value. The bigger value is 600. Yes or no? Yes or no? So eccentricity about the major axis is nothing but, length is nothing but 3000 mm. 3000 divided by 500 plus what is the D? That is 600 divided by 300. So this is 2 and this is 6. So this is nothing but 6 or 2. 3000 upon, what will be the correct answer? 26. Yes or no? 26. Okay, so 26 mm is the correct answer. So only option A or D. So for what about the minor axis? Eccentricity about the minor axis will be equal to L upon 500 plus B upon 300. Okay, so your answer will be, so here the answer will be upon 30. I'm so sorry, this is D by 30. 3000 divided by 500 plus this is nothing but 450 divided by 30. 15 6 21. So your answer will be 26 and 21. Option B is the correct answer. Understood everyone? Next question. Answer this question. A simply supported beam having 200 mm width and 450 mm depth supports a total uniformly distributed load of this much Newton. The nominal shear stress will be, so nominal shear stress is nothing but VU upon BD. You will get the answer. This is a very good question. So this is nothing but 200 kilonewton. This is nothing but 200. This is 200 kilonewton. Answer this question. This is a good question. Answer this question, guys. Yes. This is 200 mm width and depth is 450 mm. Okay. So you can see very carefully. Effective depth supports a total uniformly. UDL is 200 kilonewton. The nominal shear stress. So first of all, we'll find out the shear force. So shear force will be half of the load. Yes or no? Half of the load is nothing but 100 kilonewton. Half of the load is 100 kilonewton. So what is the nominal shear stress? V upon BD. V upon BD. So this 100 kilonewton, this is B in D is 200 into 450. 200 into 450. So convert this into kilonewton, you will get the answer. Okay. So 100 into kilonewton will be equal to, Newton will be equal to 1000. So this is your answer. So from here you will get the answer as 1.1 Newton per mm square. 1.1 Newton per mm square. Option B is the correct answer. Yes or no? I guess option B will be the correct answer. Yes or no? Yes. Next question. It is a simple question. Answer it. This is a very simple question. At limit state of collapse in shear, please remember, in shear, limit state of collapse in shear, in case of web shear, it is assumed that concrete cracks when the maximum principal tensile stress exceeds the value of Ft equal to, so the stress now you can see, look, here you can see this is a symmetrical beam. Look, this is a symmetrical beam, yes or no? If it is a symmetrical beam, okay, and it is UDL of how much? The UDL, the distributed load, the uniformly distributed, it is equals to 200 kilonewton. 200 kilonewton. So this is the total load which is distributed equally. This is the total load which is distributed equally. So how much will be the support reactions? How much will be the support reaction? Will be half of it. That is 100 kilonewton here, 100 kilonewton here. Understood everyone? So what is the maximum shear force which is at the support, which is equals to this reaction only? Yes or no? You are confused with WL by 2. Now in UDL what happens is, you must have studied this. Now look, for UDL you must have studied this. This is the shear distribution. Yes or no? Okay, so this is WL by 2 and reaction here is also WL by 2. Yes or no? When this intensity is given as W kilonewton per meter. When this intensity is given as W kilonewton per meter. But here in the question, this total concentrated load is given as 200 kilonewton. So the half of the reaction 100 kilonewton here, 100 kilonewton here. Yes or no? So half this total value is, so here the total value is given as 100 kilonewton. Here the total value is given as 100 kilonewton. So what is the maximum shear force? It is at the support which is equal to 100 kilonewton. So instead of giving the UDL intensity, he have given you the 200 kilonewton load. This is the given. So this total load, it is not intensity, this total load is distributed along the beam. Yes or no? So that was the confusion, that was the trick of that question. So this 100 kilonewton is to be remembered. Yes or no? So if you need to convert this into UDL intensity, how will you convert this into UDL intensity? 200 kilonewton for how much length of the beam? So since length of the beam is not given, understood? Length of the beam is not given, so directly he have given you the constant this load. Understood? Now answer this question. Yes. Now please remember that at limit state of collapse in shear, in case of web shear crack, that the concrete cracks when the now maximum principal tensile stress, whenever it exceeds maximum principal tensile stress, whenever it exceeds 0.24 under root of FCK, there is a crack in the concrete. Understood everyone? Because the principal tensile stress is more than this permissible values, and concrete is weak in tension. Yes or no? Hence the correct value is option A. Please put a star mark on this value. Next question. Answer this question, guys. In the design of reinforced concrete beam, the requirement of bond is not getting satisfied. The economical option of satisfy the requirement of bond is by, now let us suppose if there is a less bond strength, okay, and you need to increase the bond strength. How will you increase the bond strength? I give you the hint. There is a football. And you converted this football into 4 tennis ball. Okay, into 4 smaller ball. So you can see. So the logic behind is this surface area is this much. This green one. Now the surface area have increased. So smaller the diameter, more is the surface area. If more is the surface area, more is the contact of the concrete and the steel. Hence, more will be the bond strength. Yes or no? More will be the bond strength. So if it is not satisfied, you will provide the smaller diameter bar more in number. Option B is the correct answer. Yes or no? Option B is the correct answer. Moving ahead with the next question. Again a very good question. Please answer it. A codal based question. So area of the shear stirrup, minimum shear reinforcement in the form of stirrup shall be provided such that total cross section area of the stirrup, SV is spacing along the length of the member, width of the beam, and F the characteristic strength of steel. Characteristic strength of steel is Fy. So we know that 0.87 Fy into ASV, this area of the stirrup should be more than 40% of 0.4 times of B into SV. This is the condition. So this area of the stirrup should be more than this. So lesser equal to, so the correct answer is option A. Correct answer is option A. Yes or no? Moving ahead with the next question. Again a good question. Please answer it very carefully. Answer it very carefully. As per IS 456-2000 standard, the average permissible bond stress for plain bars in M25 grade of concrete is? Average permissible bond stress. Now please look very carefully. It is 0.8. No. Now look, this is tau BD, average permissible. Now this is average permissible bond stress. Okay, average permissible. This is not maximum value. Average permissible bond stress. M15, M20, M25, M30, okay, and so on. So what is these values? What is these values? So for M15 it is 0.6, okay, 0.6 and then 0.8, then 0.9, then 1. You can see for M25, so this for M25 this value is 0.9. For M25 this value is 0.9. Understood? I hope it is clear. Yes or no? I hope it is clear now. Yes or no, guys? Please note down. Yes, this is the average permissible values. Okay. Now it is clear. So the correct answer is 0.9. Last two question. So answer it. Flexure, shear, bond, deflection. Answer. Now deflection can be controlled by span by depth ratio. Bond. Okay, flexure. So longitudinal reinforcements are given for flexure, stirrups are given for shear, and anchorage values is for bond. So D1. So which option for D1 and A2? Option D is the correct answer. Option D is the correct answer. Understood everyone? Option D is the correct answer. Clear? Moving away towards the next question. This is a simple question. Last two question. Okay. So this is the simple question. We have covered this question. The anchorage value for standard U-type hook as per IS shall be how many times the diameter of the bar? So the anchorage value for hook is 16 times of diameter of the bar. For this is option B. Option B. Okay. Last question for today's class. Answer it. This is also simple question. Just now we have seen this value. Okay. Last question for today's class. The spacing of the nominal shear reinforcement. Now we have seen the formula as 0.87 Fy into ASV should be greater than equal to 0.4 times of B into SV. This SV is spacing. This can be written as 0.87 Fy into ASV upon 0.4 into B. 0.4 into B. So which option is correct? Which option is correct? Option A is the correct answer. I hope it is clear. So this is it for the concepts of shear and anchorage. I have almost covered all the concepts such that all the concepts of this chapter will be covered. In today's session, we will be covering the singly and doubly reinforced beam. Okay. So design philosophy we have covered. So in today's session, I'll be covering singly and doubly reinforced beam, and these sessions are very important for your upcoming RRB JEE examination and as well as for your state PSC examination. Understood? Okay, we will start the session, guys. So before starting the session, this is the Telegram channel. The annotated file of the annotated PDF of this lecture will be shared on this Telegram channel. You can scan this Telegram channel, okay, and you'll reach to my Telegram channel. Please join that. Okay, the PDF of this lecture will be available on this Telegram channel. Understood, everyone? So we will start the session. In today's session, I'll be covering, just a moment. In today's session, I'll be covering the singly and doubly reinforced beam. Okay. Clear, everyone? Singly and doubly reinforced beam. So we will be covering singly and doubly reinforced beam in this lecture. So chapter singly and doubly reinforced beam. Okay, let's just start with the session. Okay, this is the first question. This is the first question. Answer this question, everyone. Answer this question. What will be the correct answer? Everyone who are watching this class, please answer this question. The question is, the maximum area of tension steel in a beam shall not exceed. So in today's session, I'll be covering the codal provision for beam, and in next class, I'll be covering the codal provision for slab, and in next class, I'll be covering the codal provision for columns. Okay, so this is how we will cover the RCC. Okay. Anshu Sood, yes, the correct answer is C. Very, very good, everyone. Now you can see the maximum area of tension steel in beam as well as maximum area of the compression steel in beam. Okay, both the values, maximum tension area as well as maximum tension area as well as maximum compression area of steel. Maximum compression and tension area of steel, both values are 4% of gross cross section area. Please mind it, this is total depth. Understood, everyone? And what is the minimum area? Minimum area is AST upon BD, AST minimum upon BD. Okay, BD is equals to 0.85 upon Fy. Now answer me, here the D value is the effective, or here please remember that this D value is effective. Okay, it is not total depth. So for minimum area, you need to consider the effective depth, but for maximum area you need to consider the total depth. Understood? So the question answer for this question is option C. Now moving ahead with the next question, please answer this question very carefully. The size of the rectangular section. Now this is also a very good question. Please answer this question very carefully. The size of rectangular section is fixed, and the moment of, now for a rectangular beam, okay, the section you have fixed, understood, everyone? The size of the rectangular section is fixed, and the moment of resistance of singly reinforced section is less than design moment. So you can see the size you have fixed. There is no way you can change the size of the beam. Understood, everyone? And the question states that, and the moment of resistance of singly reinforced section, the moment of resistance of this section is less than okay, is less than design moment. Understood everyone? Is less than design moment. So the moment which is coming on the beam is more than the moment of resistance. So what you will do? You will go for over. Now there is only one option, that you can change the area of the steel. Either you go for under reinforced, over reinforced, doubly reinforced, or compressive. You will go for doubly reinforced. Understood everyone? Code suggests that you go for doubly reinforced. Understood? In order to increase the moment of resistance. So there is no option to change the section. So you will go for doubly reinforced section. So our preference is to go for doubly reinforced either than over reinforced. Understood? So this is how we will solve the question. In the next question, please solve this. A simply supported reinforced cement concrete beam shall be deemed to be deep beam. Now this is a good question. Which beam is said to be deep beam? Which beam is said to be deep beam? Now I'll show you. This is one of the beam, and this is one of the beam. You can see the difference of diagram in both the diagram. This is a deep beam. Okay, so deep beam, a simply supported reinforced. This is a simply supported reinforced cement concrete beam shall be said to be deep beam if its effective span to depth ratio. Now you can see very carefully, for deep beam, span to depth ratio is in the range of 2. For simply supported beam, it is 2. It means that the span is just twice of the depth for simply supported. For simply supported beam, it is 2, and for continuous beam, a beam is said to be deep beam when span by depth ratio is 2.5. So the correct answer will be option C. Understood? The correct answer is option C. Now please remember, this depth is overall depth. Here the depth is overall depth. Understood everyone? And deep beam is designed for we'll solve one more question on this. Okay. Understood everyone? Written everyone? So the span, the effective span to the depth, overall depth, this ratio is span to overall depth. This ratio is, okay, this ratio is 2 for simply supported and 2.5 for continuous beam. I hope you have understood this point. Now moving ahead with the next question. Answer this question, guys. The deflection of beam and one-way slab can be controlled by using the appropriate. This is also a simple question. Answer this. What will be the correct answer? This is a very simple question. Now, the deflection of beam and one-way slab can be controlled by using. So, deflection of the beam can be. Now, this is a serviceability criteria. Yes, very, very good. So, deflection of the beam is in the permissible limit when span by depth ratio. This for span up to 10 meter. For span up to 10 meter, the span by depth ratio, okay, for cantilever, for simply supported, and for continuous. So it is 7, 20 and 26. So 7 is for cantilever, Okay, 20 is for simply supported and 26 is for continuous. Understood everyone? I hope it is clear. Understood? We'll move towards the next question. So span by depth ratio is the correct answer. Answer this question. Answer this question. What will be the correct answer? What is the correct answer for this? Now you can see very carefully the basic value of span to effective depth ratio for a span up to 10 meter for a continuous beam. Now as per IS 456-2000 for a continuous beam, just now I have written this, the correct answer is 26. Understood everyone? Now moving towards the next question. This is a good question. This is a good question. Okay. So no criteria is given and you are asking about the maximum Now this is a good question. Please answer this very carefully. What will be the correct answer? Very good. Very good. Because there is a confusion of span by 250 and span by 350. Okay, there are two codal provision. Let us suppose this is a beam. So what is the maximum permissible deflection? Okay, what is the maximum permissible deflection? Now you can see very carefully if you consider all the loads, temperature, effect of creep. Now look very carefully. If you have considered all the loads, temperature, okay, effect of creep, then the maximum permissible deflection from the cast level. This is the cast level. Let us suppose the beam have deflected like this. So what is the maximum permissible deflection? You can see from the cast level, this have moved to this level. Understood everyone? So if you have considered the effect of load, creep, temperature, see maximum permissible deflection is span by 250, span by 250. But if let us suppose this beam contains some partition wall, this beam contains some partition wall. Let us suppose there is some partition wall on this beam, or let us suppose there are some finishes. Finishes means tiles above this beam. Understood? Tiles above this beam. So what will be the maximum permissible deflection? The permissible deflection will be less because there are some partition wall. So deflection is span by 350 or 20 mm, whichever is less. So among both the values, which is the maximum? Span by 350. Understood everyone? Abhishek, not smoothen by. This is not steel structure. Smoothen means, देखो smoothen तब होता है जब क्या होता है आप steel structures में smoothen और machined की बात करते हैं. This is the RCC structure. Understood everyone? So we will talk about the finishes. Finishes means you have placed the tiles above it, not smoothened. Understood everyone? Okay. So here among these two values, what is the maximum? Span by 250 is the correct answer. Clear everyone? Now moving towards the next question. Answer this. Side face reinforcement shall be provided in the beam when the depth of the web in the beam exceed. So this question already we have covered. Okay. So when you give the side face reinforcement, whenever the depth of the beam exceeds understood? Side face reinforcement shall be provided in the beam when depth of the beam web in the beam exceed This question we have covered. So the depth of the beam exceeds 750 mm. So how much reinforcement? 0.1% of the web area we will provide at a maximum spacing of 300 mm. At a maximum spacing of 300 mm. Yes or no? Okay, this we have already covered. Option B is the correct answer. So most probably you will find some easy question in today's class because already we have covered in the 4 lectures. Okay, so the basics of this chapter we have already covered in the starting 4 lecture. Understood everyone? Now tomorrow's most probably in the next class we'll be covering the concepts of slab. Okay, that is very important. Slab and columns are very important. Clear everyone? Now moving ahead, please answer this question very carefully. Please answer this. This is a very good question. Okay, a simply supported Now this is a very good question. Please put a star mark on this question. This is a fantastic question. A simply supported reinforced concrete beam having clear span of 5 meter and support width 300 mm has the cross section as shown in figure. This is the cross section which is shown in the figure. What is the effective span of the beam as per IS 456? This is a very good question. Effective span you are asked. Very good, very good Sachin, very good. Good morning, bhai, good morning. Very good. So this is the question of simply supported, a simply supported RC beam. So this is a simply supported RC beam. Okay, having clear span of 5 meter. Look very carefully, clear span of 5000 mm. 5000 mm. This is the clear span. Okay, the support width is 300 mm. The support width are 300 mm. Here also the support width are 300 mm. Yes or no? 300 mm is given in the question. Okay, what is the effective span of the beam? So effective span of the beam is L plus D or L plus W by 2 plus W by 2, whichever is less. Okay, so L plus D as well as now you can see very carefully. So here 400, now you can 400 mm is the effective depth. Okay, so this you need to consider the effective depth, L plus D or L plus half of the width on both side, half of the width on both side. Understood everyone? Yes or no? Half of the width and half of the, it means center to the support. Okay, minimum of both the values. So L means 5000 plus 400, and here also the length is 5000 plus W by 2 means 300 by 2 plus 300 by 2. So you will get the answer as 5300. Here you will get the value as 5400. So what is the minimum value? Minimum value is 5300. Option A is the correct answer. Understood? Clear? Moving ahead. This is a good question. Deep beams. Answer this question. What are deep beams? Now you can see, आप लेट हो गए भाई, जस्ट अभी मैंने बताया था. If the span by, now if let us suppose this is the beam, one of the beam is like this, there the span is more but depth is less. Span is more but depth is less, but here the span is less but and depth is more. So span by depth ratio, if span by depth ratio is, let us suppose 2. Okay, for simply supported beam, if span by effective span by total depth. This depth here is total depth. If the effective span to the total depth ratio is 2, it is beam is known as deep beam. And for continuous beam, if this value is 2.5, then the beam is known as deep beam. Understood? So deep beams are designed for, okay, they are designed for bending moment, but they are checked for shear force. Understood everyone? Sachin, uske liye I have taken one question. In slab. Okay. From that question, I'll take the data. Then only you will be able to understand. Okay. So wait for next class. Clear everyone? So they are designed for bending moment. Deep beams are designed for bending moment, but they are checked for shear force. Clear? Moving ahead. This is a very good question. Please put a star mark on this question. For a simply supported beam of span 12 meter, now here the span is more than 10 meter. Understood? Here the span is more than 10 meter. The basic value of span to effective depth ratio. For simply supported beam, you can see the span by depth ratio. The span by depth ratio is equal to, for simply supported beam, it is equal to 20. Understood? It is equal to 20. Now, if the span is more than 10 meter, this value is multiplied by 10 upon span in meter. This value is multiplied by 10 upon span in meter. Yes or no? So 20 value is multiplied by 20 into 10 upon span in meter. Understood everyone? So this is the value. So you can see very carefully. So 6, this is 6 and this is 5. 100 by, so 50 by 3 will be the correct answer. 50 by 3 will be the correct answer. Option D is the correct answer. Yes or no? Clear everyone? So this is a good question. Here 12 you need to put in meter. So 10 upon span, which is in meter. So here the span is given as 12 meter. So you will consider the beam to be safe in deflection, that the deflection is permissible limit. The span by depth ratio is 50 by 3. The span by depth ratio will be 50 by 3. Understood everyone? Next question. In a singly reinforced balance section, if M30 concrete and Fe415 steel is used, then the value of neutral axis K in LSM. In LSM, please mind it, the value of this value is in LSM. Understood? For Fe415, what is the value of K? For Fe415, what is the value of K? So neutral axis depth factor. So X limiting value, limiting value of the depth of the neutral axis K into D. So this K value is 0.48 for Fe415. Yes or no? For Fe415. So what will be the correct answer? Option C is the correct answer. Getting my point everyone? Yes or no? Yes. Moving ahead. This concept just now we have covered. Now maximum allowed deflection in simply supported RC beam span L under uniformly distributed load including long-term elastic and shrinkage effect. Now whenever you have considered the shrinkage, creep, load, temperature, these effect you have considered, what is the maximum permissible deflection? Maximum permissible deflection in this case is nothing but L upon 250. But whenever you have considered the partition also, whenever you have considered the effect of creep, shrinkage, load, temperature, okay, then the value is L upon 350. Then the value is L upon 350. But here you are asked with only with the shrinkage effect. Understood? So your answer will be option B. Okay. Understood everyone? Whenever finishes, partitions are there, then it is L by 350. Clear? Next question. Please answer this question. The maximum area of tension reinforcement required for a rectangular beam of section, okay, 25 mm effective cover. This is also a good question. What is the maximum area of tension reinforcement? Apply your logic. Apply your logic. What will be the correct answer? Now, without calculator, you need to solve the question. The minimum area of tension reinforcement. So, AST upon BD. This will give you, this is the effective depth, is equals to 0.85 upon Fy. So, you can see what is the minimum area of tension reinforcement? 0.85 into BD. BD. Width is nothing but, width is 200 and depth is, the effective cover is given as 25. So this will be 375, okay, upon Fi. What is the grade of the steel? 415. This is your answer. This is your answer. You can see very carefully. Now you need to solve this question by without calculator. Will you be able to solve it without calculator? Now you need to apply the logic that. Now apply the logic is, you can see very carefully. Now the option here is also nearby. Option here is also nearby. If let us suppose options are wide in the range, you can consider this as 0.85 into 200 into 375 upon, let us suppose if this is 400. So this is nothing but half, this is nothing but 0.42. It means 40% of 375. 40% of 375. Yes or no? 40% of 375. This is how you will answer the question. Clear? So roughly around you will get the values as, so you will get the value as 164. Clear? Either you have the virtual calculator, you can solve the correct value, but if you do not have the calculator, you need to apply the logic in order to get the answer. Now moving ahead with the next question. Answer this question. Answer this question. Now for this question, if it is asked in JEE examination, these questions are those which you need to skip, because it will take a lot of time to find the ultimate moment of resistance. Ultimate moment of resistance in LSM. You can see Fe 250 bars are there, okay, as well as width is there, depth is there, M20 grade of concrete, 4 bars of 25 mm. So here you will get the ultimate moment of resistance. You need to find the ultimate moment of resistance. For this, depth of neutral axis you need to find out, then you need to find out the moment of resistance. So this is a time consuming question. Whenever these type of questions comes in the examination, you know the solution, but it will take a lot of time for the calculation. Hence it is advisable to skip those questions and attempt in the last whenever you have the time. Clear? So ultimate moment of rest, first you will find out whether this section is under reinforced or over reinforced. First find out whether this section is under reinforced or over reinforced. You can see, you can compare the compression force to the tension force. 0.36 FCK B into XU is equals to 0.87. Okay, 0.87 FI into AST. 0.36 FCK B into XU is equals to 0.87 Fi into AST. So from limit state method you will compare this. So XU will get the values as 0.87. What is the value of Fi? Fi value is nothing but 250. Okay. What is the AST? How many bars are there? 425 mm. So 4 into pi by 4 into 25 square. Okay. Upon 0.36. What is FCK? FCK is nothing but it is given as M20. Okay, what is the width of the beam? Width is nothing but 300. So here you will get the value as XU. You will get the value as XU. What will be the value of XU? XU here will be 197.71. So you will get the values as 197.71 mm, and then you will compare with limiting value of neutral axis. The limiting value for Fe250 is 0.53D. 0.53D. So 0.53. What is the effective depth? Effective depth is 550. So here you will get the values as 291.5. 291.5. So neutral axis is above the 291.5 mm. So neutral axis is above the neutral axis. Yes or no? So the section is under reinforced. Section is under reinforced. Yes or no? Clear everyone? Yes or no? So it is an under reinforced section. Please answer me. You will calculate the moment of resistance from the tension side or from compression side. If it is a under reinforced section, you will calculate the moment of resistance by taking this neutral axis depth from tension side or from compression side. Very good. From tension side. Now the next question is you need to find the moment of resistance. 0.87 Fi into AST, that is the tension force, and how about the lever arm? D minus 0.42 XU. D minus 0.42 XU. You will get the answer. Clear? You will solve the question, you will get the answer as 200. 0.87 Fi into AST into D minus 0.42 XU. D is nothing but 550 minus 0.42 XU. XU is nothing but 197.71. Clear? In order to convert this in, this will be in Newton, this will be Newton mm. So in order to convert this 10 power minus 6, you will get the answer in kilonewton. You can solve this. Okay, you can solve the question. Moving ahead. Answer the question. In which condition a doubly reinforced beam is used? Answer the question. In which condition doubly reinforced section is used? Doubly reinforced beam is used. So it is a Answer this question. In which condition? Now doubly reinforced section is used when now what is the correct answer? Whenever you have constraint by not changing the width and depth of the beam, and there is a moment which is acting on the beam is more than moment of resistance. So what you will do, instead of increasing the size, you will increase the area of reinforcement by giving the doubly reinforced beam. Understood? In which condition doubly reinforced beam is used? So what will be the correct answer? When depth and width of beam have to be restricted in size. Okay, understood everyone? Clear everyone? Next question. Answer this question. Please put a star mark on this. One of the criteria of the effective width of the flange of T beam is width of the flange is equals to I naught by 6 plus BW plus 6 time of DF. Here what is I naught? This is a very good question. Although you used to remember these formulas, the effective width of flange, one of the critical section for effective width of the flange of T beam. Now you can see in T beam what happens is the fibers in the center have more stress as compared to the outer fibers. So what we do is we take the effective width, effective width of flange. Okay, effective width of flange. We take the effective width such that all the fiber have equal stress in these. So okay, so by taking the effective stress of the effective width of the flange, our calculation becomes simple. Clear? So what is this? So here you must have studied L by 6 plus BW plus 6 time of DF. So what is this value? Yes, very good. This is the distance between point of zero moment. Understood? Effective span of T beam is not the correct answer. Distance between points of zero moment in the beam. Yes, this is the correct answer. Distance between points of zero moment. Understood? Clear span of the beam is not the correct answer. Distance between point of maximum moment is not the correct answer. Option B is the correct answer. Distance between points of zero moment in the beam. Clear everyone? L naught by 6 plus BW plus 6 time of DF. Okay. Can you answer me? This is for T beam. Can you answer me for L beam? Okay. L naught by 6. So width of the flange, effective width of the flange is nothing but L naught by 6 plus BW plus width of the web plus 6 time of depth of the flange. This is the depth of the flange, and here this is the width of the web. This is the width of the web. Understood everyone? For L beam, yes, very good. L beam, the value is nothing but L naught by 12 plus BW plus 3 time of DF. Okay, for L beam, the effective width of flange is nothing but, this is nothing but L naught by 12 plus BW plus 3 time of DF. This you need to remember. Okay. Yes, this is the answer. Moving ahead, solve this question. What is the correct answer? Two planks each of 50 and 50 mm section are glued together along the length of the section. Okay, along the length to form a section 50 into 100 mm. So there are two sections. Okay, there are two sections 50 by 50, so that the cross section will become 50 into 100. Okay, this is 50. One of the section is glued. This section 50 and this section is also 50. They are glued to form 50 by 100 mm and used as a beam. If the shear force at a section is 1000 Newton, what is the maximum shear stress at the glue? Maximum. First you find out the average shear stress, then you find out the maximum shear stress is for rectangular section. Maximum 3 by 2 times of the average shear stress. So what is the value of average shear stress? 3 by 2 times of V upon V is nothing but 100 Newton. So V acting here is 100 Newton. No, sorry, 1000 Newton. 1000 Newton. So what is the area? Area here is 50 into 100. So this was the concept. This was the concept. So what will be the correct answer? 3 by 2 times of the 1000 divided by 50 into 100. You will get the value as . So 2 times of 50. 2 times of 50 is 100. 100 into 100. 100 into 100 is 0.3. You will get the answer as 0.3 Newton. 0.3 Newton per mm square. Megapascal. Option B is the correct answer. Yes or no? Option B is the correct answer. Moving ahead. Now, if it is a circular section, can you give me the answer? For circular section, in order to get the ratio of maximum to the average stress. Here, maximum to the average ratio is 3 by 2. For circular section, please answer me. For rectangular section, the ratio of maximum shear stress to the average shear stress is nothing but 3 by 2. Okay, what is the value for circular section? The ratio of maximum shear stress, it will be 4 by 3. Very, very good, everyone. Very, very good. 4 by 3. Understood, everyone? 4 by 3. This you need to remember. Okay. Now, the next question. Answer this. The next question. If D and N are the effective depth and the depth of neutral axis respectively of singly reinforced beam, the lever arm. Very simple question. Lever arm is what is the correct answer? What is the value of lever arm? Simple question. Effective depth is D and the depth of neutral axis is N. Okay. Yes, very, very good. There is the standard value D minus X by 3 or N by 3. Option D is the correct answer. Next question. A T beam behave like a rectangular beam of width equal to its flange if neutral axis. This is also a good question. Now you can see I'll make this question little tough. A T beam behave like a rectangular beam. Now you can see this T beam behave like a rectangular beam. Okay, whenever the depth of the neutral axis, when neutral axis lies in the flange portion. Understood, everyone? Now whenever the neutral axis lies in the flange portion and there is a sagging bending moment, please remember this. If there is a sagging bending moment, this area will be in compression and the area below the neutral axis, you will neglect it. You will neglect it. So there is a this behave as effectively as rectangular beam. Yes or no? And width of the flange is, this width is equal to width of the flange. Yes or no? Understood? Now answer me if there is a hogging bending moment. Now answer me if there is a hogging bending. Same scenario, the neutral axis lies in the flange portion. Now answer me the width. So here this will behave as a rectangular beam. Now answer me if there is a sagging bending moment. So this beam will behave as a rectangular beam. This beam will behave as a rectangular beam of width of the flange. Yes or no? But if there is a hogging bending moment, and depth of neutral axis is more than depth of flange, Now you can see if this neutral axis is below this and there is a hogging bending moment, so what will happen? At bottom there is compression and above it there is a tension. So that beam will behave as a rectangular beam of width of the web. Okay, this is also one of the concepts which can be asked in the examination. Very beautiful concept. Clear everyone? TBA when remains within the flange. The correct answer is option B. Understood everyone? Moving ahead. Answer this question. Shrinkage deflection in case of rectangular beam and slab can be eliminated by putting shrinkage deflection. This is also a good question. Please put a star mark on this. Now you can see shrinkage deflection in case of rectangular beam and slab can be eliminated by compression steel equal to tension steel, compression steel more than tension steel, compression steel less than tension steel, compression steel 25% more than tension steel. Now you can see very clearly in if the reference is shrinkage deflection. Now shrinkage is from all the sides of the from all the surface area of the beam. Yes or no? Now if let us suppose in order to resist the shrinkage there is steel bars, so you will provide the equal area of steel on both the sides. Hence in order to prevent the shrinkage deflection, if you provide the compression and tension steel equal, they will resist the shrinkage. So hence option A is the correct answer. Understood everyone? Option A here is the correct answer. Moving ahead with the next question. Answer this. A rectangular beam with width B is equals to 200 mm and effective depth D is equals to 300 mm is subjected to limit state shear of 80 kilonewton. Please answer this. This is a very good question. Equivalent value of shear. I have just given you the formula. Equivalent value of shear is nothing but VU plus 1.6 T by B. Yes or no? 1.6 T by B. Without calculator, can you be able to solve the question? shear value is 80 kilonewton. So shear value is 80 kilonewton plus 1.6 time of the torsion moment is 6 kilonewton meter upon what is the width? Width is nothing but 200 mm. 200 mm. So solve the question. Now here you need to convert this 200 mm into meter. Then only you will be able to get the answer in kilonewton. So 200 mm into 10 power minus 3 is in meter. Okay. What is the correct answer? Yes, without calculator you need to solve the question. Answer will be yes, 128. 128 kilonewton. So just remember this. Here the B value should be in meter. Then only you will get the answer in kilonewton. Understood? Moving ahead, answer this question. This is one of the best question or one of the important questions for your examination. Horizontal spacing we have seen. Here in the question you are asked with the minimum vertical spacing of the main reinforcement. So if let us suppose this is the beam and this is one of the reinforcements. Here also you have provided reinforcement. So what is the spacing between this? This is spacing, this maximum spacing. So here you are asking about the vertical spacing. Understood everyone? The minimum vertical spacing of the main reinforcement RC beam is the diameter of the largest bar or 5 mm more than the nominal size of aggregate of the coarse aggregate. Okay, this is the spacing for horizontal. Okay, the diameter of the larger bar or 2/3 of the nominal maximum size of the coarse aggregate, 5 mm more than the diameter of the bar, 15 mm. What will be the correct answer? What will be the correct answer then? Yes, very good. This you need to remember. Okay, larger bar 15 mm as well as okay, this value is larger bar, thicker bar, diameter of thicker bar. Okay, or 15 mm, that should not be more than 15 mm. Understood everyone? As well as the third value is 2/3 the nominal size of the coarse aggregate, 2/3 of the nominal size of coarse aggregate. Nominal size of coarse aggregate. So among these three values, maximum value you have to take. Understood everyone? Yes or no? So the correct answer is option B. Answer this. Answer this question. The maximum diameter of the reinforcement bar in RCC beam is limited to maximum diameter. What is the maximum diameter of the reinforcement bar in RCC beam? So these are very important question. What is the maximum diameter of bar you can use in beam, column, slab? Answer this. Here you are asked with the maximum diameter of the bar. Answer this. The maximum diameter of the reinforcement bar in RCC beam is limited to 28 mm, 40 mm, 1/10 of the depth of the beam, 1/8 of the least dimension of the beam. Very good. The correct answer is 1/8 of the least dimension of the beam. Least dimension of the beam. So what is the minimum of B or D? 1/8 of it. 1/8 of it. Hence option C is the correct answer. Option C is the correct answer. Understood everyone? Please remember this. You'll get the question. Now moving ahead. Next question. This question we have already covered. Answer the question. Answer the question everyone. The limiting value of moment of resistance for a rectangular beam. So what is the maximum moment that a beam can resist? Limiting value, limiting moment of resistance for a rectangular beam of reinforcement Fe415. So for here you can see for Fe250 we have seen the value, for Fe415 and for Fe500. What is the value for? So here you are asked with Fe415. So it is 0.138 FCK BD square. How about Fe500? What will be the correct answer? For Fe500 it is 0.133 and 0.148 FCK BD square. And here 0.133 FCK BD square. Understood? So you'll get the answer as for Fe415 0.138. 0.138 is option D. Understood? Yes. Now moving ahead with the next question. Answer this. Answer this question. In a doubly reinforced rectangular beam, okay, in a doubly reinforced rectangular beam, the allowable stress in compression steel is allowable stress in compression steel. Okay, so this is the question of working stress method. Answer this. In a doubly reinforced rectangular beam, the allowable stress in compression steel. What are the values for compression steel? You take any of the value, Fe250, Fe415, you take any of the value, then answer me what is the permissible stress in compression steel and in tensile steel. Compare it with steel and now if you see Fe415, let us suppose I have take the value of Fe415. What is permissible stress in steel in tension? Okay, what is permissible stress steel in tension? The permissible, so here the values are 230 and 190. 230 and 190. Yes or no? Here the value is 230 Newton per mm square and 190 Newton per mm square. 230 Newton per mm square, as well as here it is 190 Newton per mm square. You can take any of the value. If you want to take any of the values, Fe500, Fe250 as well as Fe345. For Fe345 also it will be Fe345. What is sigma st and sigma sc? Here also sigma sc is less. Here also sigma sc is less. So permissible in steel is 190, 130. 190 Newton per mm square. Here 130 Newton per mm square. Yes or no? So always equal to the permissible stress in steel tension or less than or more than. So answer me now. Now what will be the answer? Less than the permissible stress in tension in steel. Option C is the correct answer. Here option C is the correct answer. Understood everyone? Now solve this question. Just a moment, I'll be back in just 1 minute. What is the correct answer? For cantilever of effective depth of cantilever depth is 0.5 meter. The maximum span to satisfy vertical deflection limit is. So span by depth ratio is. This is a very simple question. What is span by depth ratio? The answer is 3.5. Yes. For cantilever, the ratio of span by depth ratio is nothing but 7. Okay, span is given, depth is 0.5. So what is the span? Span you need to take is 7 times of 0.5, that is 3.5 meter. 3.5 meter. Option A is the correct answer. Moving ahead. Answer this question. The behavior of an over reinforced beam is more ductile than that of under reinforced beam because over reinforced beam contain. Very simple question. The behavior of over reinforced beam is more ductile than that of under reinforced beam because over reinforced beam contain more steel and steel is more ductile than concrete. Concrete brittle. Both concrete and steel stretch simultaneously. Statement is wrong. Now this is a very good question. Very good. Real site experience, you have given the correct answer. Now the behavior of over reinforced beam is more ductile. Now you can see whenever there is a over reinforced beam, what is the type of failure? There is a brittle failure, or whenever in over reinforced beam, you can see very carefully. In over reinforced beam, what is the type of behavior? It is ductile failure or brittle failure? It is ductile failure or brittle failure? The behavior of over reinforced beam is more ductile than under reinforced beam. Is the statement correct or wrong? As compared to under reinforced beam, in under reinforced beam, the failure is due to the steel, and that failure is ductile failure. But here the behavior of over reinforced beam, now in over reinforced beam the failure is brittle, so it is not, the failure is brittle. Understood everyone? So is the statement correct? Is the behavior of over reinforced beam is more ductile? Is the statement correct? No, it is wrong. Hence the statement is wrong. Understood everyone? Yes or no? Now next question. This we have seen already. Answer it. As per IS 456-2000, for the design of reinforced concrete beam, the maximum allowable shear stress depends on maximum allowable shear stress, tau c maximum. What is the value of tau c maximum for LSM? For LSM, M20, M20, M25, M20, M25, M30, M35 and M40 and above. Okay, M35 2.8, 3.1, okay, 3.5, 3.7, and here M40 and above, this value is 4. So this depends only on grade of concrete. Grade of concrete is option D is the correct answer. Yes or no? Option D is the correct answer. Are you getting my point everyone? Moving ahead, solve this question. IS 456-2000 recommends to provide certain minimum steel in RCC beam. Yes. Why minimum steel reinforcement is provided? Why there is a need to provide minimum steel reinforcement? Answer this. to avoid rupture of steel in case of flexural failure, to ensure compression failure, to hold this stirrup in position, to provide enough ductility to the beam. Answer this question. Now, although the correct explanation is not given in the question, now please remember, although the correct explanation is not given in the question, why one of the reason is because of the shrinkage. Because of the shrinkage, the stresses are developed. Because of the shrinkage, there are some stresses developed. So to prevent those stresses, to resist those stresses, minimum reinforcements are provided. Minimum reinforcements are provided. Understood, everyone? But the statement is not given in the question. But yes, among all the statements, we'll try to figure out what is the correct explanation. IS 456-2000 recommend to provide certain minimum steel in the RCC beam. Now, why minimum reinforcement? Let us suppose minimum tension reinforcement is given. Only the tension reinforcement. So one of the statement is wrong. To hold this stirrup in position. This is wrong. This is wrong. Understood, everyone? Why this minimum is given in order to hold the stirrup is wrong. To ensure compression failure. To ensure compression failure. Why it is given to ensure failure? No, it is also not wrong. It is also not correct. Now the option lies in option either A or D. Now you can see, to avoid rupture of steel in case of flexure failure occur, to provide enough ductility to the beam. Now both the statement seems to be right. To provide enough ductility to the beam, or to avoid rupture of steel in case of flexure failure occur. To avoid rupture of steel in case of, whenever there is a flexure failure, there are minimum reinforcement which will avoid rupture of the steel. Please put a star mark because there is a confusion. Both the statement are correct. Option A and D both are correct. Both are correct. Clear? Now moving ahead. Answer this. No, this is by far the best question of today's session. By far, this is the best question for today's session. Okay. Unfactored maximum bending moment at a section of a reinforced concrete beam are 50, 80, 120, 180 kilonewton under dead load, wind load and earthquake load respectively. The design moment as per IS 456-2000 for limit state of collapse. Okay, is. Now, there are unfactored maximum bending moment at a section because of the 50 is dead load. Because of the dead load, what is the unfactored bending moment? That is 50 kilonewton meter. And due to live load, it is 80. And due to wind load, it is 120. And for earthquake load, it is 180 kilonewton meter. Kilonewton meter. Now answer the load combination. First load combination, if there is dead load and live load, how much you need to increase? 1.5, 1.5. Dead load or wind load or earthquake load, 1.5 or 1.5. Understood, everyone? When all the loads are acting, you multiply it by 1.2. So in RCC, there is very less load combination. So first load combination is dead load and live load. So you multiply dead load by 1.5 and you multiply live load by 1.5. Second load combination is if there is dead load and wind load or earthquake load. So you multiply dead load by 1.5 or 1.5 by dead load, sorry, wind load or earthquake load. Wind load or earthquake load. When all the three load are acting, 1.2 times of dead load plus 1.2 times of live load plus 1.2 times of the wind load or earthquake load. So maximum among the all will be taken care of. So you can see among the wind load or earthquake load is more. Okay, so here we will take earthquake load. Here also we will take earthquake load. Yes or no? So try to figure it out. The first value. The first value is nothing but 1.5 times of 50. 1.5 times of 50 plus 1.5 times of 80. So in the next value is 1.5 times of dead load is 50 plus 1.5 times of the earthquake load is nothing but 180. Although this value seems to be higher than the first value. Now the third value is 1.2 times of the dead load 50 plus 1.2 times of the live load is nothing but 80 as well as 1.2 times of the 180. Most probably we'll get the answer from third. Most probably we'll get the value from third. You can see what is the value. Most probably we'll get the value from, so 1.2 is common, 1.2 is common. You can solve this by 1.2 as common, 50 plus 80 plus 180, 50 plus 80 plus 180. So most probably you'll get the answer from here. So 180 plus 80 is 260, 310. So 20% of 310, 20% of 310. Yes, no need to solve the question, no need to solve because it is 20% more than 310. So you'll get the answer as option B. No need to solve the, no need to solve. Why? Because this value will be certainly more than 350. Only one option is there which is more than 310. Option B is the correct answer. Getting my point, everyone? Yes, 372 is the correct answer. Understood, everyone? I hope you have understood this question. Yes or no? Clear? Now moving towards the next question. Solve this question. Solve this question. This is also a very good question. Calculate the maximum factored bending moment of rectangular factored bending moment of rectangular beam of effective span. So effective span is given as 6 meter. The superimposed load. So superimposed load is 84 kilonewton per meter. 84 kilonewton per meter. The dimension of the beam are limited to 35.5 centimeter and 75 centimeter overall. Okay, M20 Fe415 grade density of concrete is 25 kilonewton per meter cube. Maximum factored bending moment. So you can see if it is a simply supported, superimposed load is this. Superimposed load is this. So factored bending moment is WL square by 8. Factored bending moment is for simply supported beam. We consider this as simply supported beam. Okay. So this is the factored bending moment. WL square by 8. So here your task is to calculate the load. Yes or no? So your task is to calculate load W. So superimposed is 84. Superimposed is 84. Okay. As well as what is the self weight? What is the self weight? Please don't neglect this self weight of the beam. Self weight of the beam is nothing but the density of the density is 25. Okay, density is 25. Okay, here the density is 25. So what about the volume? What about the volume? For 1 meter, it is 25 kilonewton per meter cube. So for 1 meter, the length is 1 meter as well as the width and depth is nothing but, for convert this in meter, 0.35 into 0.75. 0.35 into 0.75. Yes or no? So this is nothing but kilonewton per meter. Okay, this is nothing but kilonewton per meter. Yes or no? So this is 6.6. this value comes out to be 6.6 kilonewton per meter, as well as superimposed load. So total load is this intensity is 6.6 kilonewton per meter. Yes or no? 6.6 kilonewton per meter. What is the superimposed load? That is 84 kilonewton per meter. So this is nothing but 90.6 kilonewton per meter. This is the load intensity. So the factored load is for factored load, you multiply it by 1.5 times of 90.6. So increased 50%, 45.3. So 135.9. So 135.9. So this is the factored load. If this is the factored load, this is 135.9. What is the length? Length is nothing but, this is given in the equation as 6 meter. 6 meter square divided by 8. You will get the answer. Kilonewton meter. You will get the answer in kilonewton meter. So you will get the value as 612. Option is 612 kilonewton per meter. Option A is the correct. This question also takes a lot of time. Hence, it is advisable to leave such question for the last. Okay. Yes, the value is 612. This is also a very good question. I mean, this question seems to be for GATE examination, not for your JEE examination. But yes, how to calculate the factored load? This is what explained in this question. Shall we move ahead? Moving ahead. Answer this question. The length of the straight portion of the bar beyond the end of the hook should be at least. This is an important question. Please put a star mark on this. Answer this question. Beyond the straight portion. Now, if let us suppose this is the length of the bar. Now, beyond this, how much is the straight portion? What is the portion of this? This is nothing but 4 times of diameter of the bar. Yes or no? 4 times of diameter of the bar. Yes or no? 4 times the diameter of the bar. So the length of the straight portion of the bar beyond the end of the hook should be at least 4 times of the diameter of the bar. Yes or no? Now moving ahead. Answer this question. Last three question, guys. Last three question. What is the adoptable maximum spacing between vertical stirrup in RCC beam of rectangular cross section having an effective depth of 300 mm? So what is the distance? What is the maximum spacing? The maximum spacing in vertical reinforcement is nothing but, what will be the value? 0.75 D. Very, very good. So maximum spacing of stirrup, maximum spacing between the vertical stirrup. So this is nothing but 0.75 into D. So effective depth is value is 300. So 0.75 means 0.75% of 300 is nothing but, yes, 3 by 4. So this value will comes out to be, what is the value? 225 will be the correct answer. Yes or no? 225 will be the correct answer. So the maximum spacing should be 225 mm. Okay. Option D is the correct answer. Okay. Next. Answer this question. So last two question. Now answer me. Torsional resisting capacity of given reinforced concrete section. Okay. So whenever you increase the torsional resisting capacity, okay, for a given section, by increasing the torsional capacity for given section, you can see very carefully, decreases with the decrease in stirrup spacing. So whenever you decrease the stirrup spacing, when the spacing of the stirrups are decreased, so the torsional capacity decreases? No, it will increase because more stirrups will be there. So option A is not the correct answer. Decrease with increase in longitudinal bar. So whenever you increase the longitudinal bar, will it increase? No. Will it decrease? No. Option B is also not the correct option. Does not depends upon stirrup. It depends upon the stirrup and longitudinal steel. Hence increases with the increase in the stirrup and longitudinal steel. So whenever you increase the longitudinal stirrup as well as you increase the shear stirrup, it will increase. Option D. So only by the logic you will get the answer here. Understood everyone? Now moving ahead. The last question for today's class. 35th question. Answer it. Critical section for shear in case of RCC beam in frame building is taken at a distance. Critical section for shear. Now, what is the, as per IS code, what is the critical section for shear? If let us suppose this is the critical section for shear. If let us suppose this is the support. This is the support. Now the crack will develop from the face of the support to the D. So the what will be the correct answer? This is given in the IS code. So what is the critical section? So where there is a maximum shear, okay. So IS code assumes that here in this depth there is a equal shear, okay. There is a equal shear. So the critical section is nothing but the critical section. The critical section for shear in case of RCC beam in frame building is taken at a distance D from the edge of the support, at the face of the support. No, D by 2 from the face of the support is not the correct answer. 0.75 D from face of support, where D is effective depth. No, option A is the correct answer. D from the edge of the support. Understood everyone? Clear? So I hope you have understood the concepts of the singly and doubly reinforced beam. Although we have covered the concepts thoroughly. Understood everyone? So here the question answer is, so this is for the critical section for shear in the beam, frame building, RCC beam. It is not foundation, it is beam. That is why we have taken D from the face of the edge, from the edge of the support. Yes or no? Clear? For the beam, it is not for footing. Understood? Sachin, we are asking for RCC beam. Okay. So this is it guys. This is it for today's session. I hope you have enjoyed the session. Have you enjoyed the session? So this is how we have covered the beam part. Okay. We have completed the beam part. Now we are left with 3 chapters, that is slab, column and footing. Slab, column and footing. And most probably for your JEE examination, pre-stress concrete is not important. Okay. Pre-stress concrete is not important for your JEE examination. I am expecting questions from beam and slab. Okay. So we'll be starting with the questions on. This is the Telegram channel. In today's class, I'll be covering the question on good questions on slab, RCC slab. Okay. So today in today's class, I'll be covering the question on RCC slab. Is it clear everyone? Clear? Okay. So this is the PPT. Okay. So few days are left for your RRB JEE. Okay, these questions are helpful for your all the state AE and JEE examination. I have framed the question in such a way that these questions are important for RCC questions are, and complete RCC will be covered from these questions, important for your state JEE exam and AE examination. State AE and JEE examination. Okay, you cover these questions roughly around. I'll take 300 questions. In evening also I'll take one of the session. Okay, in evening I'll be taking the session on column. Clear? Because yesterday I haven't taken the class, so in order to manage that class, I'll take the class in the evening also. So in the evening I'll be taking the class on RCC column. Clear everyone? In evening I'll be taking the class on RCC column. This is how we will proceed. Is audio video clear everyone? And this is the Telegram channel from the annotated PPT. This is the Telegram channel. Okay. You can scan this Telegram channel and you'll reach to my Telegram channel. You will download the annotated PPT of this PDF of this file, okay, so that you can revise anytime. Clear? Let's just start with the session. Start करें भाई. Please comment. Let us start the session. Okay. Okay. Let's just start with the session. So in today's class, the first question for RCC slab. Okay. RCC slab. Look. This is the first question. And this is a very good question. The overall depth for two-way support. Put a star mark on this. Put a star mark on this. Solve the question. This is the first question. Solve the question, everyone. What is the correct answer? Now, the overall depth for a two-way simply supported slab is 300 mm. Okay, the depth is given in the question. So the depth is given in the question as 300 mm. So this depth is given. Understood, everyone? Find the span length. You are asked with the span length. So for two-way slab, the ratio for two-way slab, for the ratio of span by depth ratio is, answer everyone. I'm not getting answers. Okay, the depth is 300 mm. For two-way slab, okay, span by depth ratio, span upon depth ratio for simply supported and for continuous slab. Okay, for simply supported and for continuous slab, the value is given as, for simply supported slab it is 35 and for continuous slab it is 40. For simply supported slab, this value is 35. Okay, and for continuous slab this value is 40. This value is 40. Understood, everyone? In question it is given as two-way simply supported slab, and you can see that the depth is given as 300. So you are asked with the span. So you know these values are only for mild steel, and if you are using HYSD steel, for HYSD steel, these values are multiplied, above values are multiplied by 0.8. Understood, everyone? These values are multiplied by 0.8. So you can see you can span upon depth is given as 300 mm and the ratio is given as 35. So you can see the span length will be equal to, the span is in mm. So 35 into 300. 35 into 300. So your answer will be multiply it. You will get the answer as 10500 mm. 10500 mm is the answer. Yes or no? Option D is the correct answer. Yes, 10500 mm. 10500 mm. Yes or no? Clear, everyone? Okay, moving ahead with the next question. Is understood, everyone? Just a moment. I remind student on Telegram that the session has been started. Moving ahead with the next question. This is the second question for today's class. Answer this question. In case of two-way slab, the limiting deflection of the slab is, now this is a very good question. Now whenever you check for deflection, okay, which span will you take? In case of two-way slab, the limiting deflection of the slab is primarily a function of long span, primarily a function of short span, independent of long and short span, dependent on both long and short span. This is a very good question. Answer this question. Vaibhav, Vishnu, the correct answer is no. No, the correct answer is no. Vishnu Pandey, the correct answer is not D. The correct answer is option B. B for Bombay. Whenever you check for the limit deflection, okay, whenever you are checking for the deflection in two-way slab, always shorter span is used. Understood, everyone? Always shorter span is used. So limiting deflection of the slab is the function of shorter span. Option B is the correct answer. Understood? Please please put a star mark on this. Whenever in two-way slab you are checking for deflection criteria, always you will use the shorter span. Understood, everyone? Option B is the correct answer. Now moving ahead, answer this question. For design purposes, the width of one-way slab is always taken as, again a very good question. Now for always the design criteria, let us suppose I have marked the this is a slab. For design purpose, you always take for design, let us suppose this is the slab. For design, you will always take it the width as, you always consider this portion of the slab, and this portion of the slab, the width of this is nothing but now this width is 1 mm, 100 mm, 200 mm. This width is 1 meter. Yes, very good. 1 meter means 1000 mm. Option C is the correct answer. Understood, everyone? Always we take the width as the 1000 mm. Option C is the correct answer. Moving ahead with the next question. So in this chapter, I'll take 40 questions. Okay, I'll take 40 questions, and in the evening for column chapter we will take roughly around 40 questions of column also. Answer this question, everyone. What is the correct answer? Minimum reinforcement required in either direction in slab reinforced with high strength deformed bar. Now this is nothing but percentage of the gross cross section area, 0.11. Very good. The correct answer is whenever you are using high strength deformed bars, for high strength deformed bars, the minimum reinforcement in slab, okay, minimum reinforcement in slab is considered to be 0.12% of the gross cross section area. Yes or no? Now I'll finish. For 2 days I have to go somewhere at one of my relative place. That is why there was a break. Otherwise I won't discontinue it. Okay, I will discontinue only when we will be able to solve all the questions of this series. Understood? In evening I will take column as well as footing. So two chapters are also left again, the column as well as footing. This we will cover. Understood everyone? Also in this playlist you will see that I have taken question for SSC previous year also, but that is in Hindi. Okay, that is in Hindi. I have taken almost 20 years question of SSC previous year, so you can refer the playlist. Okay, so you can see very carefully, high stand deformed bars, minimum reinforcement is 0.12% of the gross cross section area, and whenever you are using the mild steel, how much is the minimum reinforcement will provide? 0.15% of the gross cross section area. Clear everyone? Now moving ahead with the next question. This is the question, answer it. This is a very good question. Please put a star mark on this. Most of the students will give the wrong answer for this. Please put a star mark. हाँ करवा देंगे भाई, बिल्कुल करवा देंगे, पहले ये फिनिश हो जाए फिर करवा देंगे, ठीक है। आरसीसी स्लैब, what is the correct answer? Very good, Vishnu Vaibhav, very good. Vaibhav have given the correct answer. I want answer from other student also. Now look, RCC slab under mild exposure condition having main longitudinal tension reinforced. Now let us suppose the main bar has a diameter of 12 mm. The main bar has diameter of 12 mm. Okay, the RCC slab under mild exposure condition having main longitudinal reinforcement of diameter 12 mm, then minimum allowable nominal cover to satisfy the durability requirement. In order for the durability requirement for this 12 mm bar, the minimum cover is reduced by, in the slab minimum cover is reduced by 5 mm, reduced by 5 mm. Okay, 5 mm. So we know that what is the nominal cover, minimum nominal cover for slab, nominal cover for slab is nothing but 20 mm, is 20 mm. So for this durability criteria you have a chance of reducing it by 5 mm. So what is the minimum nominal cover? 20 minus 5, that is equals to 15 mm. So your correct answer is option B is the correct answer. 15 mm is the correct answer. Understood everyone? Now moving ahead with the next question. Answer it everyone. Answer this question. In case of non-cellular, non-ribbed flat slab, what is the correct answer? This is a very good question. In case of non-cellular means non-ribbed. I'll show you the diagram. Ribbed and non-ribbed flat slab. This is a non-ribbed flat slab. The spacing of the steel reinforcing bar shall not exceed a meter in m times the thickness of the slab, where m is. Now you can see, if I show you, just a moment. Now you can imagine this, that the slab, this is a flat slab, this is not ribbed. Understood? So over the slab, their slab was placed over the column. So this is known as non-ribbed flat slab. Okay, or in case of non-cellular, non-ribbed flat slab, the spacing of the steel reinforcement bars shall not exceed 2 times the thickness of the slab. So remember this codal provision, the reinforcement bar should not, the spacing should not exceed 2 times the thickness of the bar. So here I'll show you the thickness. This is the thickness of the, slab. Understood everyone? So thickness of the slab, I have shown you here. So maximum spacing is the 2 times the thickness of the slab. Please put a star mark on this. Please put a star mark. Okay. Moving ahead. Answer this question. Answer this question. The maximum theoretical diameter in mm of steel reinforcement slab 180 mm thick is the maximum theoretical diameter. This put a star mark on this. If let us suppose the thickness of the bar is the thickness of the slab is 180 mm. So what is the maximum theoretical diameter? Theoretical wise, what is the maximum diameter of steel bar you will use here? What is the correct answer? Theoretically, what is the maximum size of steel bar that you will use here? What is the correct answer? Yes, very very good, Vishnu. So what is the maximum dia of bar? Maximum diameter of bar. So what is the maximum diameter of bar? 1 by 8 times of the thickness of the slab. 1 by 8 times of the thickness of slab. Yes or no? Thickness of slab. Now look very carefully. 1 by 8 times of the thickness of the slab is nothing but 180 mm. So what is the correct answer? 180 means 90 by 4. 90 by 4 means 45 by 2. 45 by 2 means 22.5 mm. So the maximum diameter of bar that you'll use here is 22.5 mm. So theoretical wise, you'll use 22 mm diameter bar for this slab. Yes or no? The maximum diameter of bar is 22.5 mm. So this is again a very good question. Answer this question, everyone. Again, this is a very good question. One-way slab. What is the correct answer? In one-way slab are those in which most of the load is carried on which span? The correct answer is longest, shorter, middle or quarter. What is the correct answer? Now in one-way slab you can see they are supported on one side. Okay, so you can see the main bars are provided on the shorter span and distribution bars are provided on the longer span. Please remember this, that the maximum load is carried on which span? Shorter span. Understood everyone? On shorter span. Okay, so the main reinforcements are provided on shorter span. Okay, and distribution bar are provided on longer span, Understood everyone? So you can see main reinforcement are provided on shorter span. Option B is the correct answer. Clear everyone? Clear? We'll move ahead with the next question. The distance between main bar in a simply supported should not exceed. The distance between main bars in a simply supported slab should not exceed by 3 times of effective depth, 4 times, 5 times and 6 times. This is also a very good question. What is the correct answer for 9th? In this question there is some amendment. Now in this question there is a recent amendment, not recent, but there is an amendment on this. What is the correct answer? The distance between main bars in a simply supported slab should not exceed by. Now for main bars, you can see for main bars the maximum distance should not exceed 3 times of the effective depth. Okay, so maximum distance is, okay, maximum distance should not exceed by 3 times of the effective depth. Okay, or 300 mm or 300 mm, whichever is less, but whenever you are providing, yes, answer is option A, whenever you are providing the reinforcement for temperature and shrinkage, whenever the reinforcement is provided for temperature and shrinkage, whenever the reinforcement is provided for temperature and shrinkage, the maximum spacing is in, earlier it was 3 times of the effective depth or 450 mm, 5 times of effective depth, or 450 mm, but now it is changed to 300 mm, whichever is less. So this is the amendment. Understood everyone? Here it is for main bars, so answer is 3 times of the effective depth. Option A is the correct answer. Good afternoon, Vignesh. Understood? This is the correct answer. Option A is the correct answer. I hope it is clear. So this is the amendment. Clear everyone? So in slab, okay, whenever for main bars the maximum spacing is 3 times of the effective depth or 300 mm, whichever is less, but for temperature and shrinkage, if you have provided the reinforcement, it should not be more than 5 times of the effective depth or 450 mm. This was the previous code, but now this is the amendment. It is reduced to 300 mm. Yes or no? The correct answer is option A. Option A is the correct answer. I hope it is clear. Now, very good. Now solve this question. Thickened part of flat slab over the supporting column is called. Now this is the question for flat slab. Understood? Now you can see, if this is the slab, okay, this is the column. Now this is the column, this is flat slab, okay. Now this is drop panel, this is column capital. This portion, this tapered portion is known as column capital. This is known as column capital. And you are asked in the question that what is this flat part, thickened part of flat slab? This is known as this is not apital, this is column capital. This is column capital. Option B is column capital, and this is known as drop panel. This portion is known as drop panel. Understood? So this is the flat slab. Clear everyone? So you can see very carefully, thickened part of the flat slab or the supporting column. This is the thickened part of the, that is known as, yes, the correct answer is, now here this thickened part, you are asked with this part. You can see this part you have asked. This part is known as drop panel. Option A is the correct answer. Okay, understood everyone? This is known as column capital. This tapered portion is known as column capital, but this portion is known as drop panel. Understood, Vignesh? Option A is the correct answer. Now if there are one more type of flat slab, look at this part. This is flat slab with column capital. So this is the diagram. This is known as this is column, and this is known as column capital. This is flat slab with column capital and drop panel. This is flat slab with column capital. Understood? So the correct answer is option A. Drop panel is the correct answer. Clear everyone? Moving ahead with the next question. Answer this everyone. For slab spanning in two directions, the ratio of span to depth for simply supported slab should not exceed. For slab spanning in two directions, the ratio of span to depth for simply supported slab should, this question we have just covered. For two-way slab, okay, for two-way slab, okay, spanning in two direction, okay, it is spanning in two direction, the ratio of span by effective depth, the ratio of span by effective depth ratio for simply supported slab, okay, for simply supported slab it is 35 and for continuous slab it is 40. For simply supported slab it is 35 and for continuous slab it is 40. So here the correct answer is option C is the correct answer. Very good. Yes, for these are for mild steel, but if you are using the high strength HYSD bars, high steel deformed bar, above values are multiplied by 0.8. Above values are multiplied by 0.8. Yes or no? Moving ahead. Answer this question. Again a very good question. Answer everyone. In simply supported slab, okay, in simply supported slab, alternate bars are curtailed at very good. Alternate bars are curtailed at span by 7. This is the good, very good. Please put a star mark. So if there are some bars, one bar is this, one bar is this, so alternate bars, let's suppose this one and this one, so alternate bars are curtailed at span by 7. Option C is the correct answer. Please put a star mark on this. So span by 7, so alternate bars are curtailed at span by 7. Understood? Now moving ahead, this is the very good question. Answer this. The slab is designed as one way if the ratio of long span to short span is this is a very simple question. This slab is designed, so for one way slab, the ratio of long span to the short span, if the ratio, for example Ly by Lx, okay, if the ratio is nothing but greater than equal to 2, the slab is called as one way slab. If it is less than 2, it is known as two way slab. One way slab, just a moment guys. Okay guys, so what is the correct answer for this? What is the correct answer? If the slab is designated as designed as one way, the ratio of long span should be greater than or equal to 2. So correct answer is option B. Yes or no? So this is the correct answer. Moving ahead. Next question. In case of flat slab, the minimum thickness of slab shall be. Very good question. For flat slab, okay, what is the correct answer for flats in case of flat slab? For flat slab, the minimum thickness should be, the least thickness should be 125 mm. Okay, so the minimum thickness of flat slab should be 125 mm. Option C is the correct answer. Understood everyone? Option C is the correct answer. Minimum thickness of flat slab. So in case of flat slab, the minimum thickness of flat slab is minimum thickness of flat slab should not be less than 125 mm. So the correct answer is option C. Understood? Moving ahead. Answer this question everyone. Enlarged head of supporting column of an RC reinforced cement flat slab is called. This question just now I have discussed with you. Just now I have discussed. What will be the correct answer? Column head, drop panel, none of these. Capital. Now see, this is the flat slab. I'll show you 3 diagram. Okay, this is flat slab, this is flat slab. Understood? This is flat slab with column capital. This is flat slab with column capital. Look, this is flat slab with column capital. Understood everyone? And this is flat slab with drop panel. This is flat slab. This is flat slab with column capital and with drop panel. So these are the 3 type of flat slab. Understood everyone? Understood? This is flat slab. This you can see. This is known as flat slab. Yes or no? This is flat slab with column capital. Flat slab with column capital. This is flat slab with column capital and drop panel. Flat slab with column capital and drop panel. Yes or no? So the correct answer is column capital. Option A is the correct answer. Yes or no? Moving ahead. Answer this. This is also a very good question. Please don't use, please only use virtual calculator while solving any type of question. Solve virtual calculator everyone. You can see, for it is a one way simply supported slab. You can see dimension is 9 meter by 4 meter. So you can see Ly is nothing but 9 meter and Lx is nothing but 4 meter. So the ratio of the longer span to the shorter span, the ratio of longer span by shorter span is greater than 2. So it is a one way slab. It is a one way slab. Understood everyone? It is a one way slab. Ultimate. So working load is nothing but, working load in question is given as, working load is given in the question as 9 kilonewton per meter. The design moment is design moment. In design moment we always take which span? The shorter span. So WL square by 8, WL square by 8. So 9 into length is nothing but 4 meter, 4 square divided by 8. So your correct answer will be 16. So 18 kilonewton meter is the correct answer. 18 kilonewton meter is the correct answer. Option B is the correct. Understood? Yes or no? Okay, now moving ahead, answer this question. Answer 17th question. Drops are provided in flat slab. So why the drops are provided? Now the flat slab resist over the flat slab resist. So drop is, now this drop is provided to resist the shear. Please remember, this is column head. Okay, column head is provided because of the compression failure of the column. Okay, because from the slab, from larger area the load will transfer to the column. This is the column head, column capital. Okay, so this drop is provided to resist the shear, so this is the drop panel. Okay, so drop panel. So this drop panel is given in order to resist the shear. Option A is the correct answer. Clear everyone? Moving ahead, answer this question. In two-way slab, the main reinforcement is provided along. Again a very simple question. Answer this. No, this is a two-way slab. It is not one-way slab. Now you can see very carefully. This is nothing but a one-way slab. But if the bending is taken place in both the direction, if I support it like this and support it like this, so deflection is like this also and deflection is like this also. Understood? That is known as two-way slab. So in two-way slab, please note that in two-way slab the main reinforcements are provided in both the direction, in both short and long span, because the deflection carried out in both the direction. Yes or no? In both these. But if it is a case of one-way slab, the main reinforcement are provided in the main reinforcement is provided in which span? Main reinforcement is provided in shorter span. Yes or no? Understood everyone? Clear? So here the correct answer is option C. Now moving ahead. Now this is a very good question. Most probably you will get the question. This is in your RRB JEE examination. Very good question. Very important question. Answer this. The main reinforcement in a RC slab consists of 10 mm bar at a spacing of, so 10 mm reinforcement bars are provided at a spacing of 100 mm spacing. Understood everyone? 100 mm spacing. Now again it is given as center to center. If it is desired to replace the 10 mm bar by 12 mm, now you have replaced the 10 mm bar by 12 mm. So comment about the spacing. Spacing will be less than 100 or more than 100? Now if you have provided the longer span, now spacing will be more than 100. So the first thing comes in your mind is spacing is more than 100 mm. Yes or no? More than. So all the options are more than 100 mm. So option A will not be the correct answer. Either you will get B, C, D. Understood? One option you have eliminated. Now what is the formula? Spacing formula in slab? Spacing in slab is equal to nothing but pi by 4 into phi square 1000 upon AST. Now you can see very carefully, spacing is directly proportional to the diameter square if all the things are constant. If width of the slab is 1000 mm and the area of steel is same. Now for example, here the spacing for the 10 mm bar, 10 square is upon 12 square is equals to spacing is 100. Now here the spacing is x. So your answer will be nothing but 144. Okay, 144. X is nothing but 144 mm. So your answer will be option C is the correct answer. Clear everyone? So this is the formula. Please remember this formula for spacing in the slab. Clear? Clear everyone? Now moving ahead. Now please put a star mark on this. A steel beam supporting load from the floor slab as well as from the wall is termed as. Now from the floor slab you have provided the beam. The beam is known as lintel beam, is provided in the above the door or window, such that above the door or window whatsoever be the brick masonry, the load will comes to the lintel beam. Okay, the correct answer is spandrel, stringer or header beam. No, I'll show you the diagram also. First of all, I'll show you the stringer beam. You can see. Just a moment, I'll show you the stringer beam. Stringer beam. See. Stringer beam as well as so in the question 3 beams are given. I'll show you 2, stringer and spandrel beam. Stringer beam as well as spandrel. Just a moment. Is this image clear? Is this image clear, everyone? Now you can see the correct answer is spandrel beam. Very good everyone. So this is the for below. Now you can see stringer beam is below the this beam is stringer beam. You can see this beam is stringer beam. Okay, this is provided below the it is not visible. Just a moment. Now it is clear. Now it is clear. You can see very carefully this beam below the staircase. This beam is nothing but this beam is stringer beam. Yes or no? You can see. Yes or no? Now I'll show you the spandrel beam. This is spandrel beam. This beam. This beam is spandrel. This one is the spandrel beam. So it will carry the load from the floor also, from the wall also. Yes or no? Yes, bottom part of the stair is stringer beam. Understood? So you can refer here the question. Refer the question. A steel beam supporting the load from the floor slab as well as from the wall. So below the wall as well as from the floor slab, that is spandrel beam. Option C is the correct answer. Understood? Option C is the correct answer. Now moving ahead, answer this question. The main reinforcement, again this is a very good question. Very good question. I have already told you the formula for spacing of the beam. So what will be the correct answer? those students are from Maharashtra. Okay, Mahatransco vacancies, the link for Mahatransco vacancies are open now. Okay, that is a very good opportunity for to become the assistant engineer in your examination. Very good vacancies. Yes or no? Those students are from Maharashtra, they can apply for Maharashtra, okay, Mahatransco examination. The links are open now to fill the form. You know, there are very good opportunity for Maharashtra student, as the vacancies for New Mumbai Municipal Corporation, as well as for Mahatransco, as well as for MPSC. Okay. The main reinforced outside slab consists of 10 mm bar. So 10 mm bars are there, and what is the spacing? 100 mm spacing are there. 100 mm spacing. If they desire to replace 10 mm bar by 12 mm, so what will be the spacing? Spacing will be 144 mm, or 144 mm means 14.4 centimeter. 14.4 centimeter. That is option C is the correct answer. Just now I have for 144, 14.4 will be the answer. How it will be 14.4? Vignesh, I just told you the example that spacing is directly proportional to the diameter of the bar. Yes or no? Square of the diameter of the bar. So if the spacing is 100 mm, 100 divided by spacing is x is equals to 10 square upon 12 square. Yes or no? So you can see very carefully, 100 x is equal to, x value is equals to 100 into 144 divided by 100. So your answer will be 144 mm. So it will be 14.4 centimeter. Option C is the, that is why option B is given, in order to make you confused. Understood? Now moving ahead. So you must have seen that from this is the 6th lecture. I have framed such a question that you won't get these questions in your previous year. Understood everyone? So this is how we will try to solve one more subject after this. Option C is the correct answer. Now moving ahead. In an interior span of flat slab, the negative design moment is taken as times the total design moment. Again, this is a very good question. Now for interior span, now you can see for interior span, negative design moment is as well as positive design moment. So what is the value for, Sachin, 0.5 is not the correct answer, brother. So the correct answer is for negative bending moment, it is 0.65 times of the, so in interior, okay, in interior we will take the design moment as 0.65 times of the point for the total design moment. Total design moment, and for positive bending moment it is 0.35 times of the total design moment. Total design moment. So what is the correct answer? 0.65. Negative, no. So negative design moment is 0.65 times of the total design moment. Option C is the correct answer. Moving ahead. Now answer this question. Answer this question. In an under reinforced one-way slab with effective depth of 100 mm, the main answer this question. Please use virtual calculator in order to solve this question. Now you can see in an under reinforced one-way slab. So in question it is given as under reinforced one-way slab. Now this is the under rein. So in under reinforced one-way slab, with effective depth of 100 mm, the main steel is provided as 10 mm bars at 200 mm center to center. Okay. The moment of resistance of the slab for M20 grade of concrete Fe415 steel is. Now you are asked with moment of resistance. Effective width is taken to be 1000 mm, 1 meter or 1000 mm. So this is the, and depth is taken at 100 mm. Depth is taken as 100 mm. Yes or no? Okay, now the spacing is nothing but 200 mm. The bars are, so what is the formula of spacing? Spacing is nothing but 1000. What is the width? 1000 mm into pi by 4. What is the diameter? Diameter is 10 mm upon what is the AST, area of steel. So from here area of steel can be computed. So spacing AST will be equal to area of steel can be computed 1000 into pi by 4, 1000 into pi by 4 into 10 square divided by what is the spacing? 200. So from here AST is computed. Whenever you get the AST, okay, you have calculated the AST. Moment of resistance can be calculated as, now depth, in order to get the depth of neutral axis 0.36 FCK B into XU is equals to 0.87 FY into AST. Okay, so from here XU can be calculated. XU can be calculated as 0.87 FI. FI is nothing but 415. What is the AST? From here you will get the AST. Okay, from here you will get the AST as well as upon 0.36. What is the grade of the concrete? Grade of concrete is 20 and width is nothing but, effective width is nothing but 1000 mm. So from here you will get XU. From here you will get XU. Yes or no? AST is 392.7. So this is 392.7 mm square. 392.7 mm square. So from here you will get the XU value as 19.7 mm. 19.7 mm. So what is the moment of resistance? Moment of resistance can be calculated as 0.87 Fy into AST. AST D minus 0.42 XU. D minus 0.42 XU. All the values are given. 0.87 Fy value is 415. AST value is nothing but 392.7. 392.7. D is nothing but effective depth is given as 100. 100 minus 0.42 into XU value is 19.7. So in order to convert this in kilonewton meter, multiplied by 10 power minus 6. So it will take long time to cover this question. Your answer will be 13 kilonewton per meter. 13 Newton kilonewton meter. So in slab, it is the most common question. This is not the question for your RRBJ examination. Rather, you will get such type of question in your GATE examination. Just look at the answer. Understood? Yes or no? This is the answer. I hope it is clear. Yes or no, everyone? Now moving ahead. Solve this question. Answer this. In two-way slab, the torsional reinforcement is provided at. Now this is a good question. Please note down, whenever the slab is continuous, no need to provide the torsional reinforcement. For continuous slab, no need to provide the torsional reinforcement. Answer this. So whenever there is slab is two-way, okay, torsional reinforcement is provided mid depth only, top face only, bottom face only, and top and bottom. Very good, very good, Vignesh. So torsional reinforcements are provided at top face also, at the bottom face also. Understood? So the correct answer is option D. But please mind it, whenever the slab is continuous, no need to provide the, so this is the codal provision that whenever for continuous slab, so whenever for the edge is continuous, for continuous edge, okay, no need for torsional reinforcement. Understood? Moving ahead. Answer this. The answer for 25th question. Now in monolithic slab beam, so you can see this diagram. You can see this diagram. This is monolithic. Okay, this is monolithic. I mean, beam is casted with the slab. Yes or no? Beam is casted with the slab. So this is monolithic. So whenever you have cast the monolithic slab, okay, main reinforcements are parallel to the beam. Main reinforcements are parallel to the beam. And how about the transverse reinforcement? Transverse reinforcement are, you are asked with the transverse reinforcement. Now the correct answer is not B, option C is the correct answer. Now 60% of main reinforcement at midspan. So at the midspan, so this is the main reinforcement. At the midspan, you can see at the midspan, these are nothing but the transverse reinforcement. Transverse reinforcements are 60% of the main reinforcement. At midspan, at least you will get, at least at the midspan you will get 60% of the reinforcement of the main reinforcement. Understood everyone? Option C is the correct answer. Moving ahead. Now in limit state method, the failure criteria for reinforced concrete beam and column is based on, now beam and column is based on maximum principal stress, maximum principal strain, maximum shear stress and normal stress theory. What is the correct answer? So whenever, so in limit state always you remember that when a concrete or steel will be treated as failure. So this is the basic criteria. I mean, this is the basic design criteria in limit state method. Whenever you treat the concrete or steel to be failure, when the strain in the concrete reaches to 0.0035. Do you understood? Or in axial compression, what is the maximum strain? And what it is shrinkage strain? 0.0003. Yes or no? So this is a strain controlled approach. So limit state method is the failure criteria for reinforced concrete beam and column is based on which criteria? Principal strain theory, maximum principal strain theory. Maximum principal strain theory. Understood everyone? Clear? Now moving ahead, next question. Answer this question. According to IS 456, two-way slab with corner held down are assumed to be divided in each direction into middle strip and edge strip such that the width of the middle strip is. This is also very good question for two-way slab. Whenever we design the two-way slab, okay, if let us suppose this is the two-way slab, okay, and this span is nothing but LX or LY. You can assume it any of the possible. Let us suppose this is LY. So we divide this into three strip. Okay, we divide this into three strip. Okay, the middle strip and the outer strip. Okay, so what is the, you are asked with this, I'll give you the hint. This is nothing but L upon 8. This is also L upon 8. So L upon 8 of Y, Ly by 8. This is also Ly by 8. So if you add this, you will get Ly by 4. So remaining will be equal to 3 by 4 of Ly. 3 by 4 L4, yes, 3 by 4 of Ly. So this is nothing but 3 by 4 of Ly. Edge strip, middle strip. So this is nothing, this is known as middle strip. This is nothing but edge strip. This is also edge strip. So your correct answer will be 3/4 of the width of the slab. 3/4 of the width of the slab. Option C is the correct answer. I hope it is clear. Yes or no, everyone? Clear? Please put a star mark on this. This is also a very good question. I hope it is clear now. Clear everyone? Now moving ahead. Answer this question. Now, if W is the load per unit area on the circular slab, please remember this is a circular slab. Okay, this is the circular slab of radius r. Now, you are given with this radius r. This radius is r. Okay, the maximum radial moment at the center of simply supported slab. This slab is simply supported. Now, what is the bending moment in the circular slab? What is the circumferential moment? So, here in the circular slab, we will consider this moment as circumferential moment. This is given as circumferential moment in circular slab is given as, okay, radial or circumferential moment is 3w r square minus r 3w capital R square at any radius you can calculate upon 16. Okay, 16. Yes or no? And you are asked with the center. At center the radius is, small radius is 0. So you will get the value as 3w r square upon 16. So at center the value is 3w r square by 16 is option C. Please remember this formula. Only you remember the formula, not the design part. Okay, design part is not in your syllabus, but you remember the formula. So how do you calculate the circumferential moment at any radius? If let us suppose you are asked to find the circumferential moment at this portion. Okay, this portion is, let us suppose the radius is small r. So we'll get the value as 3w r square minus small r square upon 16. Here the answer is option C. Clear everyone? I hope it is clear. Yes or no? Now moving ahead, still we are left with 10 more questions. We will complete the question now. Answer this question. As per IS 456-2000, bending moment M for two-way RCC slab can be calculated using the equation bending moment My. Now you are asked with My, bending moment My. For longer span, for two-way RCC slab can be calculated using the equation. Now please remember, in two-way slab, okay, the longer span denotation is Ly and the shorter span is Lx. What is the equation? What is the equation, everyone? For longer span, this is longer span. This is shorter span. Understood? So whenever, now please remember this very carefully. Now look, here the correct answer is no. Yes, very good. Now whenever you are asked to find My, you can see very carefully My. Whenever you are asked to find the moment about the y-axis, these are the moment coefficient. Moment coefficient about the y-axis is taken, load per unit area as well as length about the x-axis is taken. Now you can see that this is the bending moment. This is a two-way slab. Okay, we are asked to find the moment about this axis. You are asked to find the moment about this axis. Whenever you are asked to find the moment about this axis, you can see this length get deflected. Yes or no? So which length will you take? The length which is perpendicular to the reference axis. This is the axis. What is the length? This is the length that you have to take. Clear everyone? I hope it is clear now. So the correct answer is option B. B for Bombay is the correct answer. Clear? Moving ahead. What are anchor bolts? What are anchor bolts? Anchor bolt, you must have studied this in steel also. Anchor bolts to resist overturning moment are used in the slab base. To resist overturning moment are used in the slab base when column carries only moment, when column carries axial load, when column carries axial load and moment, the column carries no load. You can see. Now, anchor bolts are provided. You can see whenever the column is carrying the eccentric load. The column is carrying the eccentric load. Okay. Now, because of this eccentricity, what will happen? You will shift this load to the center and a bending moment of P into E. Because of this P load, yes, because of this P load, this P load, this will give you axial compression, and because of this moment P into E, okay, because of this will give you the moment, yes or no? This will give you the moment. So whenever a column carries the axial load as well as moment, the anchor bolts are provided in slab, okay, in slab base. Option C is the correct answer. Clear? The correct answer is option C. Moving ahead, next question. Please answer this. The torsional reinforcement for corners held down in the slab provided at. Now, please answer this. Now I have already given you the hint that torsional reinforcements are not provided for continuous edges, yes or no? So whenever the edges of the slab are continuous, okay, let us suppose I'll form you the slab. Look at this slab. Let us suppose this is the slab. All the corners are continuous. You can see this corner also continues ahead, this also continues, this also continues, this also continues. All the corners are continuous. So all this slab has all the corners continuous. So for this slab no need to provide for torsional reinforcement. So it means that for discontinuous edges, for example, for this edge, you can see for this edge this is discontinuous. For discontinuous edge you need to provide the torsional reinforcement. Hence option B is the correct answer. Option B is the correct answer. So you can see for this slab all the four corners have continuous edge. For this slab you can see this edge is discontinuous, this edge is discontinuous, this edge is discontinuous, but this edge is continuous. Yes or no? Yes or no, guys? Okay. Moving ahead with the next question. Answer this. This you need to remember that. I'll give you the hint also. What is the correct answer? Please remember it. This is WL square by 12. For continuous slab, okay, the bending moment near the middle of the end span is WL square by 12. The correct answer is option C. Please answer this. Please put a star mark on this and solve the question. This concept just I have given you in this lecture only. For a continuous slab of 3 meter into 5 meter size, the minimum overall depth of slab for satisfy vertical deflection limit with mild steel. Please remember mild steel reinforcement. So the slab is 3 meter by 4 meter. The shorter span is 3 meter. Okay. Shorter span is 3 meter. The minimum overall depth. Okay. The slab by depth ratio for continuous slab is, please solve it by slab by depth ratio. What is the correct answer? Now for continuous slab, we have given you the question answer as span by effective depth ratio. This value for mild steel it is given as 40 for continuous slab, and in the question it is given as continuous slab. So what is the span by depth? So you are asked with the depth. So which span will you take, the shorter one or the longer one? The shorter one or the longer one? Please answer it. Always remember, for deflection criteria, shorter span is taken. So what is the shorter span? 3 meter or 5 meter? 3 meter means 3000 mm upon depth is equal to 40. So you'll get the answer as the effective depth has 3000 divided by 40. So this is nothing but 300 by 4 is nothing but 0.75, 75 mm. 75 mm, option D is the correct answer. Understood everyone? 75 mm, D is the correct answer. Okay, moving ahead. Last 5 question guys, last 5 question, then this chapter will be finished. The effective width of a column strip of a flat slab is taken as, the effective width of column strip of a flat slab is taken as, no, the correct, no, not 1/4. It is not 1/4. It is half of the width of the panel. It is half the width of the panel. Now moving ahead, answer this. Design of a two-way slab simply supported on edges and having no provision to prevent the corner from lifting. Okay, no provision, so the corners are not held down. Please remember, you need to design the two-way slab. You need to design the two-way slab simply supported on the edges and no provision to prevent the corner. So there is no boundary wall over the slab. It means corners are not held down. No provision to prevent the corner from lifting. Okay, so there is no provision. Corners are not held down. Okay, corners are not held down. So by which method you will design? Corners are not held in. The correct answer, no, please remember very carefully, in two-way slab, okay, when corners are not held down, okay, so this is derived by Rankine-Grashof formula, and whenever you need to design two-way slab, corners are held down. This is designed by Marcus formula. Understood everyone? Remember? Okay. Moving ahead. Answer this question. So last 3 questions are there, 36, 37, 38. 3 questions are there. Answer this. For a circular slab carrying a uniformly distributed load, the ratio of maximum negative to maximum positive radial moment. Now please remember, in circular slab, so circular slab is not so important for your examination. Why? Because in SSC JE also very less questions are asked from circular slab. Okay, so this is very least important for your RRB JE also. What is, yes, correct answer is 2. So in circular slab, what is the formula for maximum positive bending moment? Maximum positive bending moment. And what is positive radial bending moment? And maximum negative bending moment. Maximum negative bending moment. So what is the positive bending moment and negative bending moment? What is the value? Negative bending moment is 2W r square by 16. 2W small r square by 16. So what about the maximum negative bending moment? This is negative bending moment is negative bending moment. So positive is W r square by 16. So it is 2W r square by 16. So we'll take the ratio. Take the ratio of negative to positive. Negative to positive is 2. Negative to positive is 2. Yes or no? Moving ahead. Next question. Distribution reinforcement in simply supported slab is provided to distribute. Now, why we provide the distribution bars? So you can see in one-way slab, main reinforcements are provided in shorter span, but longer for distribution bars are provided in the longer span. Okay, so why the distribution bars are provided? In order to distribute the load, shrinkage stress, temperature stress, all of the above. Very, very good. Whenever you need to consider shrinkage, temperature, also they distribute the load. Hence, all the options are correct. Option D is the correct answer. All of the options are correct. Option D is the correct answer. Understood, everyone? Moving ahead. Yes. Answer this question. In two-way slab, corner steel is provided to counter. Now, why the corner steel is provided? Why the corner steel is provided? Now you can see at the corner the stresses are such high because of the at the corner torsion exists. In order to resist the torsion, as well as because of the torsion there is chances of uplifting of the corner. Hence, to restrain the corners from uplifting, the corner steels are provided. In two-way slab, corner steel is provided to counter uplift of the corner, and they also resist the torsion. Yes. So here the option C is correct answer. Now the last question is this. Corner steel is provided in slab to resist the bending moment, to make the slab sufficiently rigid to resist torsional moment, to prevent displacement of the corner. So they resist the torsional moment. Understood, everyone? They resist the torsional moment. Option C is the correct answer. Clear, everyone? Start the session. So in today's session we will be covering the good questions of column and footing. Okay, for your JEE examination, pre-stress concrete is not so important. Okay, so this is the 7th lecture. Okay, this is the 7th lecture. Oh, and rest of the topic we have covered. Okay, rest of the topic we have covered. Now in this lecture I will be covering footing and column. So please note down, if you want the PDF of this lecture, this is my Telegram channel. Scan this QR code. You will directly reach to my Telegram channel, or find ASM Live, or search ASM Live on Telegram. You will be able to find this Telegram channel, and you will get the PDF file of this lecture on this Telegram channel. Okay. So this is the 7th lecture. All the 7 PDF will be available on this Telegram channel. Whenever you want, you can revise this annotated PDF. Okay. Let's just start with the session. Shall I start? Okay, we'll start the session. This is the first question. Please answer this. This is the first question. Answer this question, everyone. Yes, very good. Look, in case of column, area of longitudinal reinforcement shall not be less than. So look very carefully. In this question, will be, just a moment. So look, yes, very good. So you can see very carefully that the minimum reinforcement, longitudinal reinforcement shall not be less than minimum. So in case of column, two provisions are there: minimum reinforcement as well as maximum reinforcement. Understood, everyone? So maximum reinforcement here is very good, 6%, and minimum reinforcement is 0.8% of gross cross section area. Please remember this, 0.8% of, here also 6% of gross cross section area. Yes or no? So hence the correct answer will be 0.8%. 0.8% of the gross cross section. This much is the minimum area of steel reinforcement required in the column, and maximum to maximum is the 6%, because if you increase the area of the steel bar by this percentage, there will be lot of congestion in the cross section of the concrete. Now moving ahead, next question. Answer this question, everyone. Answer this, just a moment. Now what is the correct answer for this question? Calculate the pitch of lateral ties. Okay, the pitch of lateral ties for a column of 300 mm square. Okay, 300 mm square. So this is a square cross section of area 300 mm into 300 mm with 20 mm dia longitudinal bar. So the main bars are of 20 mm diameter, 20 mm diameter. Okay, and 8 mm lateral ties. So diameter of lateral ties are of 8 mm. Okay, as well as the cross section area of column is 300 mm into 300 mm. It is a square cross section column. So what is the max pitch of lateral ties? Okay, very good, Vignesh. This is the correct answer. So there are three codal provision which states that, okay, least lateral dimension 16 times of the smallest dimension or 300 mm. है ना? Understood, everyone? Least lateral dimension. So the pitch of the lateral ties are 300 mm. Least lateral dimension, so it is a square, least lateral dimension is 300 mm only, and 16 times of the dia of longitudinal bar. Okay, the minimum dia of longitudinal bar. So you can see very carefully, 16 into 20 is nothing but 320 mm, as well as least lateral dimension is 300 mm and 300 mm. So minimum of this will be the answer. Hence 300 mm will be the correct answer. Minimum of the three values are to be taken. Understood, everyone? Now moving ahead with the next question. Next question is, in the design of column, the diameter of longitudinal reinforcement bar. So this is a very good question. This is a very good question. Please put a star mark on this. Okay, in the design of column, answer the question, everyone. In case of column, What will be the correct answer? The diameter of longitudinal reinforcement shall not be less than 12. Okay, be less than 16 mm, be more than 20 mm, not less than 10 mm. So in the column, the minimum reinforcement, okay, the diameter of longitudinal should not be less than, very good, should not be less than. So the minimum diameter of the bar that is used in the column is 12 mm. This you need to remember. This is a very good, very important question. In column, the minimum reinforcement is 12 mm. Understood everyone? Understood? Moving ahead, next question. So you must have analyzed in the last few lectures, we are just covering the codal provision, because in your PSC examination, in your state AE examination, only the codal provisions are very important. Okay, so you need to very focused on the codal provision, especially in steel and RCC. Now moving ahead, so spacing of longitudinal bar measured along the periphery of the column shall not exceed longitudinal bars, spacing of longitudinal bars, okay, measured along the periphery of the column shall not exceed. So this is a very good question. Let us suppose this is a circular column, okay, so these are the main reinforcement and these are the stirrups. So along the periphery, this distance should not be more than, should not exceed 300 mm, should not be more than 300 mm. So this spacing along the periphery should not be more than 300 mm. Option C is the correct answer. Understood everyone? Yes, this is the correct answer. Shall I move ahead? Moving ahead, answer this question. Answer this question. Effective length of the column whose one end is fixed and the other end is free is, effective length of column, let us suppose there is a RCC column whose one end is fixed and the other end is free. So this is the column. So you can see very carefully, if the length is L, effective length is nothing but the distance between the point of zero bending moment. Understood everyone? Point of zero bending moment. So here bending moment is 0, here bending moment is 0. So if you take the mirror image of this, if you take the mirror image of this, here also the bending moment will be 0. Yes or no? Yes or no? So the correct answer will be L or L. So 2L is the length. Understood everyone? 2L is the length. So it is greater than this length. Okay, effective length is nothing but L effective. L effective means 2 times of the L. 2 times of the L. Whose one end is fixed and the other end is free is equal to overall length, less than overall length, okay, greater than overall length. Yes, very good. So the correct answer will be greater than overall length. Option C is the correct answer. Greater than overall length. Understood everyone? Now moving ahead with the next question. Answer this. Answer this question. This is also a very good question. You need to solve the question without calculator. Please remember, you need to solve the question without calculator. Okay. Now look very carefully. How do we solve the question? Now in the cross section of column, you can see in the cross section of column there are reinforcement as well as there is a stirrup. Okay. Now this cross section will take the load P is equals to load taken by the stress in the concrete into area of concrete plus stress in the steel into area of steel. Yes or no? So area of steel is given as 1000 mm square, area of concrete is 10,000 mm square, area stress in the concrete is given. So M is modular ratio. M is defined as the stress in the steel to the stress in the concrete, stress in the steel into stress in the concrete. This is a question of WSM. So how do you get the stress in the steel? Stress in the steel is the M times of the sigma SE. M is nothing but 20. 20 into 5 is nothing but 100. 100. Yes or no? 100 Newton per mm square. So you can see very carefully, stress in the concrete is nothing but 5 Newton per mm square into area of concrete is nothing but 10,000. 10,000 plus area of stress in the steel is 100 into area of steel is nothing but 1000. Okay, to convert this into kilonewton, multiplied by 10 power minus 3. 10 power minus 3. So 1000 and 1000 is being deducted from each and every value. So 1000 value is cut it here. Also 1, 2, 3. So this is nothing but 50. This is nothing but 100. So your answer will be 150 kilonewton. 150 kilonewton. So what will be the correct answer? Option C is the correct answer. Option C is the correct answer. This is a very simple question. Without calculator, we will be able to manage to solve this question. Yes or no? Understood everyone? Shall I move ahead? Okay, moving ahead with the next question. Answer this question. What will be the correct answer? This is a very simple question. You can see the load carrying capacity of circular column with helical reinforcement. Okay, let us suppose this is a circular column. Okay, these are the reinforcement. Helical reinforcement. Helical reinforcement means this. This is the helical reinforcement. And whenever you see the top view, so top view will look like this. Top view will look like this. Yes or no? So this is how you need to analyze the question. So whenever there is a helical reinforcement, load carrying capacity increases by 5%. Load carrying capacity increases by 5%. Yes or no? Yes or no? 5% more. Yes, very good. Moving ahead. Solve this question. An axially loaded column is of 415 to 450 mm size. The effective length of the column is, so the dimension is nothing but B is and D is equal to 450 mm, as well as the effective length of column is L effective. The effective length of column is 5 meter. Effective length of column is 5 meter. What is the minimum eccentricity of the axially loaded column? So E minimum eccentricity of the axially loaded column. This question already we have covered in one of the chapter. Minimum eccentricities need to be calculated. How do you calculate? Okay, minimum eccentricity is nothing but what the maximum value of L by 500 plus D by 30 or 20 mm. L by 500 plus D upon 30 or 20 mm, whichever is maximum. So the length is, effective length is 5 meter. 5 meter means 5000 mm. 5000 mm divided by 500 plus depth is nothing but 450 divided by 30. Okay, comma 20 mm. So whichever is value is maximum. So this value is nothing but 50 and this value is nothing but 15. So 65 comma 20. 65 comma 20. So the value is you will get the value as, sorry, this is 25 or 20. Maximum value is to be taken. This is 25. I'm so sorry. 15 plus 5 is 25. 25 comma 20. So maximum value is 25. Please remember this, maximum value is to be taken. So option A is the correct answer. Option A is the correct answer. Understood everyone? Yes. So the answer will be 25. Yes or no? Understood everyone? So the maximum value of among these two values. So from here you will get 25 and from here you will get 20. So the correct answer will be 25. Please remember this, the maximum value is to be taken. Yes or no? Now moving ahead. Solve this question. Now this is a question of steel structure. Okay, this is a question of steel structure. Put a star mark on this. Generally in a column base, the shear resistance at the proper contact surface between the steel base and the concrete may be calculated using the friction coefficient of, how much friction coefficient do you consider? You consider the friction coefficient of 0.45. You consider the friction coefficient of 0.45. Please put a star mark on this. So let us suppose so there is a steel base, then we have the column, and below the steel base there is a concrete. So there is a friction between the steel base and the concrete. How much friction coefficient do you consider? 0.45. Understood? 0.45. Now next question. Answer this. The minimum area of steel in mm square to be provided in a column of size 250 into 600. So the dimension is given as 250 into 600 mm. Okay, this is the column. So if I draw this, this will be like this. Okay, this is 600 and this is 250. So for this cross section area, minimum area of steel, what is the minimum area of steel? This is the column. What is the minimum area of steel? Can you answer me? Yes, just now we have seen the minimum area of steel is 0.8% of gross cross section area. 0.8% of gross cross section area is 250 into 600. 250 into 600. Yes or no? So from here you can see very carefully that two zeros are being cancelled out. Okay, and you can see 250 into 4 times is 250 into 4 times is 100. Okay, 100 and 150 into 0.8. So you'll get the answer as, you solve this question. So your answer will be 1200 mm. 1200 mm square. So this much is the area of the steel that is to be provided in the column section. Understood everyone? Clear? Yes, moving ahead. Moving ahead, solve this question. According to IS 456, okay, minimum slenderness ratio for a short concrete column. Please remember, you are asked with the short concrete. So pedestal, short concrete and long concrete. Slenderness ratio less than 3, pedestal 3 to 12, short column. More than 12, it is long column. Yes or no? So what will be the correct answer? What will be the correct answer? So your correct answer will be less than 12. Okay, less than 12. So all the values are more than 12. Hence the correct answer will be slenderness ratio less than 3, less than equal to 3. It is pedestal. And slenderness ratio greater than 3 but less than 12. Okay, it is short column. Slenderness ratio greater than 12, long column. Moving ahead. Yes, A is the correct answer. Answer this question. And just give me 1 minute guys, I need to fill my water bottle. Just give me 1 minute. What is the correct answer for this? Yes, look. The diameter of lateral ties in a column is taken as that diameter of lateral ties 1/4 of the diameter of the largest longitudinal bar 6 mm. So greater of 1/4 times the diameter of the largest longitudinal bar or 6 mm. So here the correct answer is option C. Here the correct answer is option C. Look very carefully. This is a very important question. Please put a star mark on this, each and every student. Okay, so the diameter of lateral ties, shall not be less than 6 mm or 1/4 times of the diameter of main bar. Okay, largest longitudinal bar or 6 mm. Understood everyone? Moving ahead. So moving ahead, next question. So I have tried to cover all the aspect of the column so that you will get each and every question from these question only. The minimum thickness of the RCC footing resting on soil is given by. So this is also very important question. Whenever the RCC footing is resting on the soil, what is the minimum thickness? Also comment me, whenever the footing is resting on the piles, then what is the minimum thickness of the footing? Answer me. What is the correct answer? Very, very good. Very good. Now look very carefully. Whenever the footing is resting on the soil, look, whenever the footing is resting on the soil, so the minimum edge thickness should be equal to 150 mm. And whenever footing is resting on the pile, okay, whenever the footing is resting on the piles, minimum edge thickness is 300 mm. So this you need to remember, 300 mm. Here the footing is resting on the soil, hence option A is the correct answer. Now moving ahead with the next question. Answer me guys. Answer me this question. What will be the correct answer? Very, very important question. The correct, very, very good. The minimum clear cover in RCC column. So the clear cover, now this we are talking about RCC column and clear cover. Clear cover is nothing but greater of 40 mm, either 40 mm or diameter of reinforcement, understood? Or diameter of reinforcement, whichever is greater. Okay, whichever is greater. So maximum of two values is this. So this is the clear cover, greater of 40 mm or diameter of reinforcement, hence option A is the correct answer. Understood everyone? Option A is the correct answer. Yes, very, very good. So the next question is this. Answer this. A helically reinforced column of 300 mm diameter has 6 bars of 24 mm diameter, has longitudinal reinforcement provided an effective cover of 60 mm and spiral of 8 mm. Diameter provided at clear cover of 40 mm. The core diameter of this column is very, very important question. You are asked about the core diameter. Okay. Now what is given in the question? a helically reinforced column of 300 mm diameter. So the column diameter is nothing but this is given in the question. This diameter is 300 mm. This diameter is 300 mm. This is given in the question. Okay, has reinforced column of 300 diameter, has 6 bars of 24 mm diameter as longitudinal reinforcement, as an effective cover of 60 mm. Okay, so 6 bars are there. So 1 bar, 2 bar, 3 bar, 4 bar, as well as 5 bar and 6 bar. So 6 bars are there. Okay, clear cover of 60 mm, spiral of 8 mm. Okay, and spiral of 8 mm is also provided. So this diameter is 8 mm. This diameter is 8 mm. This diameter is 8 mm. Understood everyone? Spiral diameter is 8 mm. As well as the 6, 1, 2, 3, 4, 5, 6. So 6 bars are there. Okay, 24 mm diameter. So these bars are of 24 mm diameter. These are the main bars. Okay. Spiral of 8 mm. Diameter provided at clear cover of 40 mm. Clear cover of 40 mm. The core diameter of the column is. Please answer this. You are asked to find the core diameter. How will you solve the question? You can see very carefully. This is 300 mm and you can see the clear cover is of 40 mm. So clear cover, you are asked to find this length. Please look very carefully. You are asked to find this length. This is the core diameter. Now you can see total length is 300. Total length is 300 and a clear cover of 40 mm is there. This is also 40 mm. This is also 40 mm. So you can see very carefully. This is 40 mm and this is also 40 mm. So in 300 mm, if you subtract 2 times of 40 mm, you will get the answer as 80, 220. The core diameter is 220 mm. Option B is the correct answer. Understood everyone? Yes or no? Are you getting my point? Yes or no? So clear cover is 40 mm. So diameter of the core is nothing but 300 minus 80. That is 220. Now moving ahead. Answer this question. In reinforced concrete, pedestal is defined as compression member whose effective length does not exceed its lead. So slenderness ratio is less than 3. Is less than equal to 3. Okay. So least lateral slenderness effective length upon least lateral dimension. Least lateral dimension. It should be less than 3. So you can see very carefully. Pedestal defined as a compression member whose effective length does not exceed. So does not exceed 3 times of the least lateral dimension. Hence the correct answer is option B is the correct answer. I hope it is clear. Yes or no? Okay, moving ahead. Moving ahead with the next question. Answer this. Answer this question. The critical section for computing maximum bending moment for the design of isolated footing. So you can see very carefully. I will show you the isolated footing. This is an isolated footing. Okay. So and the top view is looks like this. Top view is look like something like this. Something like this. So this is the top view and this is the cross section. This is cross section view and this is top view. Okay. The critical section for computing maximum bending moment for the design of isolated footing supporting a concrete column is consider D as the distance between the column face and the footing edge. So you can see very carefully this distance is nothing but D. This distance is D. So now at the face of the, now for critical section for bending moment, yes, very very good. So the face of the column is considered at, so at this point, we get the maximum bending moment. So at the face of the column we get the maximum bending moment. Option A is the correct answer. This is not the check for two-way or one-way shear. This is the bending moment. So we'll get the maximum bending moment at the face of the column. Option A is the correct answer. Yes or no? Understood everyone? Now moving ahead with the next question. Answer this question everyone. What is the minimum number of longitudinal bar provided in reinforced concrete column of circular cross section? Please answer if the cross section is square or rectangle, and if the cross section is circular. Okay, so minimum number of reinforcement. What is the minimum number of reinforcement? Minimum number of reinforcement. For square or rectangular column it is 4, and for circular column it is 6. Okay, 6 number of reinforcement bar is provided when the column cross section is circular. Understood everyone? 6 is the correct answer. Now moving ahead. Yes, for one way shear D from the face of the column, for two way shear D by 2 from the face of the column. Very very good Vignesh. Okay, very very good. So, but in the previous question it was asked about the bending moment. Okay, so that is why face of the column is the correct answer. Now moving ahead, answer this question. The pitch of lateral ties in RCC column should not exceed. Pitch of lateral ties in RCC column should not exceed. Answer this question. Pitch of lateral ties in RCC column should not exceed the least lateral dimension. Okay, least lateral dimension 16 times of the diameter of main bars. Okay, main longitudinal bars, or 300 mm. Okay, should not exceed least lateral dimension. Just now we have seen the question. So pitch of the lateral ties should not be more than of all the values. So all the above. Option D is the correct answer. Understood everyone? Moving ahead, next question. Answer this question. In the case of column of minimum dimension of 200 mm or under, whose reinforcing bar does not exceed 12 mm, a nominal cover may be provided. So very important question. How much is the nominal cover that you provide in this case when the diameter is not more than 12 mm? So again a very good question. Now very very good Vignesh, very very good. So whenever you see that in case of column of minimum dimension of 200, whenever the dimension of column is 200 mm or under, okay, and when you are using the diameter of the bar as 12 mm, you can see the clear cover here in this case is not 40 mm. The clear cover here in this case is 25 mm. Clear cover in this case here is 25 mm. Hence option B is the correct answer. Option B is the correct answer. Understood everyone? Now moving ahead. Answer this question. Answer this question. A square column of section. So it is a square column, 350 mm size, 350 mm into 350 mm. Okay, 350 mm into 350 mm. So this is also a very good question. Okay, very good question. Okay, is 4 bars of 25. So the main bars is of 25 mm diameter. 25 mm diameter. 4 bars of 25 mm diameter and 4 bars of 16 mm diameter. So the okay. The transverse reinforcement, so you can see very carefully the transverse reinforcement. Okay, the dia of transverse reinforcement shall not be less than 1/4 times of the main reinforcement as well as 6 mm. 6 mm. So what will be the correct answer? 1/4 times of the minimum of these two is nothing but 25, okay, or 6 mm, and the spacing is nothing but least lateral dimension 16 times of the dia of the main bars as well as 300 mm. So you want, now in order to remember this, you want the diameter to be maximum but you want the spacing to be minimum. So 16 times of the diameter of the main bar, so main bars is of 16 mm as well as 25 mm. So least lateral dimension is 350, here it is 300. Okay, you want spacing to be minimum. So if you want minimum, so here you take the minimum of this value, that is 16 into 16, yes or no, and you want diameter to be maximum, so 25/4 or 6 mm. So you'll get the answer. Maximum of this bar. So 25/4 is nothing but, so here you can see 7. So here you can see it is more than 6. It is more than 6. So you'll select the option which is more than 6. So only one option is there, this one and this one. So here the spacing will be minimum of this value. So 300 mm is the correct answer. Option B is the correct answer. Option B is the correct answer. 8 mm and 300 mm. Okay, 8 mm and 300 mm. Clear everyone? Clear? So 300 mm and 8 mm is the correct answer. Moving ahead. As per IS 456-2000, the minimum nominal cover specified for the footing is. So the footing for nominal cover for footing. Answer this question. Nominal cover for footing is. Answer this question. So what is the nominal cover specified for footing? So for footing it is 50 mm. Very, very good. So for nominal cover for footing, so you can see very carefully nominal cover for footing. Nominal cover for footing. It is nothing but 50 mm. So you'll get the answer as 50 mm. Option C is the correct answer. Understood everyone? Okay, moving ahead. Please answer this question. For a square reinforced concrete RC column with cross section of 300 into 300 mm having an effective length of 2500 mm, determine the minimum eccentricity. So minimum eccentricity, just now we have seen L upon 500 plus least lateral dimension upon 30 or 20 mm, whichever is minimum. So the length is nothing but 2500 divided by 500, that is 5, plus least lateral dimension is nothing but 300 mm divided by 30. So you can see very carefully, this is 5 and this is 30. So this is 35 and minimum of 20. So the minimum eccentricity is 35, 20. So answer me, what will be the correct answer? What will be the correct answer? So greater value is taken. Just a moment. So this is 5. Okay, this is 10. I'm so sorry. This is 10. 15, 20. 15, 20. So greater value is taken. Maximum value is taken. Hence the correct option will be 20 mm. Option C is the correct answer. Yes, for flat slab is it? Yes, very, very good. Yes, Vignesh. For normal slab it is 20 mm. Understood? So here we'll get the value as minimum eccentricity as, okay, minimum eccentricity as 20 mm. So maximum value is to be taken. Moving ahead. Answer this question. Answer this question. This is a question of footing. Answer this. Determine the plan area of the footing carrying a load of, so on the column, the footing, the load is coming out to be 1500 kilonewton. 1500 kilonewton from 300 mm square column. So here the column size is 300 mm square column, okay, containing 20 mm diameter bar. So the bars contain 20 mm diameter bar. Yes or no? Longitudinal, see the safe bearing capacity of the soil. So you can see very carefully, okay, 120 kilonewton per meter square, 1 meter square area resist. So for 120 kilonewton you need the footing of area 1 meter square, okay. So for 1 kilonewton you need the area as 1 upon 120. For 1500 kilonewton you need the area to be 1500 divided by 120. So you'll get the answer as 150 divided by 12, that is equal to, okay, 4 divided by 50, so that is 5. If it is 50 divided by 4, 50 divided by 4 means 25 by 2, 12.5 meter square is the correct answer. 12.5 meter square is the correct answer. Yes or no? Please look, by just unitary method we have solved this question. Just by applying the unitary method we will be able to solve this question. Yes or no? Understood everyone? Okay, moving ahead. Next question. Answer this question. Answer this. Determine the minimum and maximum longitudinal reinforcement. Minimum and maximum longitudinal reinforcement for a square column of size 300 into 300 mm having clear cover of 20 mm. So you can see the minimum reinforcement, the minimum area of reinforcement. Minimum area of reinforcement is nothing but, minimum area of reinforcement is calculated as, minimum area is nothing but 0.8% of the gross cross section area. So gross cross section area is 300 into 300 mm. Yes or no? So this is nothing but 900. So this is 720 mm square. So you have eliminated option A and B, and the maximum reinforcement is, it is nothing but, this is 0.8%, 6% of gross cross section area. Yes or no? So this is nothing but 5400 mm square. 5400 mm square is option D. So this is nothing but 5400 mm square. So this is the maximum area and this is the minimum area. Clear everyone? Understood? Shall I move ahead? Moving ahead. Answer. The purpose of lateral ties in a short RC column is to. Now please remember, in this question you are asked with lateral ties as well as for short column. Okay. So what are the purpose of lateral ties in short reinforced concrete column? Option is avoid buckling of longitudinal bar, facilitate construction, facilitate compaction of concrete, increase the load carrying capacity of the column. So very good question. So why we use the lateral ties? In the question also it is given ties. So ties means something which can bind. So I'll show you the diagram. You can see very carefully. And you can see these are the longitudinal bar and these are the lateral ties. You can see these are the lateral ties. Yes or no? So the main bar does not buckle. So the lateral ties holds the buckling of the main longitudinal bar. Hence option avoid buckling of the longitudinal bar. Option A is the correct answer. No. The main purpose of longitudinal ties is not to take the load. It does not design to take the load, but rather it is designed such that the buckling of the longitudinal bars are prevented. So this is the main reason. Please put a star mark on this. Arun Kumar, yes, this is the correct answer. Option A is the correct answer. Understood everyone? Clear? Please put a star mark on this. Understood? Shall I move ahead? Now next question. Next question. So next question is this. Okay, this is also a good question. You need to apply the formula in order to solve this question. Please apply the formula for question number 27. Okay, you are confused about the okay, just a moment. Now you can see whether it is a short column or long column. If it is a short column also, you can see very carefully. Now your doubt is very good, but sir, it is given a short column. Okay, short column. Even though it is a short column, the purpose of lateral ties is to hold the main bars in position. Understood everyone? Understood? Loss due to relaxation. Now you can see very carefully. हम स्टील को क्या करते हैं? स्ट्रेस करते हैं. हम स्टील को स्ट्रेस करते हैं, टॉर्जन देते हैं. ठीक है, हम जब स्टील को स्ट्रेस देते हैं, अब देखो ना, स्टील का द स्ट्रेस स्ट्रेन डायग्राम फॉर स्टील इज दिस. So at yield plateau there is a large strain. In order to avoid this large strain, we stress the steel and then we release the load. So whenever we release the load, this much is the plastic strain is induced in the steel, and some stresses are also induced in the steel. Over the period of time, this stress releases. So that is known as relaxation. Understood? Even though it is a short column, Vignesh, even though it is a short column, the main purpose of lateral ties is not to increase the load, but rather it is there to hold the position of the main bars. Understood? Because a column is a compression member. Okay, column is a compression member. So they do not displace from their own position. That is why they are given. Now moving ahead. Answer this question. I'll give you the hint. I'll give you the formula for this. Then you apply the equation. Answer this. So what is the depth of the footing as per Rankine formula? Depth of footing as per Rankine formula. Depth of footing as per Rankine formula. So depth is given as P upon gamma 1 minus sin phi upon 1 plus sin phi. Friction angle is this. So this is the depth of the footing. Okay, 230 mm brick masonry wall is to be provided with reinforced concrete footing on site, having soil with safe bearing capacity of 125 kilonewton per meter square, unit weight of 17.5 kilonewton per meter square, and angle of shearing resistance is 30 degree. Depth of footing. Okay, depth of footing. So you can see very carefully, friction angle is given. So 1 minus sin 30 degree upon 1 plus sine 30 degrees. So you can see 30 degrees is very simple, sine of 30 degrees is very simple. What is P upon Y? This safe bearing capacity as well as unit weight. So you can see very carefully the question, in the question it is given as safe bearing capacity is 125 kilonewton per meter square, and what is the unit weight? Unit weight is nothing but 17.5. So dimension wise this will comes out to be in meter. Okay, so you can see 125. What is sine 30? Half. 1 minus half is 0.5. 0.5 upon 17.5. 17.5 into half, sine 30 is half, so 1.5. 1.5. Yes or no? Clear everyone? So what will be the correct answer? So square of this is also there. Yeah, I'm so sorry. Square. So you can see 0.5 upon 1.5 square. So you solve the answer, you'll get the answer in meter. So on solving, you'll get the values as 0.8 meter. So minimum of 0.8 meter depth is required in this case. Yes, Q upon gamma. Yes, instead of Q I have taken P. That signifies the safe bearing capacity. Understood? Moving ahead. Answer this question. Answer this question. Now you can use the virtual calculator for this question. You are allowed to use virtual calculator in this case. Shall I solve the question? Now look, a circular column is subjected to unfactored load of 1600 kilonewton. So a circular column, so what is the unfactored load of 1600 kilonewton? Okay, so this is given in the question. As well as the effective length of the column is, 3.5 meter. The concrete is M25 and area of steel is nothing but area of steel in ASC, and the value of this ratio ASC upon AG is equals to 2%. Okay, what is the area of steel in concrete? That is 2% of gross area. So what is the area of concrete? That is 98% of gross area. 98% of gross area, which is given in the question for Fe415 steel. Okay, design diameter of the column will be, so load is given. We know the formula. Design load, design diameter of the column. So what is the formula for load? So unfactored load is given as 1600 kilo. So what is the factored load? Factored load is 1.5 into 1600. Okay, so what is the formula? Pu is equals to, what is the load carrying capacity of column? Pu is nothing but, we get the formula as 0.4 times of 40% of FCK into area of concrete plus 0.67 Fy into area of steel in compression. Yes or no? Fy into area of compression. So from here you will get the value as 60%. 50% if you increases, it will be 2400 kilonewton is equals to 0.4 into FCK. FCK is given as M25. What is the area of concrete? Area of concrete is 98% of gross area plus what is 0.67, yield stress is nothing but 415. 415 into, that is 2% of gross area. Yes or no? 2% of gross area. So this is the equation of gross area. What is gross area? Pi by 4 into d square. So in order to convert this in kilonewton, you convert this in Newton. Okay, convert this in Newton, 2400. So the equation will look like this. This equation will look like this: 2400 into 10 power 3 is equal to 0.4 into FCK is nothing but FCK value is M25 into 0.98 into pi by 4 into capital D square plus 0.67 into 415 into 0.02 into pi by 4 into capital D square. So this is the equation in D. You will get the value D in mm. You will get the value D in mm. So whenever you solve the question, it will be 446. You solve the question, you will get the value as 446. Just try to solve this equation. No, Vignesh, this is clear. So you solve the equation, you just by virtual calculator you need to solve the equation. So these questions are deliberately given, okay, so that you can consume time. Shall we move ahead? Have you understood the concept? Apart from calculation part, have you understood the concept? Yes or no? Have you understood the concept? Yes or no? Please tell me. Shall I move ahead? Okay, moving ahead. Similar question, a kind of similar question, but only twist is here. Look very carefully. The ultimate load carrying capacity of a short circular column of 300 mm diameter with 1% helical reinforcement of Fe415 grade steel and concrete M20 grade is nearly Fe415. Please change it to Fe415. A kind of similar question. So whenever helical reinforcements are given, load carrying capacity increases by 5%. So whenever you need to increase something by 5%, 1.05, 40% of FCK into area of concrete, okay, plus 0.67 Fy into area of steel in compression. So this is the formula that you need to apply. Answer me, guys. So you can use the virtual calculator. The ultimate load carrying capacity of short circular column 300 mm diameter. So what is the gross area? Gross area is nothing but pi by 4 into 300 square with 1% of helical. Now what is the reinforcement? Reinforcement here is nothing but 1%. So how about the area of concrete? That is 99%. Yes or no? That is 99%. So you can see area of concrete is nothing but 99% of gross cross section area, 99% of pi by 4 into 300 square. And what is the area of steel? Area of steel is nothing but 1% of pi by 4 into 300 square. Okay, so this is given in the question. So you can solve. The equation will comes out to be, what is the load carrying capacity? PU. PU is nothing but 1.05. So here 0.40 into FCK. What is the grade of the concrete? That is 20 into area of steel, area of concrete, that is 99. 0.99 of pi by 4 into 300 square. Okay, as well as plus 0.67. What is the area of steel? That is 4. What is the grade of the steel? 0.415 into that is the area of the steel in area of steel in compression is nothing but 0.01. 0.01 into pi by 4 into 300 square. You convert this in kilonewton multiplied by 10 power minus 3. So from here you will get the answer as 794 kilonewton. 794 kilonewton. Okay, this is the equation that you need to solve. 794 is option D. Okay, deliberately this is given. Why? Because you will commit the mistake, you will consume the time. You will not commit the mistake because it is a simple calculation, but by the help of virtual calculator it takes a lot of time to solve these questions. So these questions are to be solved at the last, whenever you complete the paper. So these questions are to be solved at the last by the help of virtual calculator. Understood everyone? Understood? So a similar question, again I'll give you a similar question. So two concepts I have given. Okay, in one of the question no helical reinforcement, in second question there is a helical reinforcement, in the third question there is a concentric load. So apply the concept, apply the concept. Apply the concept. Again this is a very good question. Okay, I'll solve the question, don't worry. Now in this question, a certain RC short column with 300 mm square cross section is made of. So this is a square cross section, 300 mm 300 mm. Okay, square cross section, grade of concrete is M20. So what is the area of steel? Area of steel is 415. So grade is Fe 415. What is area of steel in compression? That is 4 bars of 20 mm diameter. Yes or no? Concentric. This is a concentric axial compression load. Please remember, concentric axial load, ignoring the reduction in the area of concrete due to steel bar. So in the question, what is the area of concrete? Because there is no reduction, the gross area is nothing but the area of concrete. What is the gross area? Gross area is nothing but 300 into 300. 300 into 300. So this is given in the question. As per the question, we are solving the question. Okay, the ultimate load carrying capacity of the column by the relevant code is. So you can see what is the load carrying capacity here. You can see the answer will be nothing but, so it is a concentric load. So this is nothing but 0.45 FCK into area of concrete plus 0.65. So 0.45 into, sorry, 0.75 into Fi into area of steel. So you can see the 0.45. What is the grade of concrete? Grade of concrete is 20. What is the area of concrete? Area of concrete is given as 300 into 300. 300 into 300 plus 0.75 into, what is the grade of the steel? That is 415. What is the area of steel? 4 times of pi by 4. What is the diameter? 20. So in order to convert this in kilonewton, multiplied by 10 power minus 3. So you'll get the answer in kilonewton. So this is just the equation. So whenever you solve this question, the answer is 1201 kilonewton. Option B is the correct answer. Have you understood the concept? Yes or no? Is it clear? I hope it is clear. Yes or no? Now, look, as per IES code, why we have changed the formula? In the previous question, whenever we design the load carrying capacity of the column, we consider the column to be designed to be minimum eccentricity. But here we are designing the column with no eccentricity, the concentric axial compression. So whenever there is a concentric load in the column, the load carrying capacity, the formula is this one. Understood, Vignesh? And if nothing is given in the equation, we always consider the load carrying capacity or the column to be minimum eccentricity. That is why we have applied this formula. Good afternoon, Sachin. Understood? Yes or no? Please remember this point. Okay. Okay, we will take last 10 question for column and footing. Then this chapter will be finished. Okay, moving ahead. Apply the logic. What is the correct answer? So what is the correct answer? The correct answer for this question is yes, very good. In an isolated reinforced concrete footing of effective depth D, you can see very carefully. Look, this is the footing. This is the footing of effective depth D. Okay, the stress in punching shear is checked. So what is punching shear? Yes, very good. So it is a two-way shear. Okay, it is a two-way shear, punching shear. So okay, so whenever you can see, this is the plan, this is the plan. So punching shear means the column will punch into the footing. Okay, so this is the cross section. So at all the faces, from all the faces at D by 2, from all the faces of D by 2, we will check for punching shear. So at this cross section, the punching shear is maximum at a distance D by 2 away from the face of the column. Okay, from the face of the column, please understood, from the face of the column. As you can see, I have shown you the in diagram also from the face of the column. Okay, moving ahead. Correct answer is, what is the correct answer for this question? Yes, that is a two-way shear. Very good. So what is the correct answer? Again, this is a very simple question. The effective length of circular electric pole of length L and constant diameter erected on ground. So this is a electric pole of circular diameter and erected on the ground. The effective length of circular electric pole of length L and constant diameter. So this is length L and the diameter is D. Okay, erected on the ground. So what is the effective length? You can see very carefully. So one end is free, another end is fixed. So the correct answer will be effective length is nothing but 2 times of the length. 2 times of the length. Understood, everyone? So the correct answer will be D. Yes or no? This is very simple question. Next question. Answer this question. Answer this question and put a star mark on this. I'll find this question very important for your upcoming examination. Okay, a reduction factor CR to the load carrying capacity of long column. So whenever there is a long column fails by buckling. So what is the reduction factor? What is the reduction factor that we apply? 1.25 minus LE upon 24B. Effective length is LE. 1 minus LE upon 48B. 1.25 minus LE upon 48B. So this is just by observation. LE upon 48B is the correct. Okay, how about 1.25 and 1.5? So what is the correct answer for this? Answer me. Answer me yes, very good. So from here from the logic you can apply that in most of the equation, in most of the option LE by 48B is there, so LE upon 24B will not be there. Whenever you look at this side, so in most of the option you will see 1.25, so most probably, so from the random guess you can say that the correct answer is option C. So the reduction formula is nothing but 1.25 minus LE upon 48B. Just so every time this does not hold good, but here just by observation, if you want to take the hit and try, okay, then you can see the options are framed in such a way that LE upon 48B is on the maximum option, so most probably LE upon 48B, but on the left hand side you can see 1/25 is on in major on in maximum option, so most probably your option will be 1.25 minus LE upon 48B. It is just a random guess to take the options. Understood? Shall I move ahead? Okay, this is the least lateral dimension. This is least lateral. This B is nothing but least lateral dimension. Okay. Answer me. This formula we have applied in this today's class only. This formula we have applied in today's class only. What will be the correct answer? So W is the weight per unit volume, P is the safe bearing capacity, and phi is the angle of repose, okay, of the soil retained by the retaining wall. The minimum depth of the foundation to be calculated as, so minimum depth of the formula is given by the Rankine formula. This is given by Rankine formula. So as per Rankine formula, what is the depth? So that is Q or P, whatever you want to state, that is P upon W. Okay, W is nothing but gamma. Gamma is nothing but unit weight of the soil. Gamma is nothing but the unit weight of the soil as it is given in the question. W is the weight per unit volume, or here W is weight per unit volume, 1 minus sin phi upon 1 plus sin phi square. So what is the correct option? Option A is the correct answer. This we have solved the question also on this. Yes or no? Now moving ahead. Next question. Again it is a very simple question and last 5 question for this chapter. Recommended value of effective length L0 of a long RCC column, okay, as compared to the actual length L, effectively held in position and restrained against rotation at both the end. So whenever the column is effectively held in position and restrained against rotation, it means both the end is fixed. So in both the end is fixed by on applying the load. Whenever the load is applied, this is the bending criteria. So you can see distance between the point of zero bending moment is this much. Yes or no? So 50% of the L, but as per IS code 50% of the L, but as per IS the theoretical value is, theoretical length is nothing but 50% of the length, but as per IS code we take this value as 0.65 times of the L. Yes or no? 0.65 times of the L. Option D is the correct answer. The code states that there is no 100% fixity at the support. Okay, that is why some more length will also get deflected. Hence, we'll take the greater length, 65% of the length. Yes or no? Now moving ahead. Next question. Answer this question, everyone. As per IS 45, the minimum cover to be for column. Just now we have seen for column and for footing. What is the minimum cover? What is the minimum cover? So two cover we have seen. If the diameter is 12 mm and if the diameter is more than 12 mm. So what is the cover? Minimum cover for column. Minimum cover to column. To column is nothing but 40 mm. So this is given as 40 mm. Yes or no? So your answer will be option B. B is the correct answer. Yes or no, guys? Okay. B for Bahubali. Yes, B for Bahubali is the correct answer. Okay. But if the diameter is of 12 mm, then we would have been chosen 25 mm. Okay. Yes. Now less than 12 means, now Sachin, the minimum diameter to be used in column is 12 mm. So it means that that 25 mm is applicable only for 12 mm diameter. Okay. Now moving ahead. Answer this question. An RCC column of 4 meter length is rigidly connected to the slab and to the foundation. Its cross section is, it is a square column of 400 into 400 mm. Okay, it is a square column of 400 into, the column will be behave as long column, short column. So you first find out the slenderness ratio. Slenderness ratio is effective length upon least lateral dimension. Least lateral dimension. So you can see here both the dimension are for 400 mm. So what is the effective length? So column length is 400, that is 4 meter. 4 meter means 4000 mm upon 400. So this value is 10. So you can see very carefully, this value is more than 3. This value is more than 3 and less than 12. This value is more than 3. Lambda is more than 3 but less than 12. Yes or no? So it is a short column or long column? It is a short column or long column? Answer me guys. So it is a short column. Understood everyone? Yes or no? If this value comes out to be less than 3, it is a pedestal. If its value is greater than 12, it is a long column. Okay. Moving ahead. So last 3 questions. Answer this. If in any given plane, one end of the column is unrestrained and its supported length L shall not exceed. Okay, so again consider this as to be a cantilever beam. If in any given plane, one end of the column is unrestrained and its unsupported length is L, shall not exceed. Unsupported length shall not exceed. So what will be the correct answer? In order to prevent from buckling, the unsupported length shall not be less than, very good, 100 b square by d. It should not exceed 100 b square by d. Yes, option B is the correct answer. Understood everyone? Moving ahead. Again, this is a very good question. Reduction factor for RC column. Now you can see effective length to least lateral dimension is given as 24. It is a long column. So for long column, you know that what is the reduction factor? Just now we have seen CR is nothing but 1.25 minus effective length upon 48 times of the least lateral dimension. Yes or no? L effective upon 48 times of the least lateral dimension. So you can see this is given as, what will be the correct answer? No need to solve the question. 1.25 minus effective length upon B is given as 24. So 24 divided by 48. So it is nothing but this value is 0.5. So in 1.25 subtract 0.5. So you'll get the answer. Very good question. Okay. The data are given in such a way that without calculator you will be able to solve the question. Yes or no? Yes or no everyone? So the correct answer is here is option D. Option D is the correct answer. So last question for today's class. Okay. Last question for today's class is this. So what is the critical section for bending? What is the critical section for bending in footing should be considered? So in footing, you can see very carefully, this is the footing. Okay, the depth is D. Okay, this is the face of the column, and if I draw the plan, it look like this. Very good. So for bending, yes, for bending, this section have the maximum bending at the face of the column. So this section at the face of the column, at this section we get the maximum bending moments. Hence the option C is the correct answer. Understood everyone? So this is it guys, this is it for today's class. I hope you have enjoyed the question for column and footing. I have tried to cover each and every aspect of this chapter. Okay. Vignesh, physics and chemistry. Okay, I'll try to take physics and chemistry. My team is working on making the PPTs for physics and chemistry. I mean, I'm not pretty sure that I'll be able to complete this before RRB JEE, but yes, we are working on it. We are working on it so that because physics and chemistry and biology are considered in examinations like RRB JEE and SSC JEE. Okay, I'm not pretty sure, but yes, I'll try to take physics and chemistry. I'll give my 100% to cover the PPTs, to make the PPTs, because we are making the animated PPTs. Okay, so it takes a lot of time for me as well as for my team also to work on it. I hope this is clear. We have taken very good questions of RCC. Trust me guys, it takes me around 1.5 months to frame such questions. So I have taken from reference from so many books. Then I'll be able to make such questions. Understood? And you can see smartly we have covered all the concepts of RCC for beam, slab, column, and as well as design consideration. Clear everyone? So this is it from my side. Okay. So so few days are left for your RRB JEE examination. I'll suggest you to be patient and be calm. Okay. So most of the student gets, I mean, in the last moment, most of the student get confused. So you need to be very clear about your mission as well as clear about your planning. So in last few days, what you have to revise and how much time you have to devote for your revision for different subjects. So this is how. Make a clear plan for last moment and please don't get panic in the last moment. Understood everyone? So thank you so much guys for joining in this session. If it is possible for you to please share these sessions among your friends so that they also get benefited. And all the lectures of these RCC sessions are in English. So South Indian student also get benefited from it. Please share it to your juniors so that they can get the quality questions of RCC. Thank you so much guys for joining. Thank you so much. Bye bye everyone and good luck for your examination.